Hey everyone, just to let me know, am I audible? I think I'm audible. Hey everyone, welcome back, welcome, vanakkam, suswagatam. This is your Baba HSP. Today we are going to start, yes, with Isomerism, the most important chapter. But before I say something, I would like to see that, am I audible and visible to all of you kids? Yes. If yes, I want to see green signal, my dear students. How's the Josh? Everyone, do let me know. I can see the green signal, green hearts, along with fire also. If Josh is really high, if your Josh is really high, I want to see some fire in the chat section. Good evening, very, very good evening. Jo bole so nihal, sastrikal, walaikum salam, assalamu alaikum. This is your Baba HSP and all HSPN army. Where are you? I want to see full Josh in the chat section. Then only I will talk to you. Then only I will say few words, my dear friends. Yes. The Josh is really very high. I can see the green hearts along with fire. Most welcome to all my dear friends. I'm your Baba HSP. No need to tell you again and again who is Baba HSP. You know very well. Those who don't know, they have to focus on the studies. Then they will come to know that who is Baba HSP. Wow, mind-blowing. The chat is running very fast and really Baba is enjoying. Baba is getting energy from your chats. My dear friends, so many students, but why? Likes are less. I will not say smash the like button, but you are supposed to hit the like button. I want to see likes should go on, should move on. That is your attendance. If you're thinking just sitting and not speaking, not doing anything, that's not good, kids. I want to see likes should get increased. Whatever the number of students are there, at least those many likes should be there. Yes, fast, kids, what are you doing? Let me count, kids. This is bad. That means once I am going to teach and I am asking the answer, you will not participate in that. This is indicating that you will not participate in the quizzes, in the questions. If the likes are not that much, that means yes, increasing. Hey, fast. I want to see the speed like bullet fired. I want to see kids one now. Once again, welcome, vanakkam, suswagatam. But still, everyone is not participating. Kids, what is this? From the internal core of my heart, kids, mark your attendance. Now, after that, let me tell you a little bit about Unacademy Store Festival. Do you know about Unacademy Store Festival? Unacademy Store Festival, flat 50% off on all store subscriptions, starting only with rupees 999, kids. 999, valid till September 2222, kids. If you want to get maximum advantage, maximum benefit, then kids, you can tell this thing to everyone, that your friends, your classmates, your relatives, they can get benefited with this, kids. Now, after this, your team C, Phoenix Pro Batch NEET 2.025 by Team Avengers. This is Team Avengers. And after applying code, which code? Baba HSP, but the code name is, what is the name of the code, kids? Anyone in the chat section, from the chat section, who is going to tell me what is Baba HSP's code. Yes, kids. What is Baba HSP's code? I want to see if you know that what is the code. Anyone in the chat section to get mentorship along with huge discount, apply code HSP10. This is the code, and you will get this badge just for rupees 2,499. My dear student, whatever the price is there, but after applying this code, it is available just for rupees 2,499. Each and everything you are going to get over here in this batch, the best team, kids. And what I'm saying, this whole team is over here, huge team, kids. Respect for each and everyone. You apply this code. If you want Hindi batch, you will get Hindi batch. If you want Avengers batch, totally in English, you will get that. Okay, kids? Fantastic. Say yes. I want to see Nitishan, Ananya. Wow, everyone, they know Baba. Baba 10. No, Sanjana, it's not Baba 10. Baba is famous, but the code is not Baba 10. It is HSP 10. What is the code? HSP 10. HSP10. It's not Baba 10. Okay, kids? Now, kids, use me. Just see. Get ready for NEET UG 2025-2026 with Unacademy All India Test Series. My dear students, test series price is just for rupees 1,999. All India Test Series NEET UG Nimbus batch. This is for class 11th. You can see Nimbus. Nurture Nimbus batch, class 11th, 1,999, and this is Phoenix droppers. That means class 12th appearing or 13 Dreamer droppers, and the price is same 1,999, kids. But this is valid just up to September 22. September 22. Are you able to understand what I am telling you, kids? Thank you. Now, kids, the last lecture of periodic table, I have already shared the PDF to each and everyone. Yes or no? If yes, I want to see yes, thumbs up in the chat section. If yes, I want to see thumbs up. If everyone got those lovely slides, lovely beautiful slides, if you got. Now this is AIATS, All India Avengers Test Series for NEET UG 2025, only for rupees 999. You know, your lovely Wasim sir, the handsome, the Thalaiba, the great Wasim, you know. Now, Sachin, Neha. Now, what is over here? Sachin and Neha. You and Sat, you know very well, Unacademy National Scholarship and Aptitude Test 2024, class 6 to 10th, and your brother and sister, you know, the relatives, number of people are there. They are small kids. You can tell them, you can help. If you are helping others, Almighty God is going to help you a lot, kids. Now, this UN Sat, Pratham Kumar, you know very well. Now, my dear students, this is valid. Flat 50% off on all store subscriptions. Already I've told you. Now let's set go. Let's start. Sim. Come on. Now, first I will tell you how to divide, how to classify. Number of times you must have studied classification of isomerism. Today I will tell you from my side. Just see. But you have to make a promise. Before I start, this is your Baba HSP. I've done my MTech in 2004, but before MTech, in 99, I am gold medalist, MSc gold medalist, MSc chemistry, then JRF GATE, and then MTech. Produce ranks that you know from the first lecture. If you're new, you can see the first lecture, that is periodic table, AIR 1, AIMS 3, AIMS 4, number of ranks with mass selection. Giving rank doesn't mean that I am a good teacher. If you are getting 350 marks and we means as a team, our team, Ambika ma'am for bio, the great teacher, Yava sir for physics, and Thalaiba, Wasim sir and me. My dear students, 2 teachers for chemistry, Wasim sir and Baba HSP, ma'am, bio, geology and botany, the great teacher, and Yava sir, physics great teacher. My dear students, if you have got in your previous NEET 350 marks, 340 marks, 300 marks, and now with our team, with the help of we people, the positive catalyst, you are going to get 700 marks, 680 marks, 710, 715, 720 marks. Then we will say, yes, we have done something. Then we will take the credit that, yes, this is because of this team, your help, your parents' help, and the hard work, my dear students. Am I right? Am I right or not? Yes, I'm 100% correct. Now, my dear students, before I move ahead, let me tell you how to classify, because this is the thing from where isomerism starts, but we don't know anything. We are not having that much of knowledge what actually is isomerism. If I say, just if you want to see isomers, are you ready? Now, full and final, I want to see fire in the chat section. If everyone is ready with full josh, let me see the chat section. If everyone is ready with full josh, I want to see in the chat section. I want to see fire in the chat section. Am I audible and visible, kids? Am I audible and visible? I want to see, am I audible and visible? If yes, show me fire symbol in the chat section. Yes. And make a promise that whatever I'm asking, I will not wait. Whatever I'm asking, you have to reply in the chat. I will come and see the chat. And if you are getting the things with clarity, you have to show green hearts, right? If you're not able to understand, I want to see fire. One thing is clear, everyone, whenever I'm asking any question, what you will say, you will write in the chat, answer, whatever answer, right or wrong, in the chat. Answer in chat. I will come and see. If whatever I'm teaching, if you are getting it, clarity of concept is there, you will show green leaves, green heart, whatever that is green. Green symbol means go ahead, move ahead. Green to say, yes, clarity is there. If you're not able to understand, then what you will do, kids? What is your duty? You will show fire symbol. Fire, this is fire. This is green hearts. Clear? Only 3 points. 1, 2, 3. 1, 2, 3. Agreed? If you are doing this, then the thing will become smooth and easy. Agreed? Everyone agreed? I want to know that everyone agreed. Yes, if agreed, then show me green hearts, because conditions are applicable. If you're not following those conditions, you will not get anything. If you want to get first rank in your examination, if you want to get to have, you should have to have that much thing, that whatever I'm telling you, you have to follow each and everything. If you're ready, then I want to see green hearts, green lips, whatever green, I want to see in the chat section. Yes, let me start. The isomerism of organic compounds, because one isomerism you will study in coordination chemistry, but this is organic chemistry isomerism. So to be isomer, what is the definition? What is the definition of isomer? People will say compounds having same molecular formula, compounds with same molecular formula but different structures. This is the definition of isomerism. Agreed? If agreed, show me green hearts. If not agreed, fire. If agreed, show me green hearts. If not agreed, show me fire. This is the definition. For this definition, what you will show. Agreed, then green hearts. Not agreed, then fire. Let me see. Already I have taken pen. What I will do, I will tell you. Agreed, then green hearts. Not agreed, then fire. Zero marks. You will get 0 marks. 0 marks. Wrong. So see, the point from where we are starting, that is wrong. See, now what should be the definition of isomerism? See, kids. Compounds having same molecular formula empirical formula but different physical or chemical properties, or both can be different. The physical and chemical properties both can be different. These both can be different. Both can be different. Now kids, you must be asking that, sir, whatever you have written, how we can think about it and why and where we were wrong? Because from our childhood, that is class 9th or 10th standard, we have studied like this only. Our teachers has told this only. Let me tell you, kids. Now let me prove it. If I talk about CH3, CHOH, COOH, CH3, COOH, OH, H, the structure is exactly same. One is dextrolactic acid, which is found in milk. Another one is levolactic acid. We cannot say which one is dextro, which one is levo. If I'm saying this is dextro, then it's levolactic acid. I don't know which one is dextro and which one is levo. They are experimental concept, but yes, these two are enantiomeric pairs. These two are being enantiomeric pairs. So they are isomers. This is the isomer of that, this is the isomer of this, but their structures are same. Having same structure, kids. They are having same structure. Now, one point is very much clear, that they are isomer even though they are having same structure. That means their space arrangement is different. And what you said in the definition, having same molecular formula but different structures. I hope that everyone got it. This point is clear to all of you. So now let me classify the compounds. How will you move on? See, kids. If you want to say about isomer, then the first point you have to see that their molecular formula is same or different. If molecular formula is same, if molecular formula is same or it can be different, my dear students. Two things are possible. Molecular formula can be same or it can be different. If molecular formula is same and if molecular formula is different, two possibilities are there. Either the molecular formula will remain same or the molecular formula will get changed. Right, kids? Now, under these two categories, if same, then two possibilities are there. If same, then two possibilities are there. That they can be identical. They can be identical. That is homomers. Homomers. And otherwise they can be either structural isomer or they can be stereoisomers. Now, my dear students, by chance if the molecular formula is different, do you think they will have any type of relation? If their molecular formula is different, then do you think that they will have any type of relation? Yes or no? Yes or no? I want to see in the chat section, yes or no? If their molecular formula is different, then they will have any relation or not? Good evening, Kiran Pathak. Good evening. Just to let me know, Baba is waiting. Then the answer arises, if functional group if functional group is same, remember that what I am writing, if functional group is same and if they are having difference of at least one CH2 group. CH2, you understand, CH2 is CH2, that is 14 AMU if one molecule or 14 gram if 1 mole. Then we will say they are, kids. If you drop a dreamer, if you passed class 12, do let me know in the chat section. Then they will be called as homologous. This slide is clear till now? It's clear? If clear, then I will move to the next slide, but your duty is to show me green hearts, green leaves speedily. I will not tell again and again. Let me see in the chat section whether you are following it or not. If it is clear, if this slide is clear to all of you, show me green hearts. Everyone, I want to see green hearts. Everyone, kids. I think a little bit camera. Okay, that I will do later on, but I think, okay, kids, let me see a little bit camera adjustment is required. Okay, second, I think a little bit camera adjustment is required, kids. Kids, Baba is the single person who has to do all things. Let me check whether now it's okay. Let me check it out. Yeah, it's a little bit okay. Just wait. Okay, now it's fine. It will work. It will work. Very good, kids. Very good. Very good. Very good. Fantastic. Fantastic. Arpudham. Arpudham. It was looking things, otherwise the things will look idiyappam, murku. But Baba will do it, make it romba sulbham. Baba will make it nalla irku, right? Now see, kids. How will you move on? How will you move on? This slide is very, very important. Very, very important slide, kids. $1 million slide. This slide is going to be $1 million slide, kids. Isomerism. Suppose you say, I'm a compound. I'm a compound. If you have very good knowledge also, then just listen carefully. You will get something very new. I know that maximum students are waiting for the questions. Baba is having number of questions, but remember that. If you're not putting your efforts, the things will become very tough. To get the crystal clear clarity, you have to understand even a single word. Let me tell you each and every point and try to make notes. Sit with the pen and pencil along with the copy, pages, kids. Don't ask me about class duration. Baba is interested in giving you content for the full marks, right? Now, let us suppose I am a compound. HSP 10 is compound. Molecular weight, my weight, let us suppose 70 kg. Let us suppose 70 kg. Now, if you see another HSP, once if you have reached to your engineering college or medical college, because this lecture is equally good for both. If you are preparing for IIT JEE or for NEET, this lecture is for you kids. This lecture is for you kids. Now, this is HSP 10, molecular weight 70 kg, right? Now, you have reached to your first year of college. You have seen that HSP, one HSP's hand is in the place of leg and one leg is at the place of hand. What you will say? Oh Baba, Uri Baba, leg is over here, hand is over there. HSP, you will see HSP like this. You will see HSP like this. Okay, why should take my example? Let's take Champa. Hey Champa, come on, my assistant Champa. Champa, come on. Now this is one Champa. This is one Champa. These are the hands. These are the legs. And you go 70 kg Champa. Okay, 70 kg Champa. Now, once you reach to your first year, you see Champa like this. Hey Champa. Oh. Champa. One leg is over here and one hand is over here. What you will say? Two legs, two hands, one leg, one hand over here, one hand over here. This is hand, 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 leg, 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 hand, hand. What you will say, kids? What is the relation in between two Champas, Champa A and Champa B? Now that means in place of hand there is leg, in place of leg there is hand. Structure is changed. The weight will remain 70 kg. This Champa is 70 kg. This Champa will also be of 70 kg. But their structure is different. So they are being structural isomer. Structural isomer. Am I right? Because classification is very, very important. Doing many questions will not give you that knowledge, the knowledge which we are going to get with the theory part. Remember that. Now, this point is clear. Clear, this point is clear. Now, you have reached to the second year of your college. I am in second year, MBBS, I'm doing MBBS, second year. Now you see, Champa, Ma'am Champa, Physiology. Madam Champa is for physiology. Both the two hands like this. Wherever Champa ma'am is going like this. Whenever writing, Champa ma'am is writing like this. So this is Champa ma'am. Two hands on the same side. Two hands on the same side. Now, you have reached to the lab where the dissection is frog dissection. Okay, frog is going to be dissected. In the lab you have gone, and there the Champa ma'am was like this. Another Champa type ma'am, the hands like this. Always Champa ma'am was moving like this. One hand coming towards your side, one hand is going toward that side. Whenever Champa ma'am is writing, she will write like this. One hand towards your side, one hand going toward that side. What you will say? The hands originating from here only. The origination is same. The structure is remaining same. Both the Champa's hand are from same side, but this is on same side. This is cis and this is trans. Leg is at the place of leg, tibia, fibula, radial, ulna, malleus incustus, phalanges, tarsus, metatarsus, magial incustus, pia meter, acronoid, durometer, everything at the right position. Only the difference is that one Champa ma'am is always remaining like this and another Champa ma'am is always remaining like this. Then this Champa ma'am will never change into that Champa ma'am, this Champa and that Champa. They will not be interconvertible at room temperature. What you will say? They are GI. These two Champa are GI of each other. The relation is geometrical isomers. These two Champas are geometrical isomers. Now, my dear students, you have reached to your final year of MBBS, final year of your MBBS. Now see kids, final year of MBBS, final year. Now ma'am has come, Champa ma'am. Now that see the entry of Champa ma'am, entry of. Ding, ding. Hey kids, I'm Champa ma'am. Ma'am is doing like this. I'm Champa ma'am. Ting, ting, ting. So she started doing moonwalk. Ting, 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 ting. Then ma'am come. Ma'am has come. Ma'am is doing like this. Dung, dung, dung. Started doing dance, like dance. Jumba, bhangra, every. Now ma'am is. Now you will say, oh my God. In our second year, one Champa ma'am was always like this. I have seen always Champa ma'am was like this. This ma'am was not converting into trans. And trans ma'am I have seen always in trans. But this Champa ma'am, no break. Always says trans, ting, 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 doing dance, conformational, moonwalk and number of walks. My dear students, you will say, what is this? That at room temperature in finite forms, Champa ma'am is interconvertible. You will say, my God, conformational isomerism. What you will say? Conformational isomers. That conformational isomers are interconvertible into each other at room temperature. Are interconvertible into each other at room temperature. Now kids, now I will do the classification. See, Baba has taken this much of time to tell you the classification. Now Baba is going to classify. Baba is going to classify isomerism. Just see kids. I will say isomerism is mainly of two types. Isomerism is mainly of two types. One is structural isomers. or we can say constitutional isomers, their IUPAC name will be different. IUPAC will be different. And they are two-dimensional, 2D. They will be 2D. And in this category, the priority order is write your famous ring chain, tautomerism, functional metamerism, chain and position. If any compound is showing more than one type of structural isomerism, then the priority order will be like this. Priority order. What I am writing, what I have written, kids: ring chain, tautomerism, functional, meta, chain, position. I will tell you each and everything in detail. The second type of isomerism is space isomerism. Space isomerism, kids, means three-dimensional, and it is further divided into two parts. These two parts are configurational. Remember that. Everyone say along with me, configurational. Everyone, because in the examination you will forget about it. You won't be able to do the question. Configurational. Say everyone, configurational. And conformational. Conformational. And what is the basic difference in these two type of isomerism? Let me tell you, configurational and conformational. My dear students, in this category, configurational, one form, everyone say, one form can't convert into another at room temperature. My dear students, these are of two types. What are these two types? Let me tell you, let me explain you. One is geometrical isomerism. Another one is optical isomerism. Now, my dear students, if your father or mother is doctor, they know very well that whenever doctor is giving you medicine, doctor is always asking to keep it in dark place. Otherwise, in the presence of sunlight or the heat, it will get converted and it will get expired, or it is going to do reaction. If your father or mother is doctor, or any relative is doctor, they will say that we are going to inject dextrose to the patient, dextrorotative glucose. But that is always kept at cold place, cold conditions, cold environment is required, because if temperature is increasing, then dextrose will convert into levulose. You know, being a bio student, you know very well the bio. Dextrorotative glucose on glycolysis produces 10 ATPs and 2 ATPs are getting destroyed. So net gain of 8 ATPs. Acetyl coenzyme, citric acid, cis-aconitic acid, isocitric acid, alpha-ketoglutarate acid, then succinic, fumaric, malic acid. That whole Krebs cycle will run, that is TCA cycle or Amidan-Mayer-Hop pathway. Then eukaryotic and prokaryotic cell, you know, 36 and 38 ATPs we are going to get. And that is given by glucose, that is when dextrorotative glucose. Levorotative is not metabolically active. So, one form will not convert into another form at room temperature. That means configurational isomers. So, these two category, whatever I am telling you kids, that geometrical isomer and optical isomers, they both are the section of this class, you know, when you are studying in class 4th A, 4th B. but section were different, class was remaining same, that was a fourth. So these sections are different, but their class is configurational isomerism. And if one form is interconvertible into another form at room temperature, we will say conformational isomer. And whenever there are conformational isomers, they will always be infinite. One form will convert into another. This slide, if it is clear, I want to see green hearts. Not clear, then fire. Just to let me know in the chat section. Baba is just watching the chat. What's there? Just to let me know whether this slide is clear. Then show me green hearts. If it is not clear, then show me fire. Then Baba will let you know. Don't worry, kids. Is it clear? Monica Priyadarshini, very good. Madhumita, wow, okay, great. Wow, my God, kids. One fire, I can see just one fire. Rest of the hearts, green hearts, that means it's Romba Sulbham, Arpudham. Concept clarity is like easy peasy lemon squeezy. Wow. Thank you, kids. You are enjoying it. Wow, very good. Now, let me explain one by one all type of isomerism. Let me explain one by one each and every type. Now, let's start. Let's it go. I will start with the chain isomerism. Okay, right? Chain isomerism. In short, we will say CI, chain isomerism. Okay? Chain isomerism. So remember that in chain isomerism, what is going to happen? Parent chain will be different. Parent chain That's it. Parent chain will get changed. Who is going to get changed, kids? Parent chain. Parent chain is going to get changed, kids. What happened? Am I audible and visible, kids? I think some lag was there. Kids. Now it's okay. Parent chain will be different. For example, if I say C4H10 can be written in two ways. Just see CH3, CH2, CH3, and the second way is CH3, CH3. Now just see. In the first compound, I can say Vana, Randa, Mono, Nale. PC is of 4 carbon atoms. Parent chain is of 4 carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. Now here 1, 2, 3. The parent chain is just of 3 carbon atoms. So they are chain isomer. Their parent chain is different. One is isobutane. Another one is what? Another one is N-butane, normal butane, kids. Now before I go ahead, number of pupils, their problem is that they are always thinking of how to calculate total number of structural isomers. Baba, is there any trick? Okay. Baba, is there any trick? Baba will give you, but let me first explain. First, let me ask question, then Baba will give you the trick. Okay. First, let me tell you, kids, what I am going to tell you. Just see. If I ask one question time, everyone ready? Question. I am having two type of questions, printed questions and my questions, new questions. Remember that whatever I am going to frame out the questions on the spot, they are more important, because already typed questions, they are repeated one. Okay. Now, calculate or find out minimum number of carbon atoms required to show chain isomerism in chain isomerism. A, alkane. B, alkene. C, alkyne. Very simple question. Alkane, alkene, alkyne, all three. Do let me know all three, then I will explain what's the answer. Let me see in the chat section what's your answer, then I will explain. Wow, Ashif Ashraf, thank you. Ashif Ashram, thank you, really thanks. Now Baba want to see the answer in the chat. Baba is just in front. 445. Oh my God, kids, fantastic. Absolutely correct. Congratulations. 445. 4 already explained. This already explained. This is 4 and this is 5. This is 4. See, just see. CH2 double bond. CH2 CH3. Now CH2 double bond CH3 CH3. 1 2 3 4, right? But here the valency will become 5. That's why we require 5 carbons. So CH triple bond C CH2 CH2 CH3. Now CH triple bond C CH3 CH3. Kids, just see. And this 1 2 3 4 1 2 3, the parent chain of 4 carbons, parent chain of just 3. Here 1 2 3 4 5. Now here 1 2 3 4. So the parent chain got changed, and that's why your answer is like this. Right, kids? Right? Is it clear? Clear to each and everyone? Now see. Let me tell you position isomerism. Position isomerism. Everyone just focus on position isomerism. Then after this I will give you the trick. Baba will provide the trick. Now position isomerism. Here parent chain remains constant. Parent chain is same. But remember what is getting changed? The position of either alkyl, position of alkyl, or multiple bond. What is that multiple bond? That is being double bond or triple bond or the functional group. But remember that I'm not saying that functional group is getting changed. What I'm saying, the position of functional group is getting changed. Position. I'm not saying that functional group is getting changed. I'm saying that position of functional group is changed. I think position of alkyl group should get changed, or the position of double bond, triple bond, or the position of functional group should get changed. Their position should get changed. I'm not saying that functional group. Remember that I'm not saying functional group should get changed. What I'm saying, the position of functional group should get changed. Are you getting my point, everyone? So let me show you the example of it. Till now, is it clear to each and everyone, kids? Now, let me. Directly, if I say that, tell me the answer of the question. Let me check it out, whether you are able to tell me or not. Question is, find out minimum number of carbon atoms required to show PI, to show position isomerism in one is alkane, another one is alkene, another one is alkyne, another one is any organic compound. Let me check it out. What's your answer for these 4 questions? Baba is there just in front of screen. Let me see what your answer is going to come, kids. Yes. Let's find out what's your answer. Baba is waiting for your answer, kids. Yes, kids. Baba is always thinking of the camera position also. Baba is always trying to adjust the camera also so that better connectivity. 644. My dear friends, how you are getting these answers? How you are able to understand? Baba is unable to understand, kids. From where you are getting this much of knowledge, kids? From where you have got this much of knowledge, kids? From where? Who taught you? Exactly correct. Who taught you? But kids, who taught you? 6, 4, 4, 2. Which teacher has taught you, kids? Have to increase the level, Veera level. I will tell you what, kids. So, wow, kids. That means I have to increase a bit level. Oh my God, kids. Those who are unable to understand, let me tell you, those who are unable to understand. Alkane. For alkane, okay. First, let me tell you the trick. Let me tell you the trick. Those who are unable to understand, trick. HSP is the funda, rank lai, bandi banda. Everyone is going to get rank. Now let me tell you the CS number. CS number. What is the CS number? This will make you better visualization. If I say C stands for number of carbons in the parent chain, total number of carbons in parent chain, and if I say S is number of substituents starting with carbon, then 2 possibilities are there, kids. 2 possibilities are there. If CS number is coming different, if it is coming different, then that will be chain isomer. Then it will be, the relation will be chain isomers. If CS number is coming same, then they will be position isomers. Remember this trick, kids. Always keep it in your brain. This trick is very, very important trick. CS number trick. Okay, kids. Now I will solve, or you can solve any question by using this trick. Okay, kids. Let's see. Let's apply this trick. Kids. Just see. If I say that I'm having C6H14, then what I will write? I will write CH3, CH2, 1, 2, 3, 4, 5, 6. If one thing I am writing like this, another one I am writing like this, CH3, CH3, CH2, CH2, 1, 2, 3, 4, 5. Now one more compound, if I am writing like this, CH3, CH2, CH3, CH2, CH3. Just check. A, B and C, just check it out. They all are having same molecular formula, C6H14. Just check out. Just check it out. Everyone just check it out. All three are having same molecular formula. All three are having same molecular formula. Then see, if I write 1, 2, 3, 4, 5, 6, the parent chain is of 6 carbon atoms, and here 1, 2, 3, 4, 5. The parent chain is of 5 carbon atoms, and here 1, 2, 3, 4, 5. The parent chain is of 5 carbon atoms. So see, it's of 6 and these are 5. So A is the chain isomer of B and C. One point is clear. A is the chain isomer, not the position. Just see why. If I say, what is the CS number? What is your CS number? What is your CS number? C, number of carbons. So C is coming out 6. There is no alkyl, so S is coming out 0. So what is your CS number? What is your CS number? 60. Now, what is the CS number? Number of parent chain. So it is having carbons in the parent chain 5, and one alkyl group is starting with carbon. So S is 1. So 51. What is your CS number? 51. And it is having 5 carbons, so its C is 5. One alkyl with starting with carbon, so S is 1. So 51. CS number is same, CS number is different. So A is not the position isomer of B and C. A is the chain isomer of B and C. Kids, are you getting my point? A is CI of B and C. Am I right? Now, their CS number is same. So they are what? B and C are position isomers. If you got it, show me green hearts if the point is clear. Now, the alkene and alkyne 644. If this slide is clear, show me green hearts. Everyone, show me green hearts if this point is clear. Now, if I say alkene, what is the next question was alkene. Just see alkene, kids. So it's very simple. CH2 double bond CH2 CH3. Only 4 carbon atoms are required. CH3 CH double bond CH and CH3. See the position of double bond. Here it is 1. And here is 1, 2. The position got changed. Such same like in alkyne also. The same thing will be in alkyne also. Now, let me tell you any functional group about any functional group. So, any functional group will be like this: CH3, CH. Either you can add chlorine, bromine, iodine, anything you can write. So, CH2Cl, CH2Cl, they are having different position. My dear friends. At 1, this is geminal halide, and this is vicinal halide. I think this is clear. Now, after this, Baba is going to give you the trick for calculating structural isomers. How many of you need trick? I want to see fire in the chat section for the trick. Hey, Baba is going to give you the trick for structural isomers. See. Awesome trick for calculating for total number of structural isomers. Total number of structural isomers. Ready, kids? Is everyone ready? Just do let me know. Yes. So see, the trick is 2 raised to power n minus 4 plus 1. What I am saying? 2 raised to power n minus 4 plus 1. Tell me what I have written. Tell me, everyone. I am going to delete it. Tell me what I have written. What was written over here? 2 raised to power n minus 4 plus 1. Total number of structural isomers. Total number of structural isomers. Tansi. Tansi. If you want to calculate Tansi, 2 raised to power n minus 4 plus 1. Now, up to what they will ask in the examination. So tell me what I have written. Once again, I am going to rub it. Tell me, everyone, repeat what I have written. I want to see in the chat section. I want to see in the chat section. Kids, Baba wanna see in the chat section what I have written. Tansi, total number of structural isomers is equal to 2 raised to power n minus 4 plus 1. Now, kids, up to what number they will ask? This formula is valid up to, 7 carbon atoms. 7 carbon atoms. That means this formula is valid up to 7 carbon atoms. Should I apply? If it is gone to your hippocampus, then only Baba is going to apply. Tell me, has it reached out to your brain? Kids, tell me, Tansi. Whenever anyone is asking about Tansi, total number of structural isomers, this is the formula, Tansi formula, kids. Tell me, Tansi. 2 raised to power n minus 4 plus 1. What? Now, what is n? N is the number of carbon atoms. Now, kids, let me apply this formula. Let me apply. So, if I apply this formula for C4H10, apply it out. Apply 2 raised to power, what is n? 4, carbon number. This is carbon number. 4 minus 4 plus 1. 4 minus 4, 0. So, 2 raised to power 0 plus 1. So, anything raised to power 0 will come out 1. 1 plus 1, that is 2. Right? The first one you are able to understand. Now, let me apply for 5 carbon atoms. 5. C5, and let me check it out whether valid or not. 2 raised to power 5 minus 1 plus 1. 2 raised to power 5 minus 1. So, no, 5 minus 4 plus 1. 2 raised to power 1 means 2 plus 1, 3. Right? Absolutely correct. Now, C6H14. 2 raised to power 6 minus 4 plus 1. 2 raised to power 2 is 2 raised to power 2, 4 plus 1, 5, right? Absolutely correct. C7H16. So, 2 raised to power 7 minus 4 plus 1. 7 minus 4, 3, 2 raised to power 3. 2 to the 4, 4 to the 8 plus 1, 9. Till now, can you see? Everyone able to understand? Do let me, show me green fire, green hearts. Then, yeah, I will increase the speed. Don't worry. Saima, Wazim, everyone. Baba will increase the speed. Don't worry. Just to let me know. Everyone got it or not? Is everyone able to understand or not? Kids, to let me know. Just to let me know. Show me green hearts if yes. Wow. Now, let me tell you for 8 and 9. So, let me tell you for 8 and 9. 8 and 9. C8 H18. For this, the formula is 2 raised to power n minus 4. This will remain same, plus 2, plus 2. For this is the formula. Let's see, 2 raised to power 8 minus 4 plus 2 will come out 2 raised to power 4 plus 2. Oh, sorry, not, plus 2. 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16 to 18. It will come out 18. Now, for C9 H20, the formula will come out 2 raised to power n minus 4 plus 3. Now let's apply 2 raised to power 9 minus 4 plus 3. How much it will come out? 2 raised to power 9 minus 4, 5. So 5. See, 2 into 2 into 2, then into 2, then into 2. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32 plus 3, 35. Yeah. And for C10, you can remember C10 H22 is 75. That's it. Because we cannot calculate. So this is the formula. How was the trick? If everyone, you liked it, I want to see some fire in the chat section. How many of you liked the trick, kids? Was it okay? Good. If yes, you liked it, I want to see fire in the chat section, kids. If the trick is working. Wow, kids, very good, very awesome, very awesome. Romba Sulbham. Idiyappam is converting into our Nalla Iriku. Iriku is converting into, wow, thank you, what I can see, wow. Motivation is just keep on working hard. Once you are going to get that white coat, that is the motivation. Always you can see you are the best doctor or engineer. You are going to be the best. Now, kids, after knowing this much, how you are going to solve tough questions. Now, I will give 3 questions. Let's see. Baba is going to give you 3 questions and try to see how many of you can do those questions. And then I will tell you the trick to solve those questions. Okay? Question is, find out total number of structural isomers. Let's see how many of you are going to get accuracy. Structural isomers for 1, 2, 3. 3 compounds I am going to write. 3 compounds. First one is C4H9Cl. A. B is C5H11Cl. Now C is C4H11N. Write down. I want to see in the chat section what's your answer. Baba is waiting for your answer, kids. Everyone. Let me see what's your answer, kids. Baba is waiting for your answer. Baba is always trying to give you the best. Baba is setting the position of camera. Once I'm thinking, 2, what you are writing, 232. 232. Let me check it out whether your answer is right or wrong. 232. You are going for 232, kids. 488. 488. I think some people are right. Those who have written 488. Marunga Latha. Marunga Latha. Only this student is correct. Marunga Latha. Ambika Sharma. Ma'am is there? Kids, do you think ma'am is there? Still, the position of camera is not clear, but just let me explain it. The answer will come out. Answer will come out, kids. It's, hey, 4, my dear, 4. Hey, 8. And for this, 8. 8. Now, how many of you want to know the correct explanation for this? How many of you are interested? How many of you are interested? Ambika ma'am. Really, Ambika ma'am is there? Hey, ma'am, are you there? Ma'am, are you there? Welcome, welcome, vanakkam, suswagatam. Dil se hriday aapka swagatam, ma'am. Pucho kyun? Pucho kyun? Hey, just ask why. Really, ma'am is there? Hey, ma'am. Hey, ma'am. Welcome, welcome, vanakkam, suswagatam. See, once you have come, Baba HSP is happy. Hey, Saucy HSPN. Pucho Q, Pucho Q, Pucho Q. देखो ना देखो ये क्या हुआ, कोई ना ये जाना. The answers of the question, how we have got these answers, kids. Wow. पूछो क्यों? पूछो ना पूछो ये क्या हुआ, कोई ना ये जाना. Let's see how to get these answers. Just see, kids, just see. Now see, Saucy, now just see. Saucy jao, now just see. Now see, kids, now see. See how to do it, how to do it. You must have watched one movie, Chandni Chowk to China. I don't know the whole movie, but there was one hero, Akshay the Great, and everyone was beating him. At the last, he has gone to the master and he asked, hey master, what should I do? What should I do to win this race? To win this race? Then his master replied, just think about your base. What was your base? He was a chef. He was a cook. Then he said, just make it out from there. Your strong base, just do anything. Whatever you want to do, just think about your base. Now see, C4H9Cl, C4H9Cl. If I remove this Cl, it would have been, before this Cl, definitely it would have been C4H10. Am I right? And C4H10 is having how many structural isomers? Just to let me know how many structural isomers. It is having 2 structural isomers. That means N-butane. One is being N-butane. That is CH3, CH2, CH2, CH3, and another one is isobutane. Am I right, kids? Isobutane. N-butane and isobutane. This is being isobutane. Am I right? Yes, sir. Champa. Hey, assistant Champa, just to let me know. Am I right? Yes, sir. Yes, sir. Okay. Now see, If I remove this hydrogen and place here chlorine, or if I remove this hydrogen and place here chlorine, 1 chlorobutane, both means same, 1 chlorobutane, and if I replace this hydrogen or this hydrogen, they mean same. Now from N-butane, how many monovalent radical I have got? I have got 2 monovalent radicals from here. 2 monovalent radicals I have got from here. Now just here, this and this same, and this is being different. So 2 from here, 2 monovalent radicals from here. Now remember always 2 plus 2. That means remember always that C4H9 will form 4 monovalent radicals. Alright kids, 4 monovalent radicals always. So whether C4H9Cl is being asked or C4H9Br they are going to ask, or C4H9I they are going to ask, the answer will always be 4. Clear? Chlorine, bromine, iodine, anything, the answer will always be 4. Vanarana monunale. Got it? Now, the second one. C5H11Cl. Now see, before adding Cl, it would have been what? C5H12, and for C5H12, how many structural isomers have told you? How many structural isomers? 3 structural isomers. What are these? What are these 3? N-pentane. What is N-pentane? CH3, CH2, 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 CH3. Isopentane is what? CH3, CH3, CH2 and CH3. And neopentane, what is a neopentane kids? Neopentane is CH3, 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 CH3. Now just see kids, everyone just see. If I remove this carbon's hydrogen, if I remove this carbon's hydrogen, they mean same. If I remove this carbon's hydrogen or this carbon hydrogen, they are same. 2 chlorobutane, 2 chloropentane, and this 1 chloropentane. Either here 2 chloropentane, here 1 chloropentane, and this is being totally different because it will give you 3 chloropentane. So from this, I have got 3 monovalent radicals. Now from this is methyl 1 and 1, same, but that methyl kids, remember that methyl is different, totally different. Why this is different kids? Why this is different? Because its surrounding is CH2, their surrounding was CH. If I place chlorine over here, then it will be 1 chloro, 1, 2, 3 methyl butane. If I place here, then it will be 1 chloro, 2 methyl butane. They are different, and this is totally different. So I have got 1, 2, 3, and this is different. So I've got 4 from here, 4 monovalent radicals, 4 monovalent radicals. And in neopentane, this carbon is not having any hydrogen, but these are same, all 3 are same. So 1 monovalent radical, 1 monovalent. Now I hope this is clear. 3 plus 4, 7, and 1, 8. So we have got 8 monovalent radicals. So remember that answer will come out 8, right? Now the last one, but not the least one. How many of you are interested in the last one? Kids, you are ready? Kids, always remember that I know that it's very tough. To sit and to study is the most toughest job, kids. Really. To move here, to go there, it's very simple. But to just sit and study properly, number of students must be waiting for tough questions. Sir, please increase the speed. Kids, even I want to increase the speed. I just want to deal with tough questions. But kids, without understanding this basics, you won't be able to reach up to the tough questions. This is the ladder to reach up to the tough questions. Now see. It was provided C4H11 nitrogen. So first of all, I would like to make primary amine. From this, I would like to make primary amine. Now what is the special thing about primary amine? Primary amine says RNH2. RNH2. So I have to carry out NH2 from here. If I subtract NH2 from here, NH2, 1N and 2 hydrogens, if I subtract from here, what I will be getting over here, what is left? C4 and H9 is left, and I will write NH2. So can you please do let me know C4H9 forms how many monovalent radical? 4. So these will be 4 primary amines. There will be 4 primary amines. 4 to primary amines. Now let's see the secondary amine. How many secondary amines we will get? Let's see for secondary amines. Let's see about secondary amine. For secondary amine, I have to write down NH. 2 degree amine. NH must be attached, nitrogen must be attached with 2 carbons. Now see, I can write here ethyl, CH3, CH2, CH2, CH3. I can write like this. Then what I can write? NH, just see, look at over here, my dear friends. CH3, I can write CH3. CH2, CH2, CH3 I can write. Here I can write CH3. Here I can write CH3 and CH3. Now just check it out. These are 3 in number, 2 degree amines. We have got 3 2 degree amines. Ethyl diethylamine, methyl propylamine and isopropyl methylamine. So these are 3. I have got 3 in number and tertiary amine. Let's talk about tertiary amine. Let's see how many tertiary amines we will get. 3 degree amine. So let's talk about tertiary amines. Tertiary amines. Now see kids, N, methyl, and ethyl, only 1. So 4 plus 3 plus 1, 8 is the answer. The question is done and dusted. Clear? If clear, I want to see some hearts in the chat section. Green hearts if it is really clear. If you got it, my dear friends. One kid is not able to understand, then better to sit at home. Srushti, Sonwen, if you are not able to understand, then better to sit at home. Yeah, I will tell you about DB. Oh my God, number of kids are not able to understand. Oh ho 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 ho. Kids, fire means you are able to understand or not. Oh my God, fire symbol is indicating. Fire symbol is indicating able to understand. Oh my God, kids, I think I have to explain once again. Oh my God, Green heart means able to understand, fire means not able to understand. Oh, my dear friends, number of people are not getting it. Are you ready? Are you in the same position? Fire means not able to understand. Oh ho, my dear friend. Don't worry. Once again, show me green hearts if you are able to understand. Fire if you are not able to understand. Fire if you are not able to understand. Green hearts if you are able to understand. Oh my God. Hey Baba, tell them again. Don't worry, kids. Baba is here. Baba will tell you. Don't worry. Oh my God. Cool, kids. Cool. Now see why the trick has not worked over here. See, kids, trick will work C4 H9 if anything which cannot act as different functional group, whatever is attached over here, if it cannot act as different functional group, then only the trick will work. So for the trick you have to apply brain. What was written over here? See, the question was given like C4 H11 nitrogen, and the trick was, see, trick was for C4H9, CH9, here it was H9 and this was only monovalent. Chlorine can never be divalent or trivalent. Remember, it can form 4 monovalent radicals and chlorine can act as monovalent only. But see, the question was C4H11N, and nitrogen can be like monovalent, it can be monovalent, it can be divalent, it can be trivalent. If nitrogen can behave as monovalent, divalent, trivalent, by chance if they have asked how many 1 degree amine with this, how many 1 degree amine, so C4 H9NH2, the trick will work. 4 1 degree amine. Answer is 4 primary amines. There will be 4 primary amines, kids, because this is monovalent. 4. Are you getting it? Once again I am telling you, kids, 4 monovalent radicals. It can form 4 monovalent radicals. So answer is 4 primary amines. 4 primary amines. Clear, kids? 4 primary amines. Clear? Now secondary amine. Now for the secondary amine, how we can write? Just see, we can write one side ethyl. Out of 4 and 9 we can write here ethyl. Once again, this is secondary amine. The secondary amine, what we can write? Just see, NH, only we have written NH. This side it was ethyl, kids. This side it was ethyl, and that side also it was ethyl. See the parent chain of only 2 carbon atoms. 2 carbon atoms parent chain. Now if I am going to write like this, if I am writing here methyl CH2 CH3, just see, kids, 1 2 3 carbons parent chain. There it was 2 carbons parent chain. Here it is of 3 carbons parent chain. Now see, if I write CH3 NH CH3. Now see, kids, 1 2 3. The position, the parent chain is of 3 carbon atoms, but see here it was located on first carbon, but here it is located on second carbon. So all these 3 are 2 degree amines, secondary amines. Why they are secondary amines, kids? because nitrogen is attached with 2 carbons. This side also carbon, that side also carbon. So if nitrogen, remember, if nitrogen is not attached to carbon, it is known as ammonia. If nitrogen is attached to 1 carbon, we will say it is primary amine. If nitrogen is attached to 2 carbons, we will say secondary amine. And if nitrogen is attached to 3 carbons, we will say it is tertiary amine. So one point is clear. We have got, with the help of trick, 4 primary amines, 3 secondary amines, and tertiary amine we will get. See, 1 methyl. I have to put 3 carbons, 1 more methyl, and how much is left? 4 carbons were there, 2 have utilized, now 3 carbons. This is tertiary amine. Why tertiary? Nitrogen is attached with this side carbon, and this side also carbon. So how many are they? Just count, kids. Now count how many are they? 4, 3, 7 and 1, 8, total 8. Now kids, Baba will tell you once again if you are not able to understand. Show me green hearts if you got it, fire if you haven't got it, kids. Let me see green hearts or fire, kids, because your understanding means a lot to me. Baba is here to teach you, kids. Baba will make it possible. Do let me know, kids. No idea, Sahusi. I have no idea about Sahana. Kids, do let me know. Now, oh my God. Yes, now I can see only few students are there, those who are unable to understand. Rest of others, they are able to understand, but few are there, those who are not able to understand. Okay, no problem, kids. What to do now? Okay. I will make it possible. Don't worry, kids. Don't worry. Baba will teach you. I can understand. Sausi, Deepu, good evening. Sir, you are so rude. Oh my God. Srishti, Sonven. Sorry, Srishti. Baba is saying sorry. Because Srishti has written that I am not able to understand anything. Srishti, if you would have written that, Baba, this concept I am unable to understand, then I haven't said anything. But you have written that you are unable to understand, you are not able to understand anything, then do let me know. I know that you are a very good student. But Srishti, what's the complete name? I don't know. Don't worry. Okay, I will make it clear. How many of you want this particular question again? Show me. Write down again. Baba will make it clear. Don't worry. Write down, sir, again. And that name who has written Baba so rude, don't worry. I will make it clear. Don't worry. Sahana is there. Sausi, you said, where is Sahana? Sahana is there. Baba can't be rude. Write down again. Baba will make it clear. Srishti Sonven, don't worry. I will make it clear. Don't worry. Ankita is there. Srishti Sonven, don't worry. Baba will make it clear. Once, this is the first time I have seen that somebody has written that Baba is so rude. Baba is crying. Now Baba started crying. Srishti Sonven, Baba started crying. Now who is there to say? Okay. See, kids, what is monovalent, bivalent and trivalent? See, First see, monovalent radical means only one valency is free, only one valency, having only one valency. They are having only one hand. You can say only one hand. Champa with one hand. You can think about Champa having only one hand. Champa having on one hand. Only one hand, right? Monovalent, no legs even no legs. Champa with one hand only, one hand. So if Champa is going to form bond, Champa will say, oh, I can make one bond, okay? No legs, only one bond, right? Monovalent. Like chlorine, bromine, iodine, OH, CHO, 1 degree amine, NH2, they are having one hand. This point is clear to all of you. Monovalent, the meaning of monovalent is clear to all of you. Now, if they are attached with C4H9, if I say they are attached with C4H9, if I say they are attached, chlorine, bromine, iodine, OH, CHO, NH2, then they will form just 4 structural isomers. What should be the answer? 4 structural isomers. Got it? They will always form 4 structural isomers. Now, divalent or bivalent, divalent or bivalent, and Srusti Sonwar, I said that because I thought that some spammer is there. Literally, I have told you thing, just go and sit at home, that I thought that some spammer is there, and again that spammer is writing, I'm unable to understand. Love from Manipur. Thank you, Sahana. Now, see, bivalent or divalent. If I say 2 valencies are there, having 2 valencies, Now, 2 valencies means, like if I say ether, they are having 2 hands. Champa with 2 hands, no legs. Champa with 2 hands without legs. No leg is there. Champa is not having legs. Only 2 hands. Champa is having 2 hands. No legs. 2 valency. Like ether, like ketones, like 2 degree amines. Now kids, you got it. These means bivalent, monovalent. If I say trivalent, then tetravalent, trivalent, tetravalent. Are you able to understand? This point is clear to all of you. Then I will explain once again. Tell me this point is clear. Then I will tell you the question once again. Everyone do let me know. Everyone do let me know this point is clear. If yes, then I will tell you rest of the things. Kids, do let me know. Clear. Okay. Now, let me come back again to the same question. Let me come back again. If anyone is asking C4H9 Cl. Now, Cl is what? Cl is monovalent, and this C4H9 forms how many monovalent radical? C4H9 forms 4 monovalent radicals. So the answer will be 4. Because chlorine cannot form bivalent. Chlorine cannot be bivalent. So 4 will be the answer. If anyone is asking 4H9Cl or C4H9Br or C4H9 iodine, they all answer, their answer will be what? Everyone's answer will be 4. Everyone's answer is going to be 4, right? 4 will be the answer, right? But if anyone is giving nitrogen, nitrogen's valency is how much? See, chlorine belongs to halogen family. Chlorine belongs to halogen family. Fluorine, chlorine, bromine, iodine, they are just having one valency. One valency, right? Always one valency. But nitrogen belongs to fifth group. So nitrogen can have 3 valencies. See, if anyone is giving C4H11 and nitrogen, now this nitrogen can be present like monovalent. It can be like monovalent, only one valency. This nitrogen can be bivalent, means 2 valencies. Now this nitrogen can be trivalent, 3 valencies. Till now clear? Till now clear? That nitrogen can have 1 hand, 2 hands, 3 hands, means 1 hand, 2 hand and third leg. This much is clear? Nitrogen. Now if I say that for monovalent hydrogens, 2 hydrogens you have taken out from here, 1 nitrogen you have taken, 2 hydrogens you have taken, so what is left? If you take out 2 hydrogens on that side, you will write it like this, C4H9, and you know very well that C4H9 forms how many monovalent radical? It forms 4 monovalent radicals. Now suppose examiner has asked, if he has asked how many primary amines this compound can form, if he is going to ask how many primary amines this compound can form, then answer will be 4 primary amines. It can form 4 primary amines. If the examiner is asking how many primary amines it can form, then 4 primary amines it can form. 4 primary amines will be the answer, because primary amine is monovalent radical. Monovalent radical 4, then the trick will work. 4 primary amines, but he has not asked primary amines, he has asked total structural isomers. So 4 primary amines plus secondary amines. See, I can place this side ethyl, that side also ethyl. I can place here methyl, that side, then what is left? Propyl. This side methyl, and that side I can place isopropyl. Now these are secondary amines. Why secondary amines? Just see, this nitrogen is attached with 2 carbons, this side, that side carbon. Once the nitrogen is attached with 2 carbons, then that is going to be secondary amine, kids. Now it will form 3 secondary amines. They are also structural isomers because their structure is different. There the parent chain will contain 4 carbons. In all those, parent chain will contain 4 carbons. But here the parent chain is containing 2 carbons. Parent chain is of 2 carbons, parent chain is of 3 carbons, and parent chain is of 3, but position is different, so position isomer. So parent chain once again, but the position of NH, see, it is attached on second position, there it is attached on first position. Are you getting my point? So these two are position isomers, and they are chain isomer. Now 3 degree amine, 3 degree amine, 1 methyl I have placed, 1 methyl. Now how many carbons are left? They were 4. Out of 4, 2 I have taken, so 1 is left, C2H5. So tertiary amine I have got 1 tertiary amine. So all total structural isomers, they are coming out how much, kids? Tell me how much? 4 plus 3 plus 1, 8. I hope, kids, if everyone got it earlier, those who have got right now, those who have got, show me fire. If you are not able to understand, show me fire. If you got it, green hearts. Got it, green hearts. Otherwise, fire. Let me check it out. If you got it, green hearts. If you haven't got it, fire. I want to see fire or green hearts. Let me check it out, what I'm going to get. Yes, everyone, just to let me know, kids. Kids, wow, kids, really now Baba is happy. Baba is really happy now, kids. Now camera, let me see the setting. Baba is trying again and again. Let me check it out. What's the position of camera? Now from this side it's okay, that side it has gone somewhere. What's happening? I can't understand what's happening, kids. Okay, clear, kids? Till now whatever I taught you, it's crystal clear. Done and dusted. Done and dusted, kids. Now where is that child? That child, let me see in the chat section, that child is able to understand or not? That child, thank you, thank you. Where are you? That girl, who was saying Baba is so rude. I don't know whether you are there. I want to see that. Where are you? Thank you, kids. Thank you, kids. Thank you. See, kids, Baba has started asking. Baba is the one who has started asking, show me green hearts and show me fire. Yeah, DPP I am always providing. Yeah, I will provide DPP. Don't worry, I will provide. Now, this is a really good one. Thank you. Now, this is okay. Now, okay. Now, let's move ahead. Let's move. Okay, let's move here. Now, ring chain isomerism. Let's talk about ring chain isomerism, kids. RCI, ring chain isomerism. RCI, ring chain isomerism. One form cyclic, one form cyclic, another form acyclic. another form acyclic. For example, if I am having C4H8. Now from here, one thing more arises. If you want to get more clarity, if you want to have more focus, then you can do one thing. I will teach you double bond equivalent. That will make crystal clear. Concepts clarity will come from there. Now I can write CH2 double bond CH2 CH3, and I can write like this C4H8 like this. Now this is acyclic, this is cyclic, but here in the cyclic double bond will not be there, because otherwise the molecular formula will change. Now you will say, sir, how to increase the speed? How to get a very good command? So to understand ring chain isomerism and other forms of isomerism, we have to understand double bond equivalent. How many of you are ready to understand double bond equivalent, kids? Just see. Baba is going to teach you double bond equivalent. Now see, kids, let me teach you double bond equivalent, then I will come back to this position, right? Double bond equivalent. Or let me teach you double bond equivalent. I am having slides along with the questions to tell you double bond equivalent, kids. Just wait for a second. See, double bond equivalent. This is the language of chemistry. What is double bond equivalence? Double bond equivalent is the language of chemistry, kids. If you understand double bond equivalent, then your chemistry speed will get increased. Are you ready? Everyone, are you ready? Are you ready to understand double bond equivalent? Everyone, are you ready, kids? Just to let me know. Are you ready for double bond equivalent? Yes, just to let me know everyone is ready for double bond equivalent. See, double bond equivalent is also known as degree of unsaturation. Degree of unsaturation. Or it is also known as index of hydrogen deficiency. It is also known as what? Index of hydrogen deficiency. My dear students, once I am saying three names, I have taken three names. One, degree of unsaturation. One, double bond equivalent. But the last name, index of hydrogen deficiency, this is giving a very good idea. See why? Something is less. So if I write C6H14, this is saturated carbon, nothing is less. But if I write C6H12, then compare in between two molecules. Just compare in between A and B. How much molecule is less? What molecule is less? How many H2 molecules are less? H2 molecules are less. That is going to be the dV. That is going to be the dV, double bond equivalent, du, degree of unsaturation, ISD, index of hydrogen deficiency. Whatever the number of hydrogen molecules are less, that is going to be your dBE. Tell me, if you compare this C6H12 with C6H14, how many hydrogen molecules are less? Write down in the chat section, then you will find out. H2 means 14, 12, 2 hydrogen atoms, that is going to make one H2 molecule, one H2. So its dV is coming out 0 and its dV will be 1. Now you will say, sir, what is this? Just give formula, some formula. We are not able to understand. We need formula. We need formula. So see kids, the same thing. First, let me visualize. The first thing, let me make it clear. Before letting you know the formula, let me give you the visibility, visualization. Because formula just increases the speed. Formula will never give you the accuracy. I will give you the formula, but first let me make it very clear. Suppose kids, I am writing C6 H14, C6 H12, C6 H10, C6 H8, C6 H6, these many compounds. And if I am talking about without formula, just who is going to tell me that dBE or du for these compounds? Just try to understand degree of unsaturation. Let's talk about degree of unsaturation for these compounds. See to it kids, this is saturated, so 0. How many molecules of hydrogen come? Less, 1. With this, how many hydrogens molecules are less? 2. How many hydrogen molecules are less? 3. How many hydrogen molecules are less? 4. Now the same thing you can calculate with the formula, but formula just increases the speed, will not tell you anything. Just see, du is equal to x plus 1 minus y by 2. X plus 1 minus y by 2, where x is number of carbon atoms, y is number of hydrogen atoms, Apply the formula. Just apply the formula kids. How many carbons are there? Anyone? Let's take this one. C6. So du is equal to 6 plus 1 minus y by 2 minus 6 by 2. So 7 minus 3, that is 4. This is the formula. Kids, if clear, show me green hearts if clear. Not clear, then fire. Then we can move ahead. Either green hearts or fire. Let's see what you are going to give. What's happening, kids? Again and again it's getting disturbed. What's going on, kids? Let me zoom in. Now is it clear? What's happening, kids? Just give me some time, kids. Now let me check it out whether it is proper, kids. Tell me the camera position and just watching it so that everything you can get, kids. Nothing should get missed. And just adjusting the camera again and again so that you can understand each and everything, kids. Now the position of, once again it's not clear. Perfect. Is it perfect, kids? Is it perfect? Yeah, okay. Now see, kids, now see. Now, by chance, if you are asking that if we are having compound like this, C X H Y O Z, nitrogen A, halogen B, or their family members, such a big one, right? Very big compound. Can you see? Any type of compound, any type of organic compound. Now see how to find out dV or du. Once again, x plus 1 minus h by 2. Now what is this h? From where you will get h? Now h is equal to number of halogen atoms plus number of hydrogen atoms minus number of nitrogen atoms. Hello, hi, you have to add. Hello, hi, you have to add. Just subtract nitrogen. Add hello, hi, subtract nitrogen. Add hello, hi, subtract nitrogen. Then you can find out any compounds dB, any compound, the world's any compounds dB you can find out. I will prove it. Later on I'm going to prove it also, right kids? Now, this was the calculation of dB from molecular formula. Let's give you one question so that you can understand what's your answer, whether right or wrong. Question is, calculate dBE for C6H6O. C6H6O. Then the answer will come out. Okay, you find out A 4, B 5, C 3, D 2, E 0. Tell me the answer. Let me check it out in the chat box. What answer you are going to get? Do let me know what's the answer, kids. What's your answer? Kids, fast. Do let me know what's your answer. What's your answer, kids? Baba is waiting for your answer, kids. Just do let me know what's your answer, kids. A 4. Very good, very good. Everyone. Fantastic. 4 is the correct answer and you got it. You are able to understand. Now, dBE is equal to x plus 1 minus y by 2. There is no role of oxygen, whether it is present or absent. It is not going to change the answer. Then 6 by 2, that is 7 minus 3, that is 4. 4 is the correct answer. Very good. Now this was the calculation of dB from the molecular formula. Now I will let you know calculation of dB from the structural formula. Just see calculation of dB from the structural formula. Just see. Oh my god, there is question. So let me tell you calculation of dB from the structural formula. Then I will give questions. Calculation of dBE from structural formula. From structural formula. Now remember that dBE is equal to number of rings plus number of pi bonds. Then I will give you quiz. First let me teach you properly, then I will give quiz. This is the formula, kids. This is the formula for calculation of dB. Right. Let me show you examples so that you can understand properly. Suppose if I write like this, one ring, dB is 1. One ring plus pi bond, dB is 2. One ring, 2 pi bonds, dB is 3. One ring, 3 pi bonds, dB is 4. Now 2 rings, dB is 2. This much is clear? Is this much clear, kids? Now let me take second page. If I, once again question has come. Wait, question, just wait. Now if I say that I am having 2 rings and this is the situation. Now it's dB. This is being naphthalene, and calculate its dBE. I'm writing A10, B7, C2, D0. What's your answer? Baba is waiting for your answer. Let's see in the chat section. What's your answer, kids? Fast. Wow, very good. Now, kids, you are rocking. 7 is the correct answer. And how we have got it? 2 rings plus 1, 2, 3, 4, 5 pi bonds. 5 pi bonds. Clear, kids? Is it clear now? Now, here is the question. Double bond equivalent of the following is? Just tell me. This is the printed question, AIMS question. In AIMS, it has already been asked. Okay, let me check it out. Who is going to give the correct answer? Fast, kids, fast. Make it fast. Yes, kids, yes. Fast, quick. Let me know who is going to give the correct answer, kids. Baba is waiting for your answer, kids. Yes, kids. Tell me, what's your answer? 11. Hey, let's see what's the correct answer. Yay! Winner. Now you're winner. Now you're getting it. Kids. That's really awesome. Now those who are unable to understand, let them make it clear, kids. Now see, this compound is having this CHO. CHO is like this. CH double bond O. Cyanide is like this. C triple bond N. And ketone is given like this. Now just see to it. Those who haven't got it. 2 rings. Number of rings? 2. Number of pi bonds? 1 pi bond. 1 pi bond, 2 pi bonds, and 1, 2 to 4, and 3 to 5, 5 to 7, 1, 8, 9. 9 plus 2, it's coming 11. So 11 is the correct answer. Now let's see another question. Another question on dB. Let's see another question on dB, kids. The compound is given like this. Just see, compound is given like this. You know this compound? This compound's name is phenolphthalein, an indicator, if you know, kids. Phenolphthalein, an acid-base indicator, an acid-base indicator. Now let me give you options. What's your answer? DBE. Calculation of DBE. Let me check in the chat section. What's your answer? Oh my God, so fast. Even Baba is taking too much time. But kids, how you are doing it? Baba is crying, kids. How you are able to do it? Even Baba is in need of time, kids. How you are doing it, kids? You're making me crazy that how you're getting it, kids. Baba is thinking that how these people are getting it, kids. Baba is shocked. Kids are rocking. Baba got shocked. Let's see how to get the answer. Let's see that how many rings? 1 ring, 2 ring, 3 ring, 4 rings. Rings are 4. Ringa ringa roses. Rings are 4. And pi bond? 3, 3, 6, 3, 9, and 1, 10. 10, right? So pi bonds are 10. 10, 4, 14. 14 is the DB. So 14 is the correct answer. Now kids, you're rocking. You're really rocking. Now, how to utilize, what is the use of DB? Baba is going to tell you the use of DB. That's really meaningful. So kids, let me give you one question where you people are going to get failed. Should I give you one question where you people are going to get failed? Should I give you? If anyone is giving you question like this and that person is asking to calculate its DB, then definitely let's see whether you are going to pass or getting failed. Now let's see. This is cubane. It is being cubane. Let's see what is the DB of this compound. Let's see, kids. My God. Some are getting trapped. Some are getting the correct answer. Some of you are getting trapped. Some of you are getting correct answer, kids. Now see, kids. Maximum people are getting trapped over here. They are going for this answer. But remember that this will not be the answer. Remember that this is not going to be the answer. The correct answer will be this one. Now in this case, why you are getting 6? Because rings are getting repeated. Repetition of rings are there. Rings are repeated. For you people, rings are getting repeated. So never do this question with the rings. See the structural formula and count the carbons and hydrogen and find out the molecular formula. So the strategy is find out its molecular formula. Find out its molecular formula. How to find out molecular formula? See, kids, how many carbons are there? Here it's no carbon is over there. There are how many carbons? Just tell me, kids, how many carbons are there? 1, 2, 3, 4, 5, 6, 7, 4. Here is no carbon, no carbon. This is not the carbon, kids. 1, 2, 3, 4. There is no carbon, no carbon. Remember that there is no carbon. 5, 6, 7, 8. And the 3 valency is already done. So 1 hydrogen. Every carbon is fitted with 1 hydrogen. So it is C8, H8. Now apply formula that du is equal to x plus 1 minus y by 2. That is 8 plus 1 minus 8 by 2. That is 9 minus 4. That is 5. Is it clear to all of you kids? You got it? Everyone, you are able to understand now? So whenever there is tough structure, always try to get the molecular formula of that compound. Whatever the structure has been drawn, just try to find out the molecular formula, and then it will become very easy with the molecular formula. Kids, clear? Now, what the DB is going to teach you, kids, that is the $1,000,000 question. What information we are going to get from DB? Just see what information we are getting from DB. That is the $1,000,000 question, and then how it is going to help us in our isomerism. In our isomerism, how it is going to help. Now see, the language of chemistry, I would like to say DBA is the language of chemistry. DBA is the language of chemistry. Now let's see if you are able to understand this. If you are able to understand the language of chemistry, kids, your organic chemistry is going to rock. The way of seeing, the way of thinking about organic compounds, definitely it will change. Kids, let me write down. If you have good command on this, having good command, let me tell you kids, having good command on this, good command on DBE, 50% increase in the accuracy along with the speed will be there. Means that more means whatever you are thinking right now, you are taking 2 minutes, 3 minutes, 5 minutes, you will be able to think just in fraction of seconds. Accuracy and speed both will increase. Accuracy and speed both will increase. It's just like right now you're moving with cycle, bicycle, and if you are having car or bike, then the speed is going to increase, and this bike is having 4 wheels. It's not going to, means that flexible bike is there, you are not going to have accident. Okay, now let's see. If DBA is 0, then compound can't be, then 0 says compound can't be cyclic. Compound can't be cyclic, can never be cyclic. Compound can't be cyclic. Compound can't be unsaturated. Compound can't be unsaturated. Can't be unsaturated. Now you will ask, sir, how? Prove it. How prove it? Then see. If I write down C carbon C4 and H10 and O. Now it can't be cyclic. I cannot make cycle with this, and it will always be saturated. Just see 4 carbons. I am writing 4 carbons and 1 oxygen I have written. Kids, no need to count hydrogen in your exam. Whenever you are dealing with isomerism or anything, maximum time, who takes maximum time? Who takes maximum time? counting number of hydrogens takes maximum time, but DB says don't count hydrogen. Just focus on other atoms. No need to count hydrogen. What DB says? What this DB says? This DB says there is no need of counting hydrogen. This DB says no need of counting hydrogen. Get rid of. Just get rid of counting hydrogen. Just get rid of counting hydrogens. No need to count hydrogens because they are maximum time consuming. So I have written 4 carbons, 1 oxygen. 4 carbons, 1 oxygen. DB automatically says that hydrogen will get balanced. Hydrogens are going to get balanced. See how hydrogens are going to get balanced. See, carbon 3 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, OH. Already see 3 to 5 to 7 to 9 and 110 got. Because it's DB0, it will always be saturated. Suppose if I am writing oxygen, I have written 1, 2, 3. I have written 1. Definitely its hydrogens will automatically come out 10 only. I have not counted. See, I have not counted hydrogen in this. Automatically 100% they will come out 10. Let me prove it. See, let me prove it. Let me prove it. Carbon 3 hydrogens, carbon 2 hydrogens. It's a magic. You will say it's a magic. Just check it out. 3 to 5 to 7, 3, 10. It's a magic or not? It's a magic or not? You will say, sir, really it's a magic. It's a magic or not? Let me tell you. Let me tell you. Let me show you some more magic. Just see. Let me show you some more magic. You will say, wow, sir, wow. Suppose if I am having compound like C4H8O, its dB is how much? Just tell me how much is the dB of this compound. dB is x plus 1 minus y by 2. 5 minus 4 is 1. This 1 dB says, if it is acyclic, first thing, if acyclic means not cyclic, then it must be alkene, or it must be, oxygen is there, it must be aldehyde, or it must be ketone, Now you will say, sir, how? Then prove. Just see. If I say alkene, 1, 2, 3, 4, OH, and I place double bond, anywhere you can place double bond, anywhere. Okay, see. C double bond C, I have written C double bond C, OH I can place over here. Aldehyde, CH double bond O. Ketone, I can write C double bond O, C, not counting hydrogen, C. Find out. I am not going to count hydrogen. Baba is not going to count hydrogen. Hydrogens will automatically get balanced. Just check it out. Just check it out. Let's see. CH3, CH, and CH2OH. Just count 8 hydrogen. 3, 1, 4, 1, 5, 2, 7, 1, 8. Here, CH3, CH2, just count 3 to 5, 3, 8. Anywhere you count CH3, CH2, CHO, they are 8. Second, B. If 1 dB means 1 cycle, it can be monocyclic. Now see kids, if you have drawn cycle for dB1, then it will be having no pi bond. So see, if I write like this, this is okay. I can write like this. This is okay. I can write like this. Now dB I have consumed in the ring. Now how many carbons left? CH2, CH3 I can write, or I can write like this, CH3, CH3. Now you will say, sir, how you are writing? See, I'm just focusing on number of atoms and dV. If number of atoms and dV is okay, hydrogens will automatically get balanced. Just check it out. Everyone just check it out. 4 carbons are there, right? One cycle dV I have consumed one. Then just check it out. Hydrogens will be automatically will get balanced. This I am giving the proof. 2 to 4 to 6, 1 7, 1 8 here. 2 to 4 to 6 to 8, anywhere here. Carbon 1 hydrogen, carbon 1 hydrogen, 3 3 6 7 8. I want to see in the chat section till now you are able to understand. If yes, break. Yeah, I will give break, kids. But first of all, let me. Yeah, they can be alcohol. I will tell you. Don't worry, I will tell you. They can be alcohol. Yes, I will tell you, kids. See. But till now, if you have understood, just do let me know. Till now, you got it or not? Till now, is it clear or not, kids? Yeah, I will tell you one more time. But if yes, till now you are able to understand, show me green hearts. If not, you can show me fire. Baba is ready to tell you again. Don't worry, kids. Don't hesitate. Don't hesitate in asking, kids. Baba is there to tell you each and everything, kids. Baba is for you. Baba is for you, kids. Baba means for students. Baba means devoted towards students. Now see, what they can be more. C4H8O. See, C4H8O. Now some people are asking, is it possible they are cyclic alcohol? Just see, it's dV. I am focusing only one thing. Its dV is how much? Its dV is how much? 1. I have to focus on dV1, carbon 4, oxygen 1. Everything will get sorted. See, if I write like this, I have consumed 4 carbons. I can write here OH. This is alcohol. I can make this alcohol, just see, CH2OH. Just focus on carbon and dV. Just focus on carbon and dV. I can make any structure. See, methyl over here. I can make OH, methyl over here. I can make like this. I can make like this. I can make number of compounds. I can make like this. Carbon, carbon, oxygen, carbon and carbon, double bond carbon. I can make like this. I can make carbon, oxygen, carbon, carbon, carbon. Just see like this. I'm not counting hydrogen, kids. Baba is not counting hydrogen, but hydrogens will automatically get balanced. Okay. Baba is teaching you. Don't worry. Now see, should I count hydrogen? And should I give you the proof that yes, they all are like this only? See. Just focus on carbon, oxygen and dV. You have to focus on dV1, carbon and oxygen. Carbon you have to remember and oxygen. Don't count hydrogen. See, one ring. One ring means how much dV? One ring stands for how much dV? One ring stands for 1 dV. One pi bond stands for 1 dV, right? This thing you have to keep it in your mind. One ring I made one ring. One ring means how much dV I have consumed. One ring means I was having 1 dV. I was having just 1 dV. Either I can make one ring or I can form one pi bond. Only one thing I can do. Suppose I am having 1 rupee coin, I can either buy what to buy. We can't buy anything for 1 rupee, but just remember, if I am having 1000 rupee, either I can buy pizza or I can buy what to say, something else, biryani, chicken biryani, right? Are you getting my point? So 1 is consumed, 1 ring means 1 dV consumed. So carbons 1, 2, 3, 4, hydrogens 2, just count 2, 1 and 2. How many hydrogens? 2 to 4 to 6, 7 and 8. It's coming or not? Here if you want to see, CH3 I have consumed 1 dV, CH2, CH double bond CH2. With 1 dV either you can make 1 ring or 1 pi bond. Are you getting my point? Either 1 ring, 1 pi bond. Let me show you, let me tell you. Suppose, once again the same question. Suppose if I am having compound like C6H6O, okay? Now dV is how much? Its dVe is 6 plus 1 minus 6 by 2, that is 7 minus 3, that is 4. Now my dear friends, I am having 4 dV. How many dVs? 4 dVs. Now what I can do? I am having number of much rupees. Then I can do many things. dV is like rupees. You can do many things. Now see what I can do. Carbon, 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 carbon. How many carbons I have drawn? 1, 2, 3, 4, 5, 6. Now I have done this thing. So 2 dVs got consumed. 2 dVs consumed out of 4. I have placed 1 double bond. Now 3 dVs consumed. Now if I have placed double bond O, all 4 dVs consumed or not? Tell me, all 4 dVs got consumed or not? All 4 dVs got consumed or not? Yes, answer is yes, all they got consumed. Now check it out. Now let me write down hydrogens. 1 hydrogen, 1 hydrogen to make 4 valency, 2 hydrogens, 1 hydrogen. Just check it out. 1, 1, 2, 1, 3, 2, 5, 1, 6. Clear? Now what I can do? I could have done like this. 5 carbon, now 6 carbon. How many dVs have consumed out of 4? 2 rings, 2 dVs. Now I can place double bond at this place. Now I can place 1 double bond at this place. Now see, it is C6H6OH. Now completed. Now you will say, sir, how? How you made it? How you made it? Just see, 1 ring, 2 rings, plus 2 pi bonds, coming out 4. Now if you want to count the hydrogens, they will come like this. See, carbon, hydrogen, carbon, hydrogen, carbon, 4 valency, carbon, 4 valency, carbon, 2 hydrogens will come out, 2 hydrogens, carbon, just 1 hydrogen will come out, carbon, 4 valency. Now check 1, 2, 3, 4, 5 and 6 hydrogens. Now you want to say, you want to make like this, you can make it like this. See, 1 ring, 3 pi bonds, 4 pi bond, 4 dV I have consumed, 1 OH. I can make it like this. This is also correct. Now if you say, sir, anything else you can make? Yes, I can make number of things. See, I can do like this. I can put a double bond. 3 carbons I have consumed. Now 3 carbons I have consumed. 4, 5, 6. How many dVs I have consumed? 1, 1, 2, 1, 3. 1 dV is left. Now you can count. If you want to count hydrogen, you can count hydrogen. They will come automatically. They are correct. See, just check it out. That CH2, C double bond O, CH, 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 CH3. Now see, 2 hydrogen, 3 hydrogen, 4, 5 and 3, 8. Oh my god, I have done some mistake. Let me check it out. 3 and 3, 6. I have added one extra carbon. I have taken one extra carbon. Sorry for that. Either I can remove this one or I can remove that one. So CH2. Now 6 carbons. 1, 2, 3, 4, 5, 6. Now count how the hydrogens. Now this has given one lesson also, that if carbon is extra, then molecular formula will get changed, or dV is getting changed, then the molecular formula will get changed. Now 2, 1, 3, 4, 5 and 6 kids. How many of you are getting it, really getting it kids? Do let me know. Yeah, break I am going to give you. I am just going to give you break kids. But first of all, do let me know that really how many of you got it. How many of you really got it kids? Do let me know. Show me green hearts if yes. Show me green hearts kids. Now, before I give you break kids, first of all tell me that you will come back with the same energy level. You will come with the same energy level, with same Josh. Tell me. Explain the last structure. Okay, last structure I am telling you, then after that I will give you a break. Okay, just see. And kids, everyone hit the like button kids. Smash it. Smash the like button kids. Make it more than 420 everyone. Now see this structure, you are asking for this structure. See, let me make it over here. Just see how many carbons I have consumed. 1 carbon, 2 carbons, 3 carbons, 4, 5 and 6 carbons I have consumed. And dV, 1 ring, 1 pi bond. Okay, here double bond, or otherwise dV will not be cleared. Now see, 1 ring. How many pi bonds? 1 pi bond. 1 pi bond and 1 pi bond, 3 pi bonds. So 3 plus 1 is 4 dB. Got it? Everyone got it? So the structure is clear kids. So let's meet at 8:30. Okay, 8:30. We are going to meet at 8:30, right kids? 8:30 p.m. So it's a break time kids. Let's meet at, come with positive energy. Everyone come with positive energy. It's a break time. Come with positive energy. Let's meet at 8:30. Okay. Whatever the queries you are having, you can ask, whatever kids. But come with positive energy. You have to come with positive energy, right? You have to come with positive energy. Will you come with positive energy? Promise? God promise? Yes. Okay kids, let's meet at 8:30. Okay. Welcome back again, kids. I hope that everyone can hear me, can see me, and you're back. My dear students, just to let me know if I'm properly audible and visible and you are with full on Josh, then I want to see green signal from your side, kids. Let me check it out whether I'm properly audible and visible, kids. Hey everyone, can you hear me? Can you see me? Are you back? Namaskaram. Namaskaram. Every class we have to start like we have just entered, so that we can feel the subject, we can smell it out. Everyone, just to let me know that everyone, are you back, kids? Is everyone back? I want to see green hearts along with fire in the chat section. I want to see mixed colors. That is indicating full on jaws that each and everyone is back. Yes, Kevin Kumar, fantastic, fantastic. Nistishar energy, full on Josh. Yes, I can see that South HSP, and wow, that's really fantastic. Now let me check it out. Monica is there. Madhumita, fantastic. Tina, Dandel, Rakesh, Sudarshan, Raisin, Bhumika, hello. Srapalika, Common, comes Trinity, Elastic, Cloudin, Naveen, Elva, Shooting, Vikas, Nistasian, Shahid, Bashir, yes. Everyone is there. I can see. I don't want to see that chat section should get stopped. I want to see chat should be moving very fast. Gets very fast. I want to see chats moving very fast. I want to see that chat should run out very fast, kids. I want to see the speed of the chat, kids. I want to see the speed of the chat. I want to see it's moving like train. Make it like Mustang car. The chat should run like Mustang. Audi, Mustang, Mercedes. Let's see the resonance. Let's move here. Promise. Ilva studying South Scene team. Yes, let's set go. That's moving very fast. Yes. Now, kids, I was telling you ring chain isomerism. Now see to it, ring chain isomerism. My dear students, just see the ring chain isomerism. What Baba is going to tell you about ring chain isomerism. Now see. Ring chain isomerism. Ring chain isomerism, kids. Let me draw one boundary, and then let me teach you ring chain isomerism. Let's see. So earlier I have told you ring chain isomerism, that I am having C4H8. One form should be cyclic, another form should be acyclic. Now you can feel after the double bond equivalent, you will see that how the same process is going to get changed. Now you will feel it out. You will feel, definitely you are going to feel it out. Just see C4H8. I'm going to write down carbon, carbon, carbon and carbon. Double bond, I have drawn carbon, acyclic. Now I can say I can draw one cycle even like this. Now how I am drawing it, let's see how I am getting it. C4H8, our double bond equivalent will come out, how much gets? X plus 1 minus Y by 2. That means 4 plus 1 minus 8 by 2. So it will come out 5 minus 4, that is 1. So 1 dB is over here, 1 dB is over here. So one is acyclic, one is cyclic. What is the relation in between these two? So definitely the answer is that these two are ring chain isomers as well as what? Functional isomers. Why functional isomers, kids? How can I say that they are being functional isomers? See, if you react bromine water, reddish brown color bromine water with this will not show reaction with Br2 water because it is saturated. It is not having carbon-carbon double bond. So this is saturated. So no reaction. How will you understand no reaction? No color decolorization will be there. No color decolorization. No color decolorization, that means no reaction. But that compound definitely will decolorize bromine water. If you add bromine water, reddish brown color bromine water, it will get decolorized. That means it is unsaturated. So they are functional isomers also, my dear friends. Now you will talk about hydrogens. How to find out whether hydrogens are right or wrong? Just see. CH2 double bond CH2 and CH3. Just see 2, 3, 2, 5 and 3, 8 and each carbon is attached with 2 hydrogens, so it is 8. So the molecular formula is same but structure got changed. One is acyclic, another one cyclic. So the relation is ring chain as well as functional isomer. But whom you are going to give preference? Who will get the preference? Write your famous position. Write your famous position. Who will get preference? Kids, do let me know who is going to get preference. So definitely ring chain isomerism is coming over here and functional is coming over here. If the option is both, then you will go for both. If the option you have to choose only one, then ring chain isomerism will get more preference, and that's why we will say they are RCI. They are RCI. Is it clear? Now, my dear friends, if I give you one question, that if I say that one compound is CH2 double bond CH2 CH3, another compound is like this, another compound is like this, and let me say only 3 compounds right now. I'm having A, B and C, and if I'm asking what is the relation between A and B, A and B are what? Tell me in the chat section A and B, then the answer is RCI and functional isomers. What is B and C? What is the relation between B and C, my dear friend? B and C. Then remember that this is cyclic. This is being cyclic and that is also being cyclic. So definitely they are not ring chain isomers because they both are cyclic. Now what you will say? Now do one thing, what I have told you. CS number, it is a 5 carbon ring, so CS number will come out 5 and 0, 50, and its CS number, because 4 carbons in the parent chain, so its CS number come out 4 and one side chain 141. So CS number is different. Once the CS number is different, they are chain isomers. Now everyone got it? Let me see. Kids, whenever you are getting show me green hearts, no need to say otherwise show me fire. Once you are getting it, always kids, always, yeah, you will get PDF, but kids, fast. Tell me you are getting it or not. Fast kids, fast. I want to see your answer that everyone is able to understand or not. Kids, just to let me know. Always no need to ask for hearts and fire. If clear, show me green hearts. Keep on showing kids, no need to ask. Now, after this, Let me tell you metamerism. Baba is going to tell you metamerism. Metamerism. Remember that. Metamers. In metamers, very, very important, because people are getting confused in metamerism only. Metamerism, remember that functional group will remain same. Functional group remains same. At least one alkyl group, at least one alkyl group around polyvalent, functional group gets changed. Functional group gets changed. Now what are polyvalent functional group and how will it show metamerism? But before moving ahead, kids, let me give you very, very important point, that metamers are either chain isomers or position isomers. They will be definitely either chain or position isomers. Let me write down. Metamers are always either chain or position isomers, But then also we are saying metamers. Why? Because write your famous position. So he's more dominating. Metamers are here and chain positioners are there. Who is more dominating? Metamers are more dominating than chain and position isomers. That's why these are the best notes. Not clear? But who is showing this fire? Fire means you are not able to understand. Only one student is here, two students. Okay, example again, I will explain. Don't worry. I'm here for you kids. Let me explain. Don't worry. Let me give example of it. Let me explain with the example. Don't worry kids. Baba is here for you people, right? Baba will make it clear. Kids, don't worry. Baba will make it clear. See kids. So first of all, let me write down which compounds will never show and which can show. These may show and these will never show. Now first of all, and these may show. May show, never show. See, if I write ether. Now ether is having two valencies. This side can be changed, this side can be changed. Ether is having two valencies. More than one valency, may show. If I write alcohol, now alcohol, this is fixed. Only this side can be changed. This side it has to have OH, so it can never show. Now if I write 2-degree amine, if I write down 2-degree amine, RNH, it is having two valency. It can show, or may show, but RNH2 can never show, can't show. If I write down here ketone, RCOR, may show, but aldehyde will never show. Only one valency will never show. If I write down here ester, RC double bond OOR, may show, but carboxylic acid will never show. If I write down here 2-degree amide, RCO, NHR, may show, but 1-degree amide will never show. Kids, are you getting my point? etc., etc. This point is clear. To show metamerism, at least 2 valencies should be there. If there are no 2 valencies, it will never show, it will never show, it will never show. Kids, are you getting my point? Just let me adjust a bit. I think once again, it's not up to the mark. It's up to the mark. Why? But it's not coming in the camera. Okay. Now, let me show you. Once this point is clear that it is having how much valencies? 2 valencies. 2 valencies. Now you will say, you will ask me that, so what's about this 3-degree amide? Yeah, definitely RCO and R, they may show. If you ask about 3-degree amine, yeah, they may show because 3 valencies are there. These compounds may show, they can never show. Never they can show. This point is clear to all of you kids that they will never show, never. They are not going to show metamerism. Now let me give you examples so that you can understand. Let me give you example. See kids. Example is, let's take one compound C4H8O. Okay, C4H8O. Now I have written oxygen. This side I have written CH2, CH3, and this side I have written CH2, CH3. What will you call it? What will you call it? This side is ethyl. That side is also ethyl, kids. Now, this oxygen on the right hand side, there is ethyl. On the left hand side, there is ethyl. Okay. Now, I'm going to draw another compound. Once again, ether. On the right hand side, I have written N-propyl, N-propyl. And on the left hand side, I have written methyl. So this is methyl. That is N-propyl, normal propyl. Now kids, what is the relation in between 1 and 2? If I ask you this is A, this is being B, what is the relation? So definitely this alkyl group got changed and this also got changed. Both the 2 alkyl groups got changed. Definitely they are metamers. One more relation they are having. 1, 2, the parent chain is of 2 carbon atoms, and here 1, 2, 3, the parent chain is of 3 carbon atoms. So they are metamers. They are being metamers as well as what? Metamers plus they are chain isomer. But write your famous position. Write your famous position. So who will get preference? Metamerism will get more preference. Now, the story is not completed. Still the story is there. Story is there. Now see, let me write down one more compound. CH3O, CH3 and CH3. This methyl and this methyl is same. The 2 methyls are definitely same, but this is being isopropyl. Isopropyl, and what I have told you kids, what I have told you, at least on one side if the alkyl group is getting changed, just see the definition, what I have written. At least, can you see what I have written? At least on one alkyl group around the polyvalent functional group gets changed, then we will say they are metamer. I'm not saying both the 2. If 2 are getting changed, it's okay. Even if 1 is getting changed, they will be metamers. So see here that this is remaining same, but this has got changed. So they are also metamers. But along with metamerism, there is one more relationship. What is that? See, 1, 2, 3. The parent chain is of 3 carbon atoms. There also parent chain is of 3 carbon atoms, 3 and 3. in both the parent chain is of 3 carbon atoms. That is okay, but the position of functional group was 1. This was located at first position and this is located at second position. So I will say this A, B, C, that the relation in between B and C, if I say the relation between B and C, they are position isomers as well as metamers. They are metamers and position isomers. So all 3 for this compound we will have all total 3 metamers, and see we have got 3 metamers. And do you remember, kids, the same thing I have drawn for secondary amine. The same thing I have drawn for secondary amine. Do you remember? For secondary amine, if I put here NH, 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 then at that time we have got 3 secondary amines. The formula C4H11N. Now kids, if it is clear, show me green hearts. If it's not clear, then fire. Iso and neo I will tell you. Don't worry, Rakesh. Don't worry, I will tell you. But first of all, do let me know this is clear or not. Is this clear to each and everyone or not? Is this clear to each and everyone or not, kids? Wow, thank you, kids, thank you. Only 1 fire I have got, 1 fire. Rest of it is clear. Very good, very good. Now let's move towards functional isomerism. Functional isomerism, kids. Functional isomerism. Now functional isomerism, kids, now it will become very easy. How it will become very easy, kids? Because now you know DBE. Once you know DBE, kids, each and everything will become very clear. Now see, kids, let me show you. Functional group should get changed. Functional group must be changed. Now kids, this is risky also. If you are not paying proper attention, then you will get failed, because it's not that easy. If you are not taking care, you might be getting failed. So just try to understand. Once what I am writing, just focus. 1 degree, 2 degree and 3 degree amines or amides, they are treated as different functional groups. Remember that they are treated as different functional groups, my dear student. They will be treated as different functional groups. Remember this. Now alcohol and phenol, they will be treated as different functional groups, kids. Then that means if I write down one compound like this, cresol, this is orthocresol. What is the name, kids? Orthocresol. And this is benzyl alcohol. Now see, both are having same molecular formula. The molecular formula of this orthocresol and the molecular formula of this benzyl alcohol. Now you will say this is alcohol and that is phenol. How, sir? Remember that. How to identify which one is alcohol, which one is phenol? Just see, if double bonded carbon OH is attached to sp2 hybridized carbon, then this is acidic, this is phenol. And if it is attached with sp3 hybridized carbon, then this is basic and this is alcohol. Is it clear? So this point means $1 million. In the starting, Kids are cramming whether this is the functional isomer of that compound or not. But no need to cram, kids. Just we should have knowledge of double bond equivalent. You can do, you can rock, you can make question easy peasy lemon squeezy. It is going to be done and dusted. Let me show you. Suppose if anyone is giving you question like this, if somebody has given question like this, which is not, just see, I will give you tough question. Question is, which is not the functional isomer of, valeric acid. First you try, then I will explain. Now kids, those who don't know what is doing valeric acid, definitely they will never be able to do this question. Now remember that valeric acid means CH3, CH2 whole thrice, COOH, 5 carbon atom. 5 carbon atom is known as valeric acid, and 6 carbon acid is known as caproic acid. Remember that. Mark my words. Categorically, I am telling you this particular point. Always keep it in your brain, my dear students. Now see. Option A, I am giving you option A, CH3, CH2, C double bond O, C2H5, first option. Now second option, B option I am giving you, COO, 4 carbons, 5 carbons, already utilized 5 carbons, so let me write down 5 carbons. I have utilized 5 carbons, right? C, option C. If I write down D, one, two, three, 4, 5, and E. Now, this is the question. I have framed out this question. Many people will give many answers. Now you do let me know what's that. Oh my God. Somebody has already written the answer is A. Oh my God. Let me check it out. Whether you answer which is not the functional isomer of valeric acid, kids. Don't do it fast. Kids. Everyone. Kids, you are going with A. Some are going with B. Kids, just apply your brain. Don't mark like this. Apply your brain. Maximum people are going for A. Some are going for B. Kids, what is this? Let me tell you. See. You just focus on valeric acid. How many carbons are there? 1, 3, 4, 1, 5. So, carbons are 5 in valeric acid. Agreed? Everyone agreed? How many carbons in the valeric acid, kids? How many carbons? 4 carbons. 4 carbons. How many oxygens? 2 oxygen atoms. dV is equal to 1 dB, right? Okay. Now see. 1, 2, 3, 4, 5 carbon. 5 carbons, okay. Oxygen 2, okay. Oxygen 2, okay. And Dv1. So definitely it is the isomer of that compound. It has to be isomer of that compound, and it is ester. So definitely carboxylic acid and esters are functional isomers. Why you are giving answer A, which is not? They are writing not. They are not asking which is. Have you studied not, or you missed not? Now see, 4 carbon, 1 ring Dv1 and 1 pi bond. 1 ring and 1 pi bond is making Dv is equal to 2 and its Dv is 1. So this is the answer. This is not the isomer. Now see, 1 ring, only 4 carbons. This is also the answer. This is also answer. Now 1, 2, 3, 4, 5 carbons, 1 ring. This is not. These two are the answers. They are not the isomer of valeric acid, because here carbon is less, only 4 carbons. Here Dv is more. 2 answers, B and C being the answer. B and C. Everyone got it? If yes, I want to see green hearts. Some people have missed not. Yes, yes. Now 2 are the answers. If it is clear, show me green hearts, kids. Sujata, mixed. Mixed means somewhat you got it and somewhat you missed it, right? Mixed reaction, missed carbon, multiple options. Yes, this question B and C both are the answers, both having the answers. Now Baba handwriting is really nice. Oh my god, thank you, thank you. Oh great, thank you. Baba is really happy. Somebody has appreciated about my writing. Baba's writing, thank you, thank you. Now in this way, let me give you one more question. Baba will give you one more question. Okay. Question is, which one is isomer of methyl propanoate? Now for this you should know IUPAC also. If you don't know IUPAC, you won't be able to do the question. Methyl propanoate. First option, butanoic acid. Second option, CH3, CHOH, CH2, CH double bond O. C is CH3, CHOH, C double bond O, CH3. D is E is your favorite option. I am giving you all of these. Let's see how many of you are going for this, all of these. Now let's see what's your answer, what answer you will go for. Thank you, Harshin, thank you. Sujata, you got it? Okay, thank you, Sujata. I was thinking that mixed reaction, but thank you for making it clear. Thank you, Sujata. Now some are going for D, some are going for A, Thank you, Sai Pravalika. Thank you, so nice. Baba is really happy. Thank you, Ruby. Thank you very much. Thank you very much. Now see, kids. What's your answer? People are going for C, B, E. What is this? Everything you are going to mark for. Now let's see. First of all, we should know what is the IUPAC name written over here. If we are really not able to understand, we are not able to decode this compound, we won't be able to do anything. Just see what a compound is. Methyl propanoate. I'm getting sense of ester. Hey buddy, you are ester, methyl propanoate. So you are CH3, CH2, C double bond O, OCH3. So you are like this. So it is having how many carbons? This compound is having 4 carbons, 2 oxygen atoms. This is looking like 20. So let me write down 2 oxygens, and dV is coming out 1. So I have to take care of double bond equivalent, especially carbon and oxygen. Now see in the first one, butanoic acid. If I write down butanoic acid, CH3, CH2, CH2, C double bond O, OH. So I have taken 4 carbons, right? 2 oxygens, right? 1 dV, right? This is okay. Now here 1, 2, 3, 4, 4 carbons, okay. 2 oxygens, okay. dV1, yeah, okay. Now 1, 2, 3, 4, 4 carbons, okay. 1 dV, okay. 2 oxygen, okay, okay. 1, 2, 3. Oh my God, here I have done mistake. So kids, only 3 options are correct, but let me write down CH3. It's my bad, kids. Now 1, 2, 3, 4, 4 carbon, 1 dV. Now answer will come all of these, kids. Now all of these will come. Otherwise Baba did one mistake, because there was only, I have written 3 carbon atoms, 4 carbon atoms. It would have been, then E will be the answer. Kids, got it? So in D, oh yes, Murugu Latha, you are right, because I haven't taught you IUPAC. So don't worry. Definitely I will take IUPAC next. Now if you got it, show me green hearts, kids. Really, if you got it. If you really got it, kids. Okay, now after the functional isomer, the most important, kids, this is going to consume time, tautomerism. Tautomerism, kids. Tautomerism, very important, very important. So are you ready? Because it holds a hell lot of weightage. But before going towards tautomerism, let me check it out. That let's do some questions. Here is the question. See, the compound having molecular formula C4H10 can show. What's your answer? Compound having molecular formula C4H10 can show. Then definitely the answer will be, I think, all of these. Baba to go for all of these. What do you say? Baba will go for all of these. Just see, all of these, right? Now another question based on tautomerism. I will tell you after some time about tautomerism. I will tell you. Now this is the question. Here is the question. Just see to it. Total number of structural isomers possible for C5H11Cl. Do you remember what I have told you? That C5H11 forms how many monovalent radicals? 8 monovalent radicals. So answer will be definitely 8. You know very well, right? You know very well. This answer you know very well, kids. So 8 is the correct answer. So these are the questions which have been asked number of times in number of examinations. Now see, An alkane can form structural isomers if the number of carbon atoms. This is a really brilliant question. Simple question but brilliant. I would like to see the answer of this question in the chat, kids. This question is really awesome, kids. Now tell me the answer of this question, because this is very, very important. Let's see who is going to give the correct answer. An alkane can form structural isomer if the number of carbon atoms is or equal to greater than. Fast, 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 kids. 4. Yay, yay, yay. You are my HSP and army. Very good. Baba is so happy. Baba is so happy with your performance. Baba is really happy. Now see. Kids, compound with C4H11N as molecular formula can exhibit. This holds a hell lot of weightage. I've told you it is very, very important. So definitely its answer, Baba will go for all of these because it can show all of these. Wow, really great question. Now see, kids. Functional isomerism is not possible for. Functional isomerism is not possible for. Just think about it. So the answer, alcohols, aldehydes, alkyl halides, cyanides. What should be your answer? What should be your answer? What answer? Because this really holds a hell lot of weightage, because aldehyde can show, cyanide can show, alkyl halide can't show, alcohols can't show, but better answer out of these two definitely will come out alkyl halides, because they halogen, they will always carry halogen, but this alcohol can show with ether. This alcohol can show with ether. Let me show you that ethyl alcohol. If I take ethyl alcohol and if I write down ether, methyl, oxygen, methyl, then they are functional isomers. Aldehydes can show with ketones. If I take CH3, CH2, CH double bond O, this is aldehyde, CH3, C double bond O, CH3, this is ketone. They will show cyanide. If I say cyanide will show functional isomerism with isocyanide R and C, Rani Sa. So they are also functional isomers, but alkyl halide will never show, right? Gets alkyl halide will never show. Now, the type of structural isomerism shown by given compound. Just see what type of isomerism. This holds a hell lot of weightage, and really it is important question. I want to see the answer in the chat section. Tell me. So definitely you see this is sulfur like oxygen. This side is being methyl. That side is propyl. This is methyl isopropyl. You will remember that these two are metamers as well as 1, 2, 3 chain is of 3, 1, 2, 3 chain is of 3 metamers and position isomers. But we will give preference to metamers. So, oh my god, position, tautomerism, functional ring chain. Oh my god, see kids, metamerism is missing. There is no written metamerism, so we will go for position isomerism. See kids, brilliant question. They are metamers, but metamerism is not given in the option, so we will go for position isomer. So the answer is position isomer. You got it, kids? Everyone understood? Everyone understood, kids? Now, see this question. The pair that represents chain isomer. Now, let's see chain isomer. Here the parent chain is of 2 carbon atoms. Here also 2 carbon atoms. Propyl alcohol, isopropyl alcohol. Now, let's draw propyl alcohol. Propyl alcohol is CH3, CH2, CH2OH, and isopropyl alcohol CH3, CHOH, CH3. It is also having 3 carbons, so chain is not different. 1, 2, 3, 1, 2, 3. So that is also not answer. 2-methyl butane and neopentane. Let's make for this butane 1, 2, 3, 4 carbon, and 1, 2, 3, 4 carbon. At second position they are saying write down methyl. So at second carbon they are asking to write down methyl. And a neopentane is like CH3, CH3 and CH3. Now let's see, the parent chain is having how many carbon atoms? Therefore here 1, 2, 3. So this is the answer because 4 and 3. So we will go for the third question. That is going to be the answer of this question. Now very good. This is the answer. Now let's see. Now maximum questions are based on tautomerism, kids. Okay, but see this question. Everyone, I want to see answer from your side for this question. Everyone, just to let me know what's the answer, because you have to get full marks. Kids, to get full marks, you have to write down in the chat section. Let me see your answer for this question. Everyone, I want to see answer in the chat section, kids. I want to see answer in the chat section. Fast, kids. Kids. Everyone, do let me know what's the answer of this question. What you will mark? You are going for D. Someone is going for D. Someone is going for C. Let me explain. The pair among the following that does not contain, remember that they are asking does not contain position isomerism. Now see, 1, 2, the position of OH got changed. This is not the answer. Now 1, 2, 3, 1, 2, 3, the position got changed. This is not the answer. Now 1, 2, 3, 4, double bond 1, 1, 2, 3, 4, position got changed. This is not the answer. Now 1, 2, 3, 4, 1, 2, 3, 4. Now the position is remaining CN1. This is the answer. See, in here cyanide is secondary suffix, most priority group. So numbering will always start from 1. But see, if you count from here, no, I have done the numbering wrong. See, its numbering will start from 1, 2, 3, 4, 5. The parent chain is of 5 carbon atoms, and there the parent chain is of 4 carbon atoms. Its CS number will come out 5050. Its CS number will come out 1 alkyl group 41. So CS number is different. It's a CS number is different, then they are going to be chain isomers. So this is the answer. Got it? This is the answer. Everyone got it. I hope that everyone is able to understand, kids. Now let's see this question. The number of chain isomers. Now you know the trick. You apply trick. I want to see that in the starting only. I've told you trick for this. Wasim sir is there? Is Wasim sir there, kids? Really Wasim sir is there? Hey, Thalaiba, the boss. Let me see in the chat section what Wasim sir is writing. Welcome sir, welcome. Hey bro, how are you? Hey bro, how are you? Ask these kids to make lives to reach up to 500. It's 449. Ask them. Hey bhaiya. Hey bhaiya. Welcome bhaiya. Kids, in the Swagatam of Basim Thalaiba sir, just increase the likes. Make it to reach up to 500 kids. Baba, HSP, OP. No. Basim Bhaiya OP. Basim Thalaiba is OP. Baba is simple Baba. No beard, no hairstyle, nothing. Baba is so very simple Baba. Our Thalaiba is the hero, the great hero. Basim, the great. Basim sir is GOAT, goat. Wow, wow, really happy. Kids, yesterday I was not feeling well. And let me tell you, kids, yesterday I was not feeling well at all. But Wasim Bhai said, kids are on the priority level. Please, sir, you have to take this class. See, kids, Baba is standing over here with full on energy because of Thalaiba Wasim. He only asked for the class. Sir, kids, syllabus, students are the first priority. So I said, okay, bhaiya, okay. Baba will definitely follow. Kids, and Ambika ma'am along with Yava sir, both of them, they are saying, sir, how are you now? How you are feeling? How is your health? I said, I'm so fantastic, super energetic. If the team is there, if the whole team is asking how is Baba HSP, then Baba HSP is feeling really super duper awesome, kids. Okay, kids, love you, oh my God, hearts. Kids, see, these hearts for you people, that you are going to rock in your medical college or IIT, wherever. Kids, this is the love for you, kids, from our team side. See, the team is Unacademy NEET English, and Wasim sir is writing from there only, kids. Team Avengers. Team Avengers. Can you see, kids? Team Avengers. Okay, thank you, sir. Thank you, sir. Bye. Thank you. Now see, kids, for this question, the answer will come from the trick. The trick was 2 raised to power n minus 4 plus 1. This was the trick, kids. Now for C5, 2 raised to power 5 minus 4 plus 1. How much it will come, kids? 2 raised to power 1 plus 1. So it will come out 3. And for C6H14, it will come out C6H14, it will come out 2 raised to power n minus 4, 2 raised to power 6 minus 4 plus 1. So it will come out 2 raised to power 2 plus 1. So it will come out 4 plus 1. So it will come out 5. So 3 and 5 is going to be the answer. 3 and 5. So 3 and 5. Kids, trick is working or not? If yes, I want to see number of green hearts. See, this question has been asked in IIT, AIMS and NEET. At 3 places, they have asked, my dear students, in all the 3 examinations, this question has been asked, kids. If you are able to understand, then see 3, 3, oh my God. Oh. The number of chain, oh sorry kids, not the structural isomers. I'm sorry. These I have calculated the number of structural isomers, kids. Sorry, this is for total number of structural isomers. Total number of structural isomers. In structural, all will be counted. That means the chain chain plus position, both, kids. Now for this we have to work. Hard how to calculate. Let's see. Definitely for this the chain isomers we know very well. These are 3: N-pentane, isopentane, neopentane, kids. So always read it out properly. This I am saying to me also. Always read out question properly, otherwise that option is also given 3 and 5. See kids, this was the trap. This was really fantastic trap. Even this option is given. They have asked only chain isomers. They haven't asked structural isomers. If this would have been asked how many structural isomers, then it would be the answer, that 3 and 5. But they haven't asked. Now let's say C6H14. C6H14. So I have already told you C6H14. Let's see how many chain isomers we can draw. 1, 2, 3, 4, 5 and 6. 6 carbons ring. 6 carbons chain. We can find 6 carbons parent chain. 1, 2, 3, 4, 5, 6. Now second one, what we can make? 1, 2, 3, 4, 5 and 1 methyl over here. 1, 2, 3, 4, 5 and 1 methyl over here. But these will be position isomers, so don't do that. Let's make 4 carbon. And let's put 1 methyl at this place, 1 methyl at this place. Now let's make 1, 2, 3 carbon. Let's put 1 methyl over here, 1 methyl over here. Now kids, can you see? 1, 2, 3, 4 we have got. But what is going to be the next one? What should be the fifth one? Because now 3 and 4 option is also given. This option is also given. That option is also given. What do you think? That for 6 carbon atoms, the number of chain isomers, they are chain isomers. Literally, they are chain isomers. Let's see that whether this answer is right or wrong. Now, 1, 2, 3, 4, 5 carbon parent chain. 1, 2, 3, 4 carbon parent chain. 1, 2, 3 carbon parent chain. So I made 1, 2, 3, 4. They are writing 3 and 3. They are the chain isomers only. 6 carbons are there. 6 carbon, hydrogen 14. Now 1, 2, 3, 4, 4. So I made that 3 and 3 can't be the answer. Kids, do let me know. Do let me know that what should be the answer, kids. Kids. Sir, last में 5 carbon. Oh, yes. Wait. Only 5 carbons, right? So if I add one more carbon, over here, then it will get repeated. It will become this one only. See kids. If I add one more carbon, then this is going to become like this only. See kids. It will become like this is the longest chain, and then I will count from here. Then Baba has to count 1, 2, 3, 4. So at second position 2 methyl. So 6 carbon 1, 2, 1, 2. But it is coming different. 1, 2, 3, 4, 5, 6. So it is little bit different. I think nowhere it is. Now how many? 1, 2, 3, 4 and 1, 2, 3, 4. So they are position isomers. So they are not chain isomer, because here also parent chain is having 4 carbons, and here also parent chain is having 4 carbons. So they are position isomers. So we have got 3 only, right? Really good question. Really very good question. Very good question, kids. Very good question. Everyone got it? Just if you have got it, show me some green hearts. Sir, isopentane is always taken in C5. Yes. Isohexane is different. Isopentane is always taken as like this only. Kids, you got it or not? Everyone just show me green hearts if you got it. Otherwise, fire in the chat section if you haven't got it. If it is clear, I want to see green hearts. Very good question, kids. Really awesome question. I would like to say it's really very good question, kids. Rank deciding, yes. It's a rank deciding question. Nalla iriku romba sulubam question, kids. Really awesome. Very good. Everyone got it. You are better than everyone. Better than everyone. Now see. Here. What should be the answer? A functional isomer of 1 butane. 1 butane will look like this. This is 1 butane, right? Now its dV is 2. So if I write 1, 2, 3, 4, this one D1, then 2, that is having triple bond, and triple bond's hydrogen is acidic hydrogen. Why it is acidic, I will let you know, because it is sp hybridized and this is sp2 hybridized, so not acidic. They are functional isomers. So 2 butane pi, 1 butane, wrong, not the formula is not matching. 2 butane, no. So definitely this is going to be the answer, because here 2 double bonds are there. 2 double bonds are present, kids, and there is triple bond. So this is going to be the answer, and definitely this is the answer, kids. I hope that everyone got it. Now let's see tautomerism. So I have to teach methoxy and propanol, or you can do it. They are not tautomers. So they are not tautomers. So let's see what should be the answer. Methoxyethane. Propanol, CH3, CH2, CH2OH. Just see, their molecular formula is same, but one is alcohol, one is ether. This is being ether, kids, and that is being alcohol. So definitely they are functional isomers. I will go for functional isomer. You are going for what? You will go for what? You will go for what? A. You will go for A. I am going for functional isomer. Let's see. Functional isomer. See, kids, functional group is different. This is ether, this is alcohol. So I think you got it. If you got it, keep on showing green hearts. Otherwise, what's the use, kids? Now, Baba is going to teach tautomerism. Very, very important, kids. After tautomerism, I will teach geometrical isomers, then geometrical, then optical. They hold a hell lot of weightage. Now, Baba is going to teach tautomerism. Show me some fire in the chat section if you are ready for tautomerism. Very, very important topic, kids. Tautomerism. Till now, whatever I taught you, this is the most important. This is the most important isomerism, tautomerism. Maximum question will come from here only. Maximum questions will be asked from here only, kids. Maximum question. If I talk about structural isomerism, this part is most important. Maximum questions will come from here only, kids. Now, kids, if I say tautomerism, in this tautomerism, first let me tell you what I say. I consider human beings as what? I consider human beings as what? I consider human beings as an atom. I consider as an atom. And I consider electrons like money. Money is electrons. Now, kids, remember that in this tautomerism, human beings along with money, they are moving. Atom as well as electrons, both are moving. Remember that. Both will move. In tautomerism, if I talk about tautomerism, both will move. The atom, which atom mainly? Atom, the hydrogen atom, along with electron will move. Along with electron will move. Now they will move. Let's move here, let's move here, let's move here, let's move here, let's move here. They will move. Now they will move from 1 to 2. Second atom we will say dyad system. They will move from 1 to third atom, we will say triad system. They will move from 1 to 5, we will say pentad system. Now out of these three systems, this triad system is being maximum important. This is maximum atom. So tautomerism, another name is dynamic equilibrium. In between two forms there will be dynamic equilibrium. So this is the another name for tautomerism, dynamic equilibrium. Now as I said, atom along with electron will move. This is known by another name, and that is known as desmotropism. Desmotropism, its another name is desmotropism. So these are the three names for tautomerism. Remember that these are the three names for tautomerism. Desmotropism means atom along with electron moves. That's why it is known as desmotropism. Dynamic equilibrium, because the two forms of tautomers to remain in dynamic equilibrium. I will tell you, then the Lee-Chatelain principle will also be applicable. But kids, are you ready? 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 Because it will require knowledge. Now see, kids, there is only one example of diode system. Only one example of diode system. There is only one example of diode system. What is that, kids? That is HCN. Right now, hydrogen is attached to carbon. Hydrogen is carbon's property, but if you see another compound, hydrogen isocyanide. Now the hydrogen is the property of nitrogen. You see, from carbon it has gone to nitrogen. From first atom it has gone to second. So these are having two types of relations. They are tautomers as well as they are functional isomers, as well as they are being functional isomers. Now my dear students, why we are saying they are tautomers? Because write your famous position. Write your famous position. Write your famous position. So who is most senior? Tautomerism. Functional isomerism comes after that. That's why we will say the cyanide and isocyanide, they are functional as well as tautomers. So this is cyanide, kids, and that is being isocyanide. I hope that this point is clear to each and everyone. My dear students, is this point clear to each and everyone? Just to let me know. Keep on showing green hearts, some symbols, so that I can understand, because from here I cannot see what you're saying, what you're writing, kids. Baba can see the color, because color visibility is from too far, kids. I can see the color visibility. So keep on showing green hearts and all. Now see, let's move here towards triad system. Triad system is very, very important, kids. Triad system. Now in this triad system, first I will tell you the cramming part, and then I will tell you the whole mechanism. I will tell you both the two things, right? Very good, kids. Now you are looking fantastic, kids. Thank you for following what I am saying, kids. Let me tell you one thing. You are always respected. Students are always respected. Why? Kids, whatever we have studied, whatever we taught, whatever the experience I got, like in 26 years, other teachers 10 years, 5 years, 15 years, they are teaching you just in 7 to 8 months. And all combined, the brain are working, kids, and whatever they know, they are giving you, kids, for your syllabus, for your rank. And you, only one student is gaining the knowledge from 4 teachers. It's not easy job, kids. That's why I always mention this point. I always tell you this point, particular thing, that you are respectable, because it's not easy job to swallow, to engulf, to understand physics, chemistry, geology, botany, maths, and whatever the things, kids. That's why I always respect student, student is really, your presence means a lot to me. Sometimes silence works more than the words that lies in between teacher and student, kids. Love you, kids, and I respect you kids. Thank you, kids, thank you. I can see some people are writing very nice explanation. Okay, thank you kids, really thanks. Now, triad system. I will say that, remember that there are atoms X, double bond Y, single bond Z, and if this hydrogen attached is acidic, if I say this hydrogen is acidic hydrogen, I will tell you how to find out which hydrogen is acidic hydrogen. I will tell you that thing also. Now what it will do, kids, it will move from 1 to 3. It will go from 1 to 3. It will go from 1 to 3. It will go like this. Da da da, ding 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 ding. And the double bond will shift and come in between 1 and 2. It will come in between 1 and 2. Now you must be thinking that how it will come. I will show you the mechanism. Wait, but first I want to put it in your brain, in your hippocampus. Just see. Then its tautomer will be, kids. Its tautomer will be, just see who is going to be its tautomer. Its tautomer will be kids, X, Y, double bond Z, and hydrogen will come over here. Hydrogen will come over here. See, let me do the numbering. 1, 2, 3. So hydrogen has shifted from 1 to 3. Now the question arises, how it has been shifted? But before that, what is acidic hydrogen? How to find out acidic hydrogen, kids? Let me tell you how to find out acidic hydrogen. Remember that alpha hydrogens, if attached to sp3 hybridized carbon, adjacent to olefinic carbon. What do you mean by olefinic carbon? Olefinic carbon means carbon double bond carbon. These are known as olefins, olefinic carbon. Now they are known as alpha hydrogen and they are always acidic. Now let me show you. Let me show you, kids. Don't worry, Baba will tell you each and everything in detail, right? Just see. If I say that C double bond O, CH3H, just see, kids. This is $1 million thing which I am going to tell you. Remember that. This is carbonyl group. Carbo. Somebody is carbo. Hey, carbo, how are you? Let's suppose this is carbo. This is carbo. Hey, carbo, Bebo's sister. Carbo is Bebo's sister. Okay? Let's put some, some little bit of feelings over there in carbo. Hey, you are the sister of Bebo, Carbo, Miss Carbo. Miss Carbo, how are you? How are you, Miss Carbo? So this is carbo. And carbo is nil. Carbo is nil. So carbonyl. Miss Carbonyl. Now, who is neighbor of carbonyl? This side to hydrogen. Hydrogen is the part of this only. This is alpha carbon. The house is carbon. And the one who is living in this house, they are known as alpha hydrogen. And this carbon is sp3. So these hydrogens are alpha hydrogens. So there are 3 alpha hydrogen atoms. 3 alpha hydrogen atoms. Now you will say, sir, I'm so unable to understand, sir. Please once again. Hey, sir. I'm not able to understand. Okay, don't cry, don't cry, don't cry, don't cry. I will tell you again. Don't cry, don't cry, don't cry. Don't worry, don't cry. C, CH3, C double bond O, CH3. Just find out who is carbo. Hey, Miss Carbo, where are you? Can you see where is Miss Carbo? This is Miss Carbo. Hey, who is the padosi of Miss Carbo? Padosi means neighbor. Just the house which is directly attached to Miss Carbo's house. This house is directly attached to Miss Carbo's house, and that is also directly attached. So there are two alpha carbons. This carbon is alpha carbon, and that carbon is also alpha carbon, and they are being sp3 hybridized. So my dear students, there are 6 alpha hydrogen atoms, 6 alpha acidic hydrogen atoms, acidic hydrogen atoms. So it will also show tautomerism. Now if I say this is carbo, now is there any padosi hydrogens? This is the part of carbo only, Miss Carbo's hydrogen only. There is no neighbor. No neighbor means no alpha carbon. So no alpha carbon. So no alpha hydrogen. No alpha carbon. So no alpha hydrogen atom. Now if I ask this one, if you are really understood, first of all tell me, did you understand? Did you understand, kids? Have you understood? Then tell me how many alpha acidic hydrogens are present in this compound. If really you got it. If really you got it, tell me how many. Oh, Tina Dendal, not. Okay. No problem. I will teach you once again. Oh, you are writing no alpha hydrogen. I thought that not able to understand. Don't cry, Baba will tell you. HSP and Army, thank you, kids. You know Baba. Who is Baba? You are able to understand Baba, huh, kids? Yeah, Madhumita, your answer is absolutely correct, Madhumita. 100% your answer is correct. Wow, 5. Yes, 5. Now kids, if you are able to understand, hey everyone, this is 2 and this is 3. 2 plus 3, 5 acidic alpha hydrogen atoms. Now kids, if you really got it, then let me ask some questions. You have to tell me, okay? Ready? I will increase the level. Tell me how many alpha hydrogen atoms in first, then how many alpha hydrogen atoms in second, then how many alpha hydrogen atoms in third, then how many alpha hydrogen atoms in fourth. Now these are the 4 questions. Number of alpha hydrogen atoms. 1, 2, 3, 4. Do let me know. 1, 2, 3, 4. So definitely if your answer is coming like this, 2, 4 alpha hydrogen atoms, then here 1, 2, 3, 4, 5, 6 alpha hydrogen atoms. Here this is carbo, but adjacent carbon, alpha carbon, they are not having hydrogens because these are being methyls. Bond line notation methyl. So 0 alpha hydrogen atoms, and if you see this is adjacent to this 4 valencies, so this is also having 0. Its name is benzaldehyde. Remember that, Very, very important compound, benzaldehyde. This is known as benzaldehyde. Everyone, if you got it, tell me, show me green hearts so that I can move ahead. I can tell you something more, kids. 4600. Wow, wow, Madhumita, wow, Chandrika. Kids, really awesome. You kids are going to change the world. You definitely you will change the world. You are going to be at the top of the world. Baba is really feeling like that. You are going to be the best students in your college. 489. Oh my God. Now I think it is going to become 500. The likes are increasing, kids. Very good. Manasa P. Rohini. Wow. Now, kids. Very good. Now, see, kids. Now, let me tell you the mechanism. Just see the mechanism, how it is going to happen. Mechanism of tautomerism. Just see, kids. Those who don't know resonance, kids, only a little bit of knowledge we require for this. Just little bit isomer, that resonance, little bit of resonance. Sir, Leod is saying, sir, can you tell why 0? Okay, let me tell you. Let me tell you. See, this is the carbon, adjacent carbon, 4 valency, already 4 valency, this carbons, so no hydrogen. This carbon 1, 2, 3, 4 valency already, no hydrogen, no places left for hydrogen. Now see this carbon, alpha carbon, this is alpha carbon, already 1, 2, 3, 4 valency completed, no place for hydrogen, already it's 4 valency completed. I hope that you got it. Now, the mechanism of tautomerism, just see, kids, everyone just see. If I say CH3, C double bond O, CH3. Now if you add NaOH, if you add some base or acid to it, now you know Na will break to give Na positive plus OH negative. Now OH negative is a strong base. Now strong base is singing song. I'm in the search of acidic H. I'm just searching for acidic H. Do you have acidic H? So the compound said, yeah, I'm having 6. Oh, I'm coming. Inge va, just come over here. Just take my acidic H. You are electron rich. Just take away this H. I don't want to donate my electron. My electron will remain over here. Now, the compound has donated acidic H. Now the compound has converted like this. CH3, C double bond O, CH2 negative. Now the negative charge electron is free electron. This electron will say, oh, too much space at my neighborhood. I want to move. So the electron is saying, I am coming. So those electrons saying, oh, you are coming over here. So I have to move. I am going. I'm coming, I'm going. This will shift to that because carbon cannot contain more than 8 electrons. So somebody is over here. If electron is coming to this place, this electron will say, I'm getting shifted. Okay. So electron, just move here. So this electron is moving to this place. Now let's see what will happen. La la la. So I have come at this place and I have come at this place. Now the H plus was moving. hey, somebody has stolen, and this was the catalyst. NaOH searching for its OH negative. Somebody has stolen NaOH H plus and they made water. They are living as water. Now Na plus is saying, hey water, I want my OH negative back because I'm a catalyst. I have to become catalyst once again. Just give. I need my OH back. I need my OH back. Just give my So he is singing song and he is asking for his OH negative. I need you, and I need you right now. So it will take its OH negative and this H plus will say, I am coming. Da, da, da. Now I am yours. He is saying I am yours. Now this compound will change into CH3, COH, double bond, CH2. Now see, once again, this H plus will say, I want to leave. This OH negative once again will come. I will kill you. I will take you back. So this will go once again. Now this negative charge will come. Now it will say, oh, I want to come over here. You just go back to your position. So it will come back like this, and this will come back like this. So it will keep on moving. This process will keep on happening. So this will continue. So the A is converting to B and the B is converting to A, and this movement of hydrogen is known as tautomerism mechanism. You understood? Hey kids, first of all, do let me know you are able to understand the mechanism. Yeah, it's a hydride shift. Nigat, Majid, yeah, it's hydride shift from 1 to 3. Kids, do let me know you are able to understand. Madhumita, thank you. Madhumita is able to understand. Monica, Priyadarshini, wow. Shravan, Sausi is very good. Sausi, fantastic. Niranjan, kids, keep on showing green hearts if you're really able to understand, kids. Wow, I want to see that my kids, they are really able to. Sahana, thank you. Sahana, thank you. Harun, Lafia, thank you. Harshine, Srilekha, Balaji, wow, test tube. Angeline, wow. Now kids, see, let me tell you something more interesting, something more. Now see, kids, oh, here is the question. Oh, Baba, all these slides are getting filled. Now I have to make another slide. Ting, 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 ting. Num, 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 num. Ting, 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 ting. Num, 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 num. Ting, 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 ting. सोचो पूछो दुनिया में क्यों आए, तेरे लिए आए. La 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 la. Na 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 na. नहीं जिंदगी हम यहाँ तुम वहाँ, हम कहाँ जानम जान लो दुनिया. Da ra 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 ra. What's happening this? Oh, where are you? I don't know what you said. Now, my dear students, remember that if I write like this, CH3, C double bond O, CH3. Right now I have told you the mechanism, that this was converting into that and that was converting into this. Now what the name they will give it to this compound, what name should be given? Just see. They are calling it keto because carbonyl group is there. Keto. Everyone say keto. And that one, because the double bond is there. For the double bond, they will say ene. and OH, all, enol, in, double bond in, all, enol. My dear students, remember one thing very clearly, kids. People are asking for sing song. Baba don't know how to. Okay, now see, kids. Now, this is 99%. This keto content is 99%, kids. 99%, and this is even less than 1%, or you can say 1%. Enol is less stable and keto is thermodynamically more stable. Remember that. Thermodynamically more stable form, more stable. Because thermodynamics says this equilibrium is more towards keto side, and equilibrium favors or thermodynamics favors this form more. How many bonds are involved? Actually, this bond is involved, this bond is involved, and alpha hydrogen, this bond is involved, and that pi bond is involved. Actually, this is its pi bond is involved, kids. So 3 bonds are involved, and these 3 bonds energy, whatever is coming, and if it is being compared with 3 bonds, then equilibrium is more towards backward direction. 12 kilocalorie per mole more favorable. 12 kilocalorie per mole. This is more stable. This is being more stable. This form is being more stable. That's why equilibrium lies toward this side. But it's not always like this. There will be cases where enolic content will be more, and the examiner will ask those cases only, kids. The examiner will ask those cases only, kids. So, are you ready? Are you ready, kids? The examiner will be interested in those examples where enolic content will be more than keto content. So, I would like to say that keto content is generally more. Keto content is generally more. I will not say always more. So from this, what idea I am going to get? What idea I am getting, kids? That basically we can say keto content is generally, this word generally is very, very important. Generally is generally more than enolic content, more than enolic content. Now see, kids, see the cases where enolic content is more than keto content. So this is the $1 million thing. Examiner will definitely emphasize on this, will ask number of questions based on this. Cases in which enolic content is more than keto. Cases in which enolic content is more than keto, is more than keto. Now see, kids, the first case, very, very important case, kids. Just focus over here, because examiner will definitely ask this case. Case number 1. Remember that case number 1 holds a hell lot of weightage. Case number 1. When enolic form becomes aromatic, then enolic content will, be 99.99%. Then the enolic content will be 99.99%, kids. See, the thing which was more towards keto side has turned out more towards enolic side. See, now how to find out this case and how to understand this case, just see, kids. Just see. Because this is very, very important, kids, right? Just see. Let me take one example. If I take one example that if I write like this, now try to find out what is going to happen. These are, you see, sp2 hybridized hydrogens. They will not move. They will never move. Which hydrogen will move? This is your alpha hydrogen. Can you see there are, in this compound, there are 2 alpha acidic hydrogen atoms. Can you see, kids? Now, I've told you that hydrogen will migrate from 1 to 3 and double bond will come in between 1 and 2. Have I told you or not? So, according to that, this is 1, 2, 3. Hydrogen will go from here by taking electron to that position, and this will come over here, kids. Now, what should be its enolic form? Its enolic form will look like this. They will remain like that. 1 pi 1 will get shifted over here, and it has become aromatic. Aromatic compounds are highly stable generally, and this was sp3 hybridized. So this compound was non-planar. Non-planar. Right now you don't know how to find out aromaticity. Later on, when I teach you GOC, then I will let you know that aromatic will follow Huckel's rule. But remember that this is 99.9%, so it will not come back, my dear students. 99.99%. This form will be 99.99% because this is highly stable. It is being highly stable. Got it, kids? So just you can remember that benzene, whenever you see benzene has been formed, that means very, very stable. Now see another example. Suppose if they have given you compound like this. This compound has been provided. Now you see how many alpha hydrogens are there. Definitely this is alpha hydrogen, this is alpha hydrogen, this is alpha hydrogen atom. So they will move. Let's move here. 1, 2, 3. So this will come over here. Then 1, 2, 3. This will go over there. Then 1, 2, 3. This will go over there, and double bonds will come in between 1 and 2. So definitely it will become once again benzene. So it is going over here. Double bond is coming over here. So OH, 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 and it will be like this, kids. You got it? 99.99% enolic form you will get. My dear friends, you must have got it. Now after this, I am going to give you one Rhombus example. Vera level example I am going to give you, kids. Yeah, 4n plus 2. Now kids, this much is clear to all of you. Is this much clear to each and everyone? First of all, do let me know, kids. I want to see that everyone till now able to understand, kids. Is it crystal clear or not, kids? Do let me know in the chat section. Very good, very good. That's really awesome. That's really awesome. Fantastic. Now see, kids. One fantastic example. This example is of 1,5 hydride shift. 1,5 hydride shift. Just see, kids. If I draw this compound, just see to it. Now, kids, once you focus on this compound, it will look like that there is no acidic alpha hydrogen atom. You will see. And what feeling you are going to get? You will get this is carbonyl, Miss Carbonyl, and this is alpha but these hydrogens are attached to sp2 hybridized carbon atoms. sp2 hybridized. So sp2 hybridized are not acidic. So these hydrogens are not acidic, not acidic at all. Not acidic, it's not acidic hydrogen. Not acidic. So what you will say, kids? Now you will say that no tautomerism. In the first attempt, most of the students, they will say like that, oh my god, there is no tautomerism because there is no alpha acidic hydrogen. But later on they will realize that this hydrogen, these two hydrogens are attached to sp3 hybridized carbon, and these are acidic alpha hydrogen atoms. So see, X double bond Y single bond Z, X double bond Y single bond Z, and these two are acidic alpha hydrogen atoms. Is this point clear? So they will move, and how they will move now, the case is that 1, 2, 3. So hydrogen will come from 1 to 3 and double bond will go in between 1 and 2. Now just try to understand, this hydrogen will go from 1 to 3 and double bond will come in between this. Now let's see how to draw it. Now the double bond has come over here and the hydrogen has reached over there. Now the compound has become like this, kids. Now the compound will look like this. I hope that everyone is able to understand. Till now it's okay. Now these hydrogens, this carbon has become sp3 hybridized. Now this carbon has become sp3. So these hydrogens have become acidic alpha hydrogen atoms. They have become acidic alpha hydrogen atoms. Now once again they will move from 1, 2, 3. The hydrogen will go from 1 to 3 and the double bond will come in between 1 and 2. Now the meaning, what is the meaning coming, kids? Now let's see. This is remaining over here, this is remaining over here, and this has come over here, and we got benzene. And benzene is aromatic. Benzene is aromatic. Now benzene will say, I will not go back. I am not going to go back. So 99.99% it will get formed. And hydrogen has traveled from which place to which place? If you see, it's 1, 2, 3, 4, 5. It has gone from 1 to 5. And this is very good example of this aromaticity. If everyone got it, I want to see green hearts, kids, because your symbols, wow, Kevin, thank you. That's really awesome, Kevin Kumar. See, kids, some people are so decent that Kevin Kumar is really, wow, thank you. Kevin Kumar, so you're liking my studies? Oh, you like my Tamil? Number of people, they say that chemistry pedikaradu customer, but I would like to say no, it's romba sulubam. So this team Avengers will make your chemistry very, very fantastic. Romba sulubam. Your Tamil, good sir, thank you. Really. Arpudham, Nalla Iruku. What about dinner? Oh, I will after, once I am going to give you break, then in this break Baba will have dinner. Okay? Saucy is always there. Big fan. Danish Ayub, oh my god. Oh my god, kids, your handwriting is also good. Thank you, really. Wow. Kevin, thank you. really you talking good Tamil. Oh my God, Pravilika, Pravi, oh my God. I will give you break, but just let's move up. Let's complete tautomerism along with question. Once I complete tautomerism along with questions, then structural isomerism will get completed. Then Baba will have dinner. Then after that, I will tell you stereo isomerism. Oh my God, so awesome. Okay, let's complete. Okay, kids. Okay. Now, this was the case number 1. Now let's move towards case number 2. Remember that case number 2. You see, in the case number 2, just focus on this compound R, C double bond O, CH2, C double bond O, R. Just remember this compound. Just remember, because number of times they are going to ask question from here. I call it Chotu, CH2 Chotu. I call this one Chotu. This is Chotu. Chotu surrounded by 2 core, COR, COR. The right hand side of Chotu there is core, left hand side there is core. In English, I will say that active methylene group. This is known as active methylene group. This is Chotu is active methylene group. And this is flanked by 2 carbonyl groups. This is Miss Carbonyl. Miss Carbonyl, do you remember Miss Carbonyl? Hey, hey, ha, ha, ha. Miss Carbonyl, la, la, la. Miss Carbonyl, la, 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 Miss Carbonyl. The active Chotu and 2 Miss Carbonyls. Chotu is in the middle and 2 Miss Carbonyls, right? Will you be able to remember it? Will you be able to keep it in your hippocampus? Now, why this Chotu is so active? Active methylene group, that I will explain on the next page. But let me tell you, remember it, mark my words, kids, they are going to ask number of questions that this is Chotu, okay? Now, somebody is writing Chotu. Yeah, now see, kids. If I say that if I take this example, okay, first of all, let me complete it on that page, what I was going to write. Then if you see, whenever you see such type of compound, its enolic content will be, let me write down here only, enolic content will be more than 75%, will always be more than or equal to 75%. Remember this, remember that. Whenever you see such type of Chotu surrounded by 2 Miss Carbonyl, then its enolic content will be equal to or more than 75%. Now, I have to tell you the detailed thing, why and how, what are the reasons. I have to tell you, kids. Are you ready to understand? Are you ready? So if I say the compound is like this, now this compound is having how many alpha hydrogens? How many alpha hydrogens? Then the answer will come out 3, 2, 3. 8 alpha hydrogen atoms. 3 alpha hydrogen atoms. 2 alpha hydrogen atoms, 3 alpha hydrogen atoms. So total 8. But these alpha hydrogens are highly acidic. Now question arises, why highly acidic? Why these alpha hydrogens are highly acidic? Let me Once remove this one and once remove that one, and then I will show you. Suppose it has lost this alpha hydrogen atom, then just see how it will stabilize itself. Now it will do resonance with this one. It will do resonance with this one. It will go over there and that will come over here, and that is applying minus I also. But if by chance this one is going, this hydrogen is left, then see, it will do resonance with this one also, and it will do resonance with that one also. Just see, it will do resonance this side also, that side also. Not able to understand, sir, I am unable, sir, I am not able. Okay, don't worry, let me tell you. Adjacent to it, this is pi bond. It will do resonance with this, like this. Now you are getting it. It will come on this side. It will move on that side also. It will go like this and will do resonance with that also. This much area the resonance is possible, and this side minus I and this side also minus I stabilization. So this conjugate base is more stable. This conjugate base is being more stable. More stability it is getting. Conjugate base is more stable. So the conjugate base is more stable. So this hydrogen is more acidic, highly acidic. Now you got it. This much is clear to all of you. Is this much clear to all of you? Now, let me tell you, kids, why this compound's enol form is more. Just see. Let me write down, kids. CH3, C double bond O, CH2, C double bond O, CH3. Now this hydrogen will move from this carbon to that carbon, 1, 2, 3, right? It will go from 1 to 3, and double bond will come in between 1 and 2. So its enolic form will be more, and why it will be more, I am going to tell you. CH3, C double bond O, CH, double bond C, OH, CH3. Now why it's being moving like this? First factor, the most dominating factor, first factor. Now first let me tell you, this is 76%, 76% kids, and that is only 24%. Now first factor, the first factor is extended conjugation. The first factor is being extended conjugation. Now what do you mean by extended conjugation? See kids, what is the meaning of extended conjugation? If I say kids, that resonance, those who don't know, those who are not having resonance idea, then remember pi, sigma, pi, just like ladder. You know ladder? If ladder is like this, the one which is used in villages just to move or go to the rooftop. So the ladders means this bond, then space, then bond, then space, then bond. Conjugation is there. Now see this pi bond, sigma bond, then pi bond, then sigma, then lone pair. That means its resonance is taking place from here to here. Now after this also the resonance got extended. The resonance got extended and it is taking place from here to here also. This is extra. When you go to buy some car, scooty, bike, they will give you warranty. Warranty they have given Now they will ask for more rupees. They will say, oh, please give me 5,000 rupees. I will extend this warranty. That for more days, for more years, the warranty for 1 to 2 or 3 years, that is going to get extended. So that is known as extended warranty. Extended warranty, right? So here this conjugation is known as extended conjugation. So one reason is extended conjugation, and for 70% enolic content, this extended conjugation is working. More dominating factor. This is being dominating factor, I would like to say. This is being dominating factor. Now, the second factor is that this oxygen and hydrogen, they are forming what? Ta-ta-da! हो गया है तेनू दो प्यार सजना. Intramolecular hydrogen bonding, ring formation known as chelation. Chelation. The second factor is being intramolecular hydrogen bonding stabilization, known as the only nation. The only nation, chelation. Chelation. What do you mean by chelation? Temporary ring formation due to hydrogen bonding. Temporary ring formation due to hydrogen bonding. Intramolecular hydrogen bonding. Now, my dear students, 6 to 7% its role also. This is not that much dominating, but yes. Now see, if you try to see, a little bit of aromaticity is also coming. I will not say this is aromatic compound, but see, 2 pi electrons, and 2, they are localized, but these are delocalized. These two 4, and these 2 6, a little bit aromaticity also coming. So this compound is without conjugation. The keto is being without conjugation. Conjugation means there is no resonance, but the enol is having conjugation resonance, and that's why equilibrium is shifting more towards right hand direction. Now tell me, this is conjugation. Pi, sigma, pi, sigma, pi, sigma, pi. Conjugation resonance. Now let me see in the chat section. If you got it, show me green hearts, kids. Chill, just chill. La 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 la. Chill, just chill. Now, kids, if you got it, wow, Niranjan Pillai is the first one to show the green hearts. Very good. What about rest of others, my dear students? If you are getting Madhumita, very regular. Wow, kids, fantastic. Baba the best. Sausi is very, very dedicated. Sausi, Priyadarshini, Monica, yes, gotcha. Oh my God, Sausi HSPN, thank you. My singing is really good. No, I'm not a good singer. This is for you people only, because you are giving too much time. Baba, please break for dinner. Yes, I will give you Mrugu, but just before that, let's have some questions. Let me complete this tautomerism. Yes, Shubhan, but no problem. Baba never teach for watching views and rest of the things. Baba is always teaching you for your best career. You should become good doctor, engineer. That's why Baba is teaching. Baba never see. Now kids, see, let me tell you one thing. Now how it will move. Now remember that this thing I have told you right now, R, C double bond O, CH2, C double bond O, R. Now remember that if if both are phenyl, remember that phenyl, if both are phenyl, then the enolic content will be 99%. If 1R is phenyl, then it will be 90%. If both are hydrogen or alkyl, then it will be ranging from 75 to 76%. So it will always be more than 50%. Now you will ask, what happens when both are phenyl? Then why it is getting increased? Let me show you, let me tell you. Suppose this is phenyl. CH double bond COH. What has happened? How the tautomerism took place? From one hydrogen has gone from here. So double bond CH OH and one phenyl at this place. This is the enolic form. Now see from where to where resonance is taking place. Pi, sigma, pi, 1, 2, 3, 4. This H is not there, I think. Yeah, this H should not be there. Now, everywhere resonance is taking place. So, resonance will take place in the whole area. In the whole area, resonance is taking place. So, electron is moving from there to there and here. The delocalization of pi electron is present everywhere. Maximum area on the compound, delocalization is present. So maximum stable, therefore maximum stable it's like this. Got it? This is the reason why it is 90%. Now kids, let me tell you very important thing. Now those cases are completed. Now there, let me tell you one note. Then I will give you questions, right kids? Note is that esters do not tautomerize. Esters do not tautomerize. Now what is the reason why esters do not tautomerize, kids? Everything is having reason, nothing to cram, everything is having reason. Suppose if I am writing ester, this ester, right? If I write down C double bond O, OR. Now suppose if NaOH is coming, NaOH OH negative is coming to snatch the proton of this carbon, it will try to snatch this proton, right? It will get negative charge. Now once it is going to have negative charge, it will look like this CH2 negative, C double bond O, O, R. Now this carbon will ask to this carbon, hey, just do resonance with me, but oxygen will say, don't do resonance because I'm busy with someone else. I'm busy with someone else because it is doing its resonance with this carbon. Very, very good resonance. Very, very good resonance. Then this carbon will feel lonely, solitary, alone. Now it will say, oh my God, I have donated my hydrogen. Now no one loves me. No one is doing resonance with me. Hey hydrogen, come back. so it will not go to that side. It will come back, it will take its proton. So this hydrogen is very, very less acidic. So once this hydrogen is not going to move, so it will not show tautomerism. It will not show tautomerism. Kids, got it? Everyone got it? Just to let me know. Just to let me know, kids. Yeah. So no one is going to love that carbon. That carbon started crying, mommy. Everyone. Crying. This is crying. Crying, crying, crying. This one is crying. Crying for hydrogen. Oh my love, no one loves. They are busy, they are busy, they are busy. Why they are busy? They are having good resonance because their orbitals are of same energy. Oxygen and oxygen, they are having same energy level. So they are having same energy level. So no one is going to love him. So he is saying, I will not leave my H. That is highly unstable. Highly unstable conjugate base. That's why he is crying, highly unstable. Clear, kids? Clear? Everyone, is it clear? Oh my God, what you are writing in the chat section? Let me see. The chat is full on. Wow, yay. So funny, Baba. Okay. I'm busy with someone else. Yes, he said that I'm busy with someone else. I can't do resonance with you. Just go. Go back to your home. Yes, now. Remember that there is one type of aster in this world. The note's second point. This was the first point, note's first point. Now the note's second point. Remember that there is one aster with active methylene group. Active methylene group. Its name is EAA. Everyone say EAA. 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 How it will look like? See. This much is ethyl, this much is aceto, and this much is acetate. Just see, I will write its name and try to understand. Ethyl, color combination, just see, aceto, acetate. Ethyl, aceto, acetate. In your organic chemistry, you will see this compound is formed during Claisen condensation. I will teach you during name reaction, during Claisen condensation. Now see, compounds is having active methylene group. So its enolic form will get benefit of hydrogen bonding. Already it is having resonance. See, it is busy with someone. This one, they are having very good resonance. Good resonance. So that this compound is not going to get any benefit of resonance, but which benefit it will get? Just see. It will get benefit of intramolecular hydrogen bonding, chelation. And chelation's role was 7%, 6 to 7%. So its enol will be 7% and this will be 93%. From here they will ask. Now the question part is left, kids. Till now whatever I taught you, I have told you each and everything. After break we, yeah, okay. Okay. Yeah. So let's have one break and we will do question practice after the dinner. Okay. It's everyone is asking for break. So dinner break. So right now it's 22:39. What time we should meet, kids? At what time? 40. So 11:10. At 11:10. 11:10 is okay, kids. Do let me know. 11:10. No, the percentage is experimental. I'm not calculating. It's experimental. It's experimental. Percentage no one can determine. It's experimental, kids. Percentage is being experimental, kids. Okay, so let's meet at 11:10. 11:10, okay? Okay, kids. There's short break. Let's meet at 11:10. Dinner break. Welcome back, kids. Just to let me know, am I audible and visible to all of you kids? Just to let me know, everyone, Baba is back. Now, kids, this will be the sequence, because you must be asking what you are going to teach us now. First, structural isomerism, I will complete with tautomerism question, then geometrical isomerism, and this in the geometrical isomerism, these are the parts: alkene, polyenes, ENZ, cycloalkenes, allenes. After completing this portion about geometrical isomerism, along with the questions, this will take time, because optical isomerism holds a hell lot of weightage, and in optical isomerism, this will remain the sequence. Pos, cos, enantiomers, calculation of total number of optical isomers in that meso also, R and S configuration, T and L, 3O and Ri 3O, I will tell you, and then epimers and anomers, and then conformational isomerism, kids. So, kids, how is everyone? Let me see. How is everyone? Just to let me know, kids. Sahana HSP, thank you. Priyanshu, thank you. Thank you. Thank you. Sir, what did you eat? Rice, biryani, veg biryani. Baba has consumed veg biryani, kids. Now, I can see that everyone is able to hear me, see me. That's really awesome, kids. Really awesome. So, should we start with the questions? Sahana, thank you. Afia, thank you. Siddharth, thank you. And Rahit, Arpit, Meena, welcome, 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 kids. Really awesome. Harshin, welcome, welcome, Harshin. Anamika, South Sea, welcome. Madhumita, thank you. Hafiz, everyone, kids, everyone. Now let's start. Vijayasri, welcome. Duration, please don't ask duration. I believe in giving content. Baba believe in giving content, not the duration. I understand, but what to say, kids? What to say? What to say? It's very tough to tell you the duration, okay? Because number of times kids are asking twice, thrice. So understanding is more important than the duration. Tell me, should I move according to the time, or should I move according to your understanding? So understanding is more important. You kids means a lot to me, kids. Thank you, thank you. Who is this boy, girl? Rahit, thank you. Sai Vamsi, thank you. Rakesh, thank you, thank you, thank you, thank you. Now let's it go with the questions. Let's move out with the questions, my dear students. Now let me tell you all type of questions based on tautomerism. Okay. First type of question, what type of question they will ask? They will ask which will show tautomerism. But before telling you, let me tell you Bradit's rule. That means a lot. Bradit's rule. This rule says, kids, what this rule says, that bridge had a carbon, bridge had carbon in bridge bicyclo, in bridge cyclo, in bridge bicyclo up to 7-membered ring can't be sp2 hybridized, can't be sp2 hybridized. What is the meaning of this? Let's see. For example, if I say this compound, the positive charge, this is not possible. Or if I say this compound, the double bond is also not possible. These two things are not possible because this is bridgehead carbon. Remember that? The one which is having three directions where the two cycles are meeting, this is bridgehead carbon, and it cannot be sp2 hybridized. Cannot be sp2 hybridized. That means these two things does not exist. These two compounds doesn't exist. They are not having their existence because they are highly unstable. So though these two compounds, they don't exist. Right, kids? Highly unstable. So no existence, does not exist, no existence. Got it, kids? If this point is clear to each and everyone, then you can understand each and everything, kids, right? Now see, the question is, which compound will not show tautomerism? Which compound will not show tautomerism, right? So this type of 2-3 questions will come in your examination. So let me tell you, let me show you all type of questions, all variety of questions, what they can ask. Whatever the questions Baba is framing out, they are very, very important. Remember that. If you ask your seniors, they will tell you that maximum questions have been asked from Baba's notes. Directly these questions will come on an examination, right? What's your answer? What do you think? What should be your answer, kids? Do let me know. What's your answer? Let me see in the chat what answer you are going to give. Yes? Yes, kids? Waiting for your answer. Very good, Praveen. This is the spirit. That's fantastic. Now see, kids, the answer will be definitely this one. Why this is the answer? See, this hydrogen cannot move because a double bond cannot come over here. But these two hydrogens, they can move. So it will show. Here, methyl groups are placed. And this hydrogen cannot move. If this hydrogen is moving, see, if this hydrogen is allowed to move, then it will go like this. 1, 2, 3. It will go from 1 to 3. And the double bond will come in between 1 and 2, and its tautomeric form will look like this. And kids, what's the problem in this compound? Just see, you see to it. This compound will look like this. Now see, the problem arising over here is that this is sp2 hybridized carbon and it cannot be attached with double bond. So this does not exist, so it cannot move. This is having alpha hydrogen, no problem. And this is having alpha hydrogen at this place, so no problem. That is the answer. I hope that this point is clear. If yes, keep on showing green hearts so that I can understand that you are getting it, everyone. For this question, what's the answer, kids? Fast. Let me see in the chat who is going to give the answer. Fast, fast, kids, fast. So definitely, this question's answer will be yes. Let me know. So definitely, this is going to be the answer. Why, kids? See, this is your carbonyl group and this is alpha carbon, but it is sp2 hybridized. So this hydrogen is not acidic at all. This is not acidic at all. Rest of the compounds, we are having definitely acidic hydrogens, so there is no problem. See, 3 alpha hydrogens, they are acidic because they are being attached with sp3 hybridized. This is here no alpha hydrogen, but if you see with respect to this carbonyl group, then we are having alpha hydrogens, 4 acidic alpha hydrogen atoms we are having over here, and this compound here we are having that pentad system will become aromatic, we know very well. So this compound will not show because this carbon is sp2 hybridized. If you got it, is it okay? Now let me move towards the third question. The third question will be like this. Formaldehyde, they will write down the name, journal names. So journal names you have to remember: formaldehyde, benzaldehyde, chloral, all of these. So my dear students, if we don't know the journal names, we cannot write down the structures, and we are not able to write down the structures, then we are not going to solve this question. We won't be able to solve this question. Now see, the journal name formaldehyde, you see formaldehyde is this one, HCH double bond O, no alpha hydrogen atom, no alpha hydrogen, right? If you know the structure, you can find out no alpha hydrogen. Benzaldehyde is like this. This is being benzaldehyde, no alpha hydrogen atom, no alpha hydrogen atom, so will not show. No alpha hydrogen atom, so will not show. Chloral is CCl3 CHO. It is also not having alpha hydrogen. Otherwise, if you know first two options, then definitely all of these is going, because remember that if you know 50%, then options are going to help you. If you don't know even 50%, then options, they are going to create confusion. You won't be able to do question, right? So this is chloral. Once again, no alpha hydrogen atoms, no alpha hydrogen. So all of these is the correct answer. Now, second type of questions, what type of question they are going to ask? They will ask question like that, very, very important. Arrange the following in decreasing order of enolic content, decreasing order of enolic content, decreasing order of enolic content, because it is very, very important, this type of question. Definitely they will ask it. Now let's see. Number of times when I was writing, kids were asking, sir, how to find out percentage? There is no need to find out percentage, but at least you should have an idea about it. Then only you can solve questions. Otherwise, you won't be able to solve the questions. Just see the question. These questions are very, very good questions. They are going to ask it. Suppose they are writing. Okay, before doing this question, such type of questions, let me give you one-liner trick so that everyone can try. At least you can try it out. So let me give you the that trick so that everyone can do it. Otherwise, this type of question you won't be able to do it. So let me give you that trick, kids. First, I will give you that trick, then try it out. Okay, just see. The percentage of enolic content in decreasing order. Now see, kids, definitely it will help you. First is, if enol is aromatic, remember that if enol is being aromatic, aromaticity is there, then 99.99% enolic content will be there. Then after this, R, C double bond O, CH2, C double bond O, R. Its percentage varies from 99% to 76%. Now these two, remember, these two are really very, very important. So first try to keep these two in your brain. Now after this, that ester, EAA, R, C double bond O, CH2, C double bond O, OR, the ester with active methylene group, ester with active methylene group. Its enol is being 7%. Now this first liner you have to remember. After that, it's simply R, C double bond O, R, normal aldehyde and ketones. Its enolic is being 1%, and then it will come normal esters. Normal esters, they do not tautomerize. 1 out of 1 million, so I will write 0.000000001% will tautomerize. This I have told you. This will help you a lot. This is Baba HSP's trick. Nowhere you will get. You will get it only over here. Baba HSP's trick, kids. Now, if you remember this, even if you not having the percentage in your brain, then also you can do questions. Now, kids, should I give? See, kids, one spammer is there. Whenever the spammer is here, keep on putting green hearts so that spammers can't do spamming. This is the best. That should be the best revenge. Whenever spammers are there, keep on putting green hearts, fire, so that spammers, they can't do anything. So spammers, they will do like this only, kids. If not good, then you can leave. So they are paid spammers. They are paid spammers. They are paid spammers. Understood? If nothing is good, then what are you doing here? Why you are wasting your time at this time? Means go and sleep. Now, kids, see, A is CH3, C double bond O, CH3. B is CH3, C double bond O, CH2, C double bond O, CH3. C is double bond O, double bond O, double bond O, and D is CH3, C double bond O, O CH3. Now let me give you options. A, B, C, D, B, C, B, A, D, C, D, A, B, C, and D, A, D, B, C. Okay, kids? Now, if you really have done it, if you have really gone through my teaching, you will be able to do this question. Otherwise not, kids. Hafiz is going with B. Hafiz, you are absolutely correct. Absolutely, Anamika. Hafiz, fantastic, kids. You are mind-blowing. Your selection, your rank is for sure. Because why it is being B, and I'm really happy that kids are able to understand. Kids are doing really awesome question. Now, this will give 76% enolic content. This will become aromatic, so it will form 99.99% enolic content, kids. 99. So it will start from here only. The option is starting with C is there is only one, and this is normal ester. Normal esters do not tautomerize, so this will be approximately 0%. Starting with C, ending with D, there is only one option, so that is the answer. Kids, if everyone is able to understand, I want to see green hearts. Otherwise, show me fire in the chat section. If you're not able to understand, show me fire in the chat section, kids. Fantastic, kids. Now, see another question. A, C6H5 CHO, B, CH3 CHO, C, CH3 CO, CH2 CO, CH3, D. So options I am going to make A, B, C, D. Option A, B, C, D. Now D, A, B, C. Now D, C, B, A. Now A, C, D, B. Now let's see if you're really genuine person, really genuine students, you can do this question. Let me see in the chat section that you are able to do it or not. Fast. Fast kids, fast. C. Everyone is going for C. C. Now let me check it out whether C option is being correct or incorrect. So it will become aromatic. So 99.99%. It will be 76%. It will be 1%. It will be 0% because no alpha hydrogen atom. So D, then C. D, C, B, A. Fantastic. One more. This type of question. Kids, that is really fantastic question. Now see to it. Option A, if I write down like this, option B, if I write down like this, option C, if I write down like this, option D, if I write down like this, this is going to be a little bit tough. This is going to be a little bit tough, kids. A, B, C, D, D, A, B, C, C, D, A, B, D, A, C, B. Now let's see, because you are doing really fantastic job. Really, kids, you are doing fantastic job. C. Parkaway is going for C. Kids, really genuine students are present at this time. I am really appreciating a lot to all genuine students because you really mean a lot, kids, because your answers are fantastic, awesome answers, kids. Now see, it will give 76% in all, it will form 1% in all, it will form 100, means 99.99% in all, and this is one phenyl and active methylene group, so it will form 90% in all. So C, it is starting with C, ending with B, starting with C, ending with B. There is only one option. Claps, kids. Congratulations. Claps, claps. Really, you are doing awesome job. Now, kids, some other types of tautomerism. Okay, one more question. So leave it. Okay, let's frame it out because let's move ahead, kids. Now, some other types of tautomerism. Some other type of tautomerism. Some other type of tautomerism, kids. So see, remember in the starting the trick I have given you. Suppose they are asking whether urea will show tautomerism. Urea, kids. Do you remember the formula of urea? NH2 C double bond O NH2. So one hydrogen will go from here to this place. This will come over here and double bond will come over here, kids. Now you will get NH2 COH double bond NH isourea. We'll call it isourea. Urea will get converted into isourea, kids. Now second type, they will give you amido. They will give amide CH3CONH2. Now my dear students, it is having 2 and 3, 5 alpha hydrogen atoms. Which one is more? Negative charge is more stable on more electronegative atom, This is more electronegative atom. So this hydrogen is going because carbon's electronegativity is 2.5 and nitrogen's electronegativity is 3, gets 3. So remember that negative charge is more stable. Negative charge is more stable on more electronegative atom or more electronegative atoms. So this will go and this will move over here and the double bond will come over here, kids. Now let's see what you will get. You will get CH3 COH double bond NH. This is known as imido. That is amido. This is known as amido. And that is known as imido. Imido, imido, imido. Amido will convert into imido. Now, one more they will give you. This is known as, just see, if I write down nitro, CH3, CH2, NO2. This is known as nitro. Nitro. Now hydrogen will go from here. This is acidic hydrogen, sp3 hybridized. It will go from here to here and this will come over here. So you will get kids ASI form. Nitro will get converted into ASI, CH3, CH double bond NOH coordinate bond O. This is known as ASI. Nitro will convert into ASI. So these type of tautomerism they can ask kids, and I hope that everyone is able to understand, kids. If really understand, then show me some green hearts, because I want to understand that easily you understood it. Now you can do all the questions of structural isomerism, kids. Let me see whether everyone is able to understand, because your chat section tells me really the awesome thing, the truth. Because you know, sometimes there are spammers, they will say this and that. So we are not able to understand in that case that really you are able to understand or not, kids. Okay, so your understanding is my first priority, kids. Sir, need your brain. Wow, thank you. Thank you. Fantastic, kids. Really. Whenever any spammer is there, always put green hearts so they will run away. Right now, kids, we are going to start with what? Just tell me, we are going to start with what? Tell me, kids, we are going to start with what? First of all, let me show you the printed questions. Tautomerism. See, this is the tautomerism will be exhibited by. See, good question. Just try it out. What answer you are going to give. Now just see, if you write down this compound, then this will come like this. Sorry, this will be like this. C N double bond O, and this carbon is attached with 3 methyl groups. This carbon is attached with 3 methyl groups. So it is not having any alpha hydrogen, no alpha hydrogen. So will not show tautomerism. Now see this one, CH3, NH, CH3. There is no carbonyl group. But see this one, CNO2 and 3R being attached, no alpha hydrogen, so will not show. But this one, if you see this one, kids, the last one, RCH2 NO2, the only one is having alpha hydrogen. This one is having alpha hydrogen, so this is going to be the answer. Which one will show? So the fourth one. Oh my God, already you have written. You are better than me. Wow. You are better than Baba. Now see, kids, this already you have done. Now let me show you already the printed questions based on tautomerism. Then we will move out towards geometrical isomerism kits, right? Tautomerism is exhibited by, this is going to be a tough question, but I know that you can do it. You can definitely do this. Now there is no alpha hydrogen atom. Already this is enol, so it can convert into keto form. Definitely this 1, 2, 3 hydrogen will come over here and the double bond will go over there. So enol will, this is already enol. The enol form will get converted to keto. Enol form can convert into keto. Remember this point is also there. So CH2, CH double bond O. So it will show. It will also show. It will, so it is not having any acidic alpha hydrogen because they are attached with double bond. All they are attached with double bond, so they can't show. So this will not show, but they have asked which will show. And this will show there are acidic. So this will 1, 2 and 4. 1, 2 and 4. Third will be the correct answer. Already you have written kids. Wow. Really awesome. You are writing before than me. You are getting answer. Your answer is coming before than me. What else you need, kids? You are really awesome. You are really awesome. The pair that represent chain isomerism. Okay, chain to already we have done. Tautomerism questions. We are doing tautomerism. Okay. Double bond equivalent we have done. Now we are moving towards geometrical isomerism. Swagatam in the world of geometrical isomerism. Now everyone, are you ready? Are you ready? Let's do the swagatam of geometrical isomerism. Kids, are you ready? Are you ready for geometrical isomerism? Finally, we have reached towards geometrical isomerism. Now, let's set go about the geometrical isomerism. Like and share this and see the double bonds, shape of double bonds, so that I can start teaching you that why double bonds are necessary, kids. Okay. Let's see, kids. Remember that if I compare single bonded compound, that in single bonded compound, the single bond is having free rotation. This is having what? It is having free rotation. So one form will convert into many other forms. But if I talk about kids, double bonded carbon, so it's double bond. If double bond is there, kids, the pi bond, it will form pi bond. So this pi bond, my dear students, this pi bond, the overlapping of pi bond, if you want to rotate the compound, suppose if I say that this is a compound, if you rotate it, it's okay, no problem, the compound will remain same. But if you say I will fix this part and I will rotate like that so that it is going to break, do you think that breaking is easy? No. Suppose if I am a compound, if I am rotating, then I will remain HSP only. But if you say that you stand over here and try to rotate your this neck, this will go that side. Oh my God, how I will be alive? I will be dead. So that will give pain. So if you want to convert cis into trans, if I say one compound is being cis, what do you mean by cis? That carbon its hydrogen is on same side, kids. Hydrogen is being on same side, then we will say it is being cis. Both the hydrogens on same side, and you want to keep this carbon over here, and if you want to rotate this carbon, and you want to make it trans, that is not possible, kids, because for that you need to break this bond, and breaking a bond is not a good thing at room temperature. This bond will not break at room temperature. Bond will not break at room temperature, will not break at room temperature. That means I can say cis will not get converted into trans at room temperature. Cis will not convert into trans at room temperature because this pi bond is causing restricted rotation. Due to the presence of pi bond, there is restricted rotation. Kids, are you getting my point? Because of this pi bond, there is restricted rotation. Because of the pi bond makes restricted rotation. Restricted rotation, kids. Restricted rotation. So it will not move. Now you will say, sir, in triple bond also there is restricted rotation. Yes, of course, why not? In the triple bond also there is being restricted rotation. But kids, there is only one valency, and that will lie linear. That will lie at 180 degree. It will be placed at 180 degree. So no two groups are there to say that they are GI. There is nothing to call as GI. So this page, I think you are able to understand. This page, everyone got it. Now let me tell you, to show GI what is required. Necessary condition to show GI, my dear friends. Necessary condition to show GI. Condition number 1, that each sp2 hybridized carbon, each sp2 hybridized carbon must be attached with different atoms or groups, and these atoms or group should lie in one plane. Second, these atoms or groups must be present in one plane, must be present in one plane. These are the two necessary conditions gets to show geometrical isomerism. Let me explain. Suppose if I say C double bond C, here is chlorine, here is hydrogen, here is bromine, here is hydrogen. Now see the sp2 hybridized carbon, just see, this is sp2. If this is attached with two different, these are being different atoms, and if you see these are being different atoms, if you see at this carbon they are being different, then we will say this double bond is active double bond. This double bond is active for GI, we will count it as one stereocenter. We will count it as one stereocenter, kids, right? Now if I say the compound is like this, C double bond C, here is methyl, here is chlorine, but here is hydrogen, If you see this carbon sp2 hybridized, it's attached with same So they are being same. That means this is dead. Dead to show GI, can't show GI. So this compound can't show GI. I hope that you are getting it. You are getting it. Let me write down one more compound. That C double bond C. If I write chlorine, if I write hydrogen, if I write bromine, if I write methyl. So see, these are different. They are different. So this will show GI. Will show GI. I hope that this page is clear to all of you. Do let me know in the chat section so that I can move ahead, kids. Wow, Hafiz, really you are doing great job. You are making questions like easy peasy lemon squeezy. Really you are doing great job. Hafiz, Sahana, Sausi, Kiran Pathak ji is there. Wow, Kiran, welcome back. Wow. Now, see, let's move ahead, kids. Let's move. Now, see, kids, that one thing is there, that this compound is having all 4 different atoms group. So it will not show cis trans. In this compound, cis trans will not be defined. What I'm saying, what I'm talking, are you getting? Cis and trans is not defined. Cis and trans is not defined for this, not defined. Then what is defined for this? Then it will show E and Z. I will teach E and Z. It will show E and Z type of isomerism. Now see, calculation for total number of geometrical isomers. Let's see total number of geometrical isomers. How to calculate total number of GI in polyenes. Total number of GI in polyenes. Can I write total number of GI? Tangi, shortcut is Tangi. So there are 2 cases. Case 1, kids. Case 1 is when terminal atoms or groups are different. When terminal atoms or groups are different. Then value of N can be even or odd. What is N? N is stereocenter, active double bonds, where N is number of active double bonds. What is N, kids? N is number of active double bonds, because that is going to give you idea about geometrical isomers, right, kids? Number of active double bonds. So see, kids, then the formula for Tangi will be T and GI will be 2 raised to power N. Remember that, 2 raised to power N. This will be the answer. Let me give you some examples so that you can understand. But for that, you have to keep it in your brain that the formula. What is the formula? I will give examples to visualize it also, kids. Just see. If there is compound like CH3, CH, double bond CH, CH, double bond CH, and here chlorine. Just see, kids. Just see. This is sp2 hybridized carbon. One atom is hydrogen attached to this. Another one is methyl group attached. They are different. Yeah, sure, of course. So they are being different. If I say this is sp2 hybridized and this is sp2 hybridized, the hydrogen and chlorine, they are being different. Yes, so they are being different. So how many double bonds are active? Then the answer comes 2 double bonds are being active. So it is showing geometrical isomerism from this carbon to this carbon, from here to here, they are responsible for showing geometrical isomerism, right? From where to where, kids? From this carbon to this carbon, they are showing geometrical isomerism. Then the rest part we will say R1 and R2. This is R1, kids. This is R1. And that is being R2. R1 and R2 are same or different? So definitely R1 is not equal to R2. So I will say total number of GI will be 2 raised to power 2. The answer will come out 4. Now, I've told you that formula increases the speed, but formula is not giving correct information, visualization formula. So see how to visualize it. The visualization part, let me tell you. Visualization, analysis, visualize. Just see how to visualize it. This is double bond. This is saying I will remain cis. That is saying I will also be cis. Both the hydrogen same side, both the hydrogen same side. If this is saying I will remain trans, that is saying, oh, with respect to this also trans. If this is cis, that is trans. If this is trans, that is cis. This is just mathematical permutation and combination. So these are the 4 permutation, P and C, permutation and combination. So these are the 4. This is the visualization part. This is the simply you can do this. Now let me give you another example. So for example, if I am having compound like this, CH3, CH, double bond CH, double bond CH, double bond CH, CH3, CH2, CH3. Now just see, if you compare from here to here, the 3 double bonds are being active. Just check it out, 3 double bonds are being active or not, and do let me know. Yes sir, they are active. So whatever is left, that will become R1 and R2. This is your R1 of 1 carbon, and this is going to be R2 of 2 carbons, 1 and 2 carbons. So my dear student, we can directly say this is R1, and R1 is not equal to R2. So R1 and R2, if they are not equal, then it is case number 1 only. So Tangi will be equal to 2 raised to power 3. So it will come out 8. Now if you want to visualize, now visualization will say cis, this is cis, this is cis, that is cis. This is trans, that is trans, that is trans. This is CC, that is T. This is TT, that is C. This is CTT, that is TCC. Now this is CTC. Now this is TCT. Now in this way, how many? 1, 2, 3, 4, 5, 6, 7, and 8. So this is requiring time. That's why formula is easy. But you should know how to use the formula and when to use the formula. Kids, do let me know in the chat section if this is clear, so that I can move ahead. Kids, you are getting it? मुझे बताएं. Just do let me know, kids. Oh, it's morning. Good morning, Netify. Good morning, BK Brush. Anamika, good morning. Good morning, kids. Good morning. Yes, HSP and Army. Wow. Thank you. Kids, you got it? This one is clear? Okay. Now, let's move to case number 2. You are enjoying it or not? First of all, do let me know you are enjoying it or not. Everyone, good morning. Good morning, Saucy, HSP and Kiran Pathak. Wow, kids. You are really HSP and Army, kids. Anamika, Sinaz, Saira Saxena, Kiran Pathak. Clear. Half is clear. Okay, let's move. Let's move here. Let's move here. Now see case number 2. But before moving towards case number 2, let's do one question. Let me check it out whether you are able to understand or not. Will you be able to do it or not? Tough questions are coming. By chance tough questions are coming. What you will do, kids? Let's see for the tough part. Tough questions, will you be able to do or not? Total number of GI for this compound. Total number of GI for this compound. Tell me, kids. Total number of GI for this compound. So see, this is dead. Why this one is dead, kids? Because carbon is attached with 2 hydrogens and these 2 hydrogens are same. So this is being dead, will not show GI. This is active, this is active, this is dead. Now tell me, R1 is equal to R2 or different? R1 and R2 are same or different? Then the answer will come out that it is showing GI from here to here only. Now this R1 is having 2 carbons and that R2 is having these many carbons, means 1, 2, 3, 4, 5, 6 carbons. So R1 is not equal to R2. They are being different. So the answer will come out 2 raised to power 2 and the answer is 4. Let me check out in the, oh my god, kids, you are doing better than me. No, they are not same. They are different. That is having more carbon. 4 answer. Number of kids, they are writing 4. Exactly correct. 4 will be the correct answer. Now see, kids. Let's move towards case number 2. Let's move towards case number 2. I hope that everyone is ready. Case number 2. For the case number 2, I hope everyone is ready. When terminal atoms or groups are same, when terminal atoms or groups are same, then 2 subcases arises. 2 subcases. Subcase A. Subcase A is n is equal to even. N is equal to even. Subcase B n is equal to odd. Now the formula, just see, focus on the formula here. Tanguy formula will come out 2 raised to power n minus 1 plus 2 raised to power p minus 1, and there the Tanguy formula will come out total number of geometrical isomers 2 raised to power n minus 1 plus 2 raised to power p minus 1. Till now it's same. But here the value of p is equal to n by 2 and there the value of p is equal to n plus 1 by 2. Will you be able to learn it? Remember it? The 2 subcases. These are the 2 subcases, kids. Can you keep it in your brain? This is when even number of active double bonds, and this is when odd number of active double bonds. Now let me give you example of these 2. Okay, n by 2, here p is n by 2 and there p is equal to n plus 1 by 2, right? Now let me give you examples for both these 2. Just try to understand what is going to happen. CH3, CH double bond CH, CH double bond CH, CH3. So Tanguy formula is, first of all, see why we are going to apply that formula. R1 and R2 are being same or different. You can see R1 and R2, this is being R1 and that is being R2. R1 and R2 are being same. R1, this is R1, that is being R2. R1 is equal to R2. So Tanguy formula is what? 2 raised to power n minus 1 plus 2 raised to power p minus 1. So 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. So 2 raised to power 1. So 2 raised to power 0. So 2 raised to power 1 is 2 and 2 raised to power 1 is 0. That means 3, 1, 3, 3. Now let's visualize it. Visualizing, we are visualizing it how it is less, because earlier when the value of n was 2, it was 4, the answer was 4, but here why it is less, just see. If I say CC, TT, but if I say CT and TC, CT and TC, they will become identical. They will become identical. So overall total I have got only how much? I have got 1, 2 and 3. 3 only. So less we have got. Kids, how's the Josh? I think you are tired now. I think you are tired now. Yeah, 3 is 3, right? Kiran Pathak ji, class kab tak chalegi? No idea, because Baba is busy in teaching kids. Kids, are you okay? Are you okay, kids? Is everyone okay, kids? Do let me know. Is everyone okay? Kids, we have to do it in a better way. Hafiz. No means what? Okay, you are not tired. Very good, kids. We have to do it. Josh on rock. Yes, full on energy, kids. You have to remain full on energy. Yeah, I will deal with cis and trans. Don't worry, I will deal with cis and trans. Don't worry at all. Don't worry, kids. I want to see your Josh. Josh should remain high. Yes. Now, sub case B. Let's see sub case B. Are you ready for sub case B, kids? Is everyone ready for sub case B? Sub case B. CH3, CH double bond CH, CH double bond CH, CH double bond CH, CH3. Now see, R1 and R2 are same. This is R1, that is R2. R1 and R2 are same, right? Now see how many active double bonds are there. 1, 2, 3. This is odd. So Tangi formula is 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to n plus 1 by 2. Now let's apply 2 raised to power 3 minus 1 plus 2 raised to power 3 plus 1 by 2 minus 1. So 2 raised to power 2 plus 2 raised to power 4 by 2, 2 minus 1, 2. So it will come out 6. So people, you are calculating better than me. No 8, it will not be 8. It will be 6, because less. R1 is R2 same. If R1 and R2 are same, then it will be lesser than 8. Gets lesser than 8. 6. People are getting 6. Fantastic. Now some people are asking about cis and trans. Just see cis and trans. Now if you see C double bond C, the same atoms, they are on same side. These CS3 and CS3 are, they are on same side. H and H being same side, we will say these same type of groups on same side, cis. If it is like this, C double bond C, here CH3, here hydrogen, here CH3, here hydrogen. If you see this double bond, that double bond, this side is methyl, methyl is on that side, opposite side means trans, opposite side means they are trans, and this is being same side, so same side means cis. Now after this, if they are not able to show cis and trans, then what they will show? They will show that E and Z. How many of you are ready for E and Z, kids? With full on Josh. How many of you are ready for E and Z? Kids, do let me know how many of you are ready for E and Z. Fast, fast, fast. Do let me know fast for E and Z, kids. Now, this will require CIP rule E and Z. Let me teach you E and Z. E stands for anti-gagan, and Z stands for juicer man. Now, what is the meaning of all these things? Don't remember anti-gagan and juicer man. What I am going to tell you, that you have to focus on. If I say C double bond C, there is one group X, here is group Y, here is X, there is Y. And if I say that Y is senior, Y is being senior, then X will junior. Y is being senior, then X being junior. Senior, senior on same side. Remember that if senior, senior are on same side of this double bond, if senior, senior are being on same side, we will say they are Z, Z, Z. If they are opposite side, if they are being opposite side, kids, we will say they are enemy, enemy. So we will say E, anti-gagan, opposite side. See, X and X, they are opposite, Y and Y, they are opposite. Now, the problem is that how to find out who is senior and who is junior. So seniority and juniority was decided by three scientists. Seniority was given by rule, that is CIP rule, that is CIP rule. Now what is the CIP rule? These are the initials of three scientists. These are the initials of three scientists. One scientist named Kahan, another scientist named Ingold, and another scientist name is Prelog. These are the three scientists' name, Prelog. Now what they said, what they have defined. See, EZ is always valid. Cis stands sometimes valid, sometimes not valid, but E and Z is always valid, kids. E and Z, abhi batate hain Kiran Pathak ji. Let me tell you E and Z, okay? Don't worry, I will tell you each and everything. So CIP rule number 1. Are you ready, everyone? CIP rule number 1. Are you ready, everyone, kids? First rule says the atom present alone or the part of group directly attached to sp2 hybridized carbon with maximum atomic number will be senior, with maximum atomic number will be senior, Now my dear students, for this rule number 1, do you think that you need to remember to cram atomic number? No. You should have basic knowledge of periodic table. If you are having that knowledge, you can definitely do it. So see, kids, if I write down C double bond C, iodine, hydrogen, methyl, bromine. Now what I will say, just see. This is the first compound. I will tell you slowly. Just focus on this carbon, hide that carbon, this carbon. This is bromine, this is carbon. Just see carbon and bromine. Who is senior? Definitely bromine is senior. In between iodine and hydrogen, senior. So senior and senior, they are on same side. Senior, same side. So we will write Z configuration, Z. Now suppose if I give you like this, C double bond C, bromine, hydrogen, chlorine, COOH, what you will say? Just see, this is chlorine, and don't say this is COH. Don't say the whole family, just see only carbon, the first atom. Chlorine is senior. It's not IUPAC that you will say COOH is senior. No, my dear friend. This is senior. This is senior. Once again, it is Z configuration. Just see to it. And do let me know, first of all, this page you are able to understand or not. This page, kids. This page, everyone, you are able to understand or not. Do let me know, kids. This page, you got it or not. Yeah, don't see COOH. Only just focus on the first atom. Don't see the whole group. Don't see the whole group. Just focus on first atom. Wow, kids, clear. You are really HSP and Army. Really. Now, kids, just see, if first atom, that's rule number 2, CIP rule number 2, in case of isotopes, the one with maximum mass will be senior. For example, tritium is more senior to deuterium, is more senior to protium, carbon 14 is more senior to carbon 13, is more senior to carbon 12. Clear, kids? Now how they will give you the question? Just see. If they are saying C double bond C, here the protium, here the deuterium, here carbon 14 methyl, and here nothing is written. That means nothing is written, then carbon 12. If nothing is written, then definitely it means carbon 12. Now just see, kids. Out of these, this is senior, and out of that, that is senior. Senior opposite side, so enemies, so E configuration. Clear, kids? Clear in case of isotopes? Is it clear, kids? Is it clear? What I can see in the chat, let me see the chat. Is it clear, kids? किरण जी देखिए मैं धीरे धीरे बता रहा हूँ, डोंट वरी, यू विल गेट इट. Cis and trans, it has nothing to do with cis and trans. Geometrical isomerism is going on, kids. You don't know this chapter, what to say, kids? If you don't know this much also, then what to say? I can't say anything. Which chapter is going on? Simply geometrical isomerism. Now see, kids. Now, one more example. Okay, you tell me that. Let me give you one more example. See, kids. If I say this is the compound, if I say this is CH3, if I say this is OH, if I say this is COOH, If I say this is fluorine, now check it out, E or Z, do it yourself. So out of this oxygen and this carbon, definitely its atomic number is more because its atomic number is 6 and this is being 8. So this is senior. Now this carbon and this fluorine, this is senior. So senior, same side. I will say Z configuration. Now if you're not able to understand, let me give you a very simple example. Just see the smallest one. Just see. We know from the starting this is cis and that is being trans. This too we know very well. Cis and trans we know very well. Now let's find out E and Z in this. Out of these two, this is senior because this is carbon. Out of these two, carbon and hydrogen, that is senior. So this is cis, or you can say this is Z configuration. Now this is senior, trans, or we can say this is E. Compound is one, but its names are two. Either you can call it cis or Z, trans or E. But here cis and trans is not defined. Cis and trans is not defined in this. Cis and trans is not defined, but there it is defined. Kids, are you getting my point? Now I think it is clear. Now is it clear, kids? Do let me know. Very good, Madhumita, Pramod, Tamiz, Zarasu, Vijayasri, Hafiz, very good. Now see, kids. CIP rule number 3. Let's move towards CIP rule number 3. Everyone ready for the CIP rule number 3, kids? Are you ready for the CIP rule number 3? CIP rule number 3. Kids, in your paper, NEET paper, if first bio paper is not able to decide who is going to be first, then who will decide? The second criteria. So if first atom is not able to decide, see the second atom. See the second atom. See the second atom. If first atom gets failed, if first atom is getting failed, just see, let me give you one example how they will give you. See, C double bond C, and if I write down CH2 iodine, and here chlorine, and here bromine, and here fluorine, just see, if I say out of bromine and fluorine, you know that fluorine, chlorine, bromine, iodine, astatine, the atomic number is increasing in this way. Who is senior? Bromine is senior. If you see here, this is carbon, this is chlorine, so chlorine is senior. Don't see iodine because that is the second atom, not the first atom. Always give chance to first atom. So senior and senior opposite side, so it is being E. Are you getting my point? Everyone. Now is it clear? Are you getting my point? Now second question, just see the second question. If I say C double bond C, Here I write down CH2OH. Here I write CH2Br. Here if I write down chlorine, here I am writing CH3. Now see to it, everyone just see to it. That CH2, this is same. Now bromine is winner than oxygen. This is senior, and out of this is senior. So they are opposite. So this is E. I hope this is clear. Clear to each and every one. Now see kids, let me show you that if you see this is carbon, hydrogen, and here hydrogen, and there iodine, there is being bromine. And if I say there is carbon and carbon, here is being chlorine, here is being chlorine, here is being iodine, here is being bromine. Now see kids, now if I say that this hydrogen and hydrogen being opposite sides, so this is trans. One name is trans, another name, if I talk about seniority and juniority, out of this is senior, out of this is senior, so it is E. But if I write down over here, chlorine and chlorine, they are same, so this is cis. And if I write down according to E and Z configuration, so I will get out of these, this is senior, and out of that, this is senior, this is Z. Right? Now you will start thinking that cis is Z and trans is E. It's not always like that cis will always be Z. I can make cis to be E also. Just see, if I say there is chlorine, and I'm going to make cis to be E. Just see, I will make cis to be E. Just see, wait and watch. According to cis and trans, these two chlorines are on the same side, so this is cis. And if I write down according to E and Z, just see to it, this is senior and this is senior, this is E. So cis can be Z or cis can be E. There is no rule. Whatever is coming according to rules, situation, that it can be like that. It's not necessary that cis will be E or Z will be. Are you getting my point? They can be anything. Kids, do let me know. Everyone got it or not? Everyone just do let me know. Baba is waiting for your answer. Show me green hearts. If till now it's clear to each, it is clear to each and everyone. If yes, Baba wanna see green hearts, kids. Everyone do let me know. Wow kids, you are really dedicated students. Fantastic, fantastic kids. So awesome kids. Wow, everyone. Now there is no that fire. It's all the green hearts I can see kids. Baba can see all the green hearts. That's really fantastic kids. That's really fantastic. Means a lot, means a lot. Now kids, so let's come to the CIP rule number 4. That is a little bit tough. Nothing is tough once you are going to understand it, okay? So tough will become easy. Idiyappam Muruku things will become Nalla Iruku. Don't worry kids, okay? Now see. CIP rule number 4. In case of multiple bonds, draw hypothetical structures. Draw hypothetical structures. Let's see kids. If somebody has given you CHO, then write down the CHO properly. How will you write CHO properly? Then we will draw hypothetical structures. In correct order, we have to write first, and then we will write hypothetical structures. Now seek it. CHO we will write like this, CH double bond O. Now pi bond we will break. We will break pi bond and just see. We will write down like this, CHO. The pi bond has been broken. So it is broken from here, it is broken from here. Now somebody asked carbon, you were attached to pi bond to whom? Which atom? Carbon said, oh mama, I was attached to oxygen. And oxygen, you were attached to carbon. So this is hypothetical structure. Not able to understand? Let me tell you again. Once again. So see, if you see cyanide, write down properly cyanide, C triple bond N. So one pi bond, one more pi bond. So just try to make out first the sigma bond, C and N. C and N. Now carbon is attached to 2 pi bonds. Break its 2 pi bonds. Nitrogen's 2 pi bond. So media has come. Hey, carbon, you were attached to whom? Nitrogen. Okay, please add me to the nitrogen. Nitrogen is online. Now nitrogen was attached to carbon. Okay, carbon. So this is hypothetical structure. I hope if this is clear, then I will give one question and then I will explain. Once you tell me you are clear with the hypothetical structures, you know how to draw hypothetical structures, then only I will move ahead, kids. Do let me know. You are clear with the hypothetical structures? हाँ बेटा, खाया मैंने, खाना खाया. बिल्कुल किरण जी, मैंने खाना खाया. बहुत बढ़िया. Very good, very good. Now see kids. How the question will come. Question will come like this. C double bond C, cyanide, CH, NH2, NH2, CHOH, OH, COOH. Now kids, if you see, the first atom is carbon, there is tie. Now you will say there is one nitrogen, there are two nitrogens, but if you draw its hypothetical structure, then you will see that it is attached with 3 nitrogens. This carbon is attached with 3 nitrogens. If hypothetical structure, if you draw hypothetical structure, then it is attached with 3 nitrogens. So this is senior, and out of these two, this is attached, carbon and carbon being same, it is attached with 2 oxygens. But if you draw its hypothetical structure, COOH, if you draw hypothetical structure, then 1 oxygen and this 1 oxygen and 1 more oxygen, so it is attached with 3 oxygens. So this is senior, it will come out to be E. Just tell me whether you are able to understand or not. Let me see in the chat, kids, this point is clear or not. Everyone does just, oh my god, before writing my answer, you kids have already solved it. How you are doing it, kids? I am so unable to understand how you are making it, kids. Really awesome. Your answer is 100% correct, kids. 101% correct, kids. How you are doing it? I am so unable to understand. First two, let me know how you people are doing it, kids. Tell me kids, how you are making it? How you are making it possible? Really? Thank you, thank you, thank you. Thank you, thank you. Now see kids. So, last CIP rule, let me tell you last CIP rule. CIP rule number 5. Bond pair is senior to lone pair. Bond pair is senior to lone pair. Bond pair is senior to lone pair. For example, if I write compound like this, you know that we call it hydrogen and OH are same side, we call it syn, and we call it anti. Hydrogen and OH opposite, anti. But if I call it with respect to this, these are oxymes. These compounds are known as oxime. Now see, out of this is senior, and out of this is lone pair, and this is bond pair. So definitely bond pair is senior. So they are opposite. We will say it is E. And senior and senior same side, we will say it is Z. Completed. CIP rule is completed, because CIP rule always it's going to take too much time. Once it is completed, now we are in a safe zone. We are in a safe zone, kids. Now what people are writing? Thank you, Avengers Twice. Your interacting skills and magical tricks made us wow, wow, wow. Fantastic, fantastic. Parkavya, fantastic. Now kids, let's move here. Now, let me move about cycloalkenes. Cycloalkenes, GI in cycloalkenes. GI in cycloalkenes. Remember one point, kids. Cycloalkenes up to 7-membered exist in cis form. Exist in cis form. With respect to double bond. That transform does not exist. If I say kids, this propene, it will exist in cis form. See how? This is carbon, its one valency is going toward this side, one valency going toward this side. So it is sp2 hybridized, its hydrogen will be opposite to this, opposite. So they are same side, cis. It never exists in transform. Suppose if I say there is Alia, Ramu's daughter, only one daughter, Ramu's one daughter. There is no another daughter. So can I say that Alia's sister is there? No. To have sister, there should be two. So if I say who is GI of this cis form? No one, because there is no transform. Transform does not exist. It's also transform does not exist. It's also, if I say benzene, cyclohexene, cyclopentene, they all exist in cis form only. Their transform does not exist. Now question arises, why transform does not exist? Then the answer is that transform will have too much ring strain. That's why that transform does not exist. If I try to make that transform, then the transform will have too much ring strain, and that's why that transform doesn't exist, right? So they will never show GI, will never show. That's why these will not show GI, will not show GI with respect to double bond, will not show GI with respect to double bond, with respect to double bond, will not show GI with respect to double bond. Now my dear friends, another one is GI in cycloalkanes. I hope that you are with full on energy, kids. Now definitely you will ask one thing, that what will happen if 8 carbons are there? Yeah, cycloalkenes of 8 carbon and onwards exist in both, cis and transform. So will show GI, and therefore will show GI, therefore will show GI. Now see kids, if I say cyclooctane, this is the cis form of cyclooctane, and this is the trans form of cyclooctane. How will you get it? Just see. If I say this is carbon, this valency is going toward this side, so hydrogen will be on that side. This is going this side, so hydrogen will be on this side. So hydrogen are on same side, cis. If I say this compound, if you see this compound, carbon bond valency is going this side, hydrogen will be on this side. This is going on this side, so hydrogen will be on that side. So this is trans. Are you getting my point? Now there is one trick if you want to understand, that if double bond is making C, double bond is making C, this is cis, and if double bond is making Z, then this will be your trans. Why kids? Why? This is going toward this side, so hydrogen will be on this side. That side, hydrogen will be on this side. This is coming this side, so hydrogen will be on that side. That is going that side, so hydrogen will be on this side. So this is having so many carbons, so it exists in both two forms. So they are cis and trans. So they are GI of each other. GI, kids, got it? Till now it's clear, kids? Do let me know first of all, is it clear to each and everyone? Yes, that is jet form up to 7 carbons. Wow, Dr. Siddharth, you are absolutely correct. I have given the flow of what I will teach. I don't know up to how long it will go, but I know only one thing, Baba will teach each and everything. Whatever the time is required, Baba will teach, because my motto is to make you the best. whether you want to become doctor or you want to become engineer, but I want to see your rank. That matters a lot. Yeah, with respect to double bond, what is the meaning of that? I will tell you. Once I am going to tell you GI in cycloalkanes, then you will come to know what is the meaning with respect to double bond. That you will get after this one. GI in substituted cycloalkanes. What I am going to tell you, kids, GI in substituted cycloalkanes. Now see, substituted cycloalkanes means what? If I say that this is your cyclobutane, let me first visualize it. Let me first give you a better diagram. So suppose if I say that I am having two pens, this is chlorine, this is my mobile, this is chlorine and this is chlorine. Both the chlorines are going upside. Now if I turn it upside down, then also same side cis. If I turn it out like this, then also cis. Everywhere, wherever it is rotating, it is cis. But if I say one pen is going up, one pen is going down, that means one chlorine is up, one chlorine is down. So opposite side, they are opposite to each other, we will say trans. Gets clear? Cis trans is clear? Now see how to make it over here. What I am saying, I have to make it over here also. So if I say one chlorine this side, one chlorine this side, hydrogen and hydrogen, both the chlorines are going upside, so they are on the same side, so I will say it is being cis. Now kids, if I say that one chlorine is going up, one chlorine is going down, so this is going up, my dear friends, and this is going down, so they are opposite directions, so I will say this is being trans. Is it clear? This is being cis and that is being trans. They are GI to each other. Clear? Kids, is it clear? Now if I say that I am having cyclohexane, now see, cyclohexane is really very awesome. If I say one chlorine is going up, hydrogen is going down, chlorine is going up, hydrogen is going down, so this is cis. Now if I say like this, that this chlorine is going up, hydrogen is going down, this hydrogen is going up, this chlorine is going down, this is being trans, this is being trans. Now the same thing I can draw in this way also. Just see kids, if somebody is writing like this, this is being cyclohexane and this chlorine is coming towards observer side, or I can write in this way also, that two chlorines are going away from observer, they all mean same. Now this chlorine I can write this sign, remember that this is looking tough, this means towards observer, remember that for you, I think it's a new thing, towards observer, this means towards observer, or people call it wedge, W-E-D-G-E, wedge, people call it wedge. And this is dash, dash means going away from observer, going away from observer. Now for this trans, how to write it down? we can write it like this, that this is cyclohexane, this chlorine is coming towards observer side, towards observer, and one is going away from observer. Just try to understand. One is coming towards observer, one is going away from observer. That means they are not on same side. Kids, are you getting my point? These are the ways that these three are identical. What I'm going to try and what I'm trying to tell you, kids, these three are identical. Identical. They are identical. These three are identical, and these two are also identical. Are you getting my point? These are identical. Identical. These are identical. These are identical. What is the relation in between these two? They are GI. So what I want to say, kids, let me number it, otherwise you will get confused. A, B and C are identical. Now if I say D and E are identical, but they are having relation with them, they are GI. Kids, are you able to understand? Are you able to understand? Now I'm going to tell you something for rank deciding, for top 100 rank. Should I tell you? Should I teach you? Only those students, those who want only for top 100 rank. It's a little bit tough, little bit, just little bit, but Baba will make it simple. We are going to draw cyclohexane like this. It's looking planar. It's looking planar, but actually it is not planar. But actually it is not planar. But actually it is non-planar. So what is the correct structure of this? That is known as chair form. What, kids? Chair form. Just see how the chair form will look like. Just see, kids. It's not looking chair. Now it's looking like chair, a little bit chair. It's looking like little bit chair. It's okay chair. It's not looking that good, but it's chair. Now see, kids, if I draw a better structure, then try to tell me what knowledge you are getting from it. Okay. So let me draw it properly and tell me how many carbons can you see going up and how many carbons looking like going down. Suppose if I say this is the rocket, this is the rocket, rocket is going up, rocket is going up, rocket is going up. The vertices, try to understand, the vertices are looking like rocket, and rocket is going up. 3 rockets are going up and 3 rockets are going down. This rocket is going down, this rocket is going down, this rocket is going down. Till now it is clear. Keep on giving hearts, fast, kids, then only Baba can let you know. Now if the rocket is going up, now let me visualize tetrahedral first. So always visualize tetrahedral. This is 90 degree and now it has become 109 degree. Can you see 109 degree? This is 1V. This is 1V, and if I write here, this is going to be another V. Another V must be bisecting it like this. You must have seen in your class 9th Lee-Bonhoeffer structure has given like this. But right now this is 1V and this is another V bisecting each other. Kids, are you getting my point? Now if I draw over here another V, then I will draw it like this. One valency going like this, another valency is going like this. So people will say that the valency which is going up one, this is axial. If I place here methyl, then this valency is axial. Once again, let me tell you kids, if the rocket is up, remember one thing, if the rocket is up, axial is up. Just remember, axial is up. The another one will be known as equatorial. Equatorial. People will write EQ and there they will write AX. Once again, let me tell you, if rocket is up, this rocket was up, then the axial is up, then the equatorial will be down, opposite to that. So don't remember the down one or the equatorial one, just focus on axis. If rocket is up, axial is up. If rocket is down, axial is down. Axial is down because rocket is down, so axial is down. Then the equatorial will be up. Got it or not? First of all, tell me you got it. Let me see in the chat section. You got it or not, kids? Okay, I will tell you once again. Thank you, kids. Thank you, Saucy. Thank you. Now, kids. I will let you know once again, don't worry. I will tell you number of times, but kids, those who have joined right now, smash the like button, hit the like button, those who have joined right now. Now let me tell you. I will tell you once again, don't worry. Now this methyl is up, this methyl is down. So two methyls are opposite side. So I will say this is trans. Let me give you another example, just see. If I draw this chair, this is chair, okay, this is chair form. Now tell me, if I make it like this is the chair form. So let me draw once again so that you can understand, everyone can understand. So see, always draw two lines like this, okay. Now make one beak like this, attach these two and these two, then the chair will be formed, right? You got it? Now see kids, if anyone is giving you a question like this, if they have given you a question like this, just see. They have written methyl, hydrogen and hydrogen, and they are asking whether it is cis or trans. Let's see. Check it out. Write down in the chat section. Let me see how many of you are getting it, cis or trans. Do let me know. Yeah, I will give you a break. Yes, but first of all, do let me know. This is cis or trans. Yes, I will give. Half is, don't worry. I will give break. But first of all, do let me know this is cis or trans. After this, let me complete it. Let me make it clear. Then I will give. So kids are saying this is cis. Okay, let me check it out. This is cis or trans. Now see, this rocket is going up. So axial is going up. And this axial is up, then the equatorial will be down. So this methyl is down. Now this rocket is going down. So its axial is going down. If axial is going down, then the equatorial will be going up. So this methyl is up, that methyl is down. So they are opposite. So this is being trans. So the answer is not correct. Answer is everyone's answer is not correct. Let me give you one more so that you can understand. Once you got it, then only Baba will give you break. Otherwise, how Baba is going to give break? No. Otherwise Baba can't give you break. Now see kids, just see to it. Now see, if I draw it like this, chlorine, chlorine, hydrogen, hydrogen. Now this time try hard. Tell me cis or trans. Tell me cis or trans. Let's see how many of you are really able to understand. So Raki and Gayatri, they are going for cis. Most of the people, they are going for cis. Let me check whether you are right. Then I will say congratulations. So see, this rocket is going up. So this is axial going up. This is going down, equatorial, so down. This rocket is going down, so this is down. Axial is going down, so this is down. One chlorine is down, one chlorine is down. Cis, congratulations. Really congratulations, kids. Really congratulations. Now, right now the time is 1:08. So let's meet at 125. 125, okay? 125, 125. Small break. Let's meet at 125. Small break, okay? Okay, kids? Okay? Welcome back, kids. How is the Josh? Oh my God, Saucy is taking care of Baba. Saucy, definitely. Now I will not eat anything because I have to complete this chapter. I have to tell you because you kids are there. You kids are so awesome that you are thinking for Baba what to say. Thank you, kids. Wow, thank you, kids. So let's move. Should we move ahead, kids? Everyone, just do let me know. Are you there? Yeah, definitely, Lafia, I will. South CHSP, and that is the first thing, Baba. Yes, definitely. Okay, Siddharth, everyone. Health is, yeah, my dear students. You are thinking for Baba. This is what more is required to Baba. That you are thinking for your Baba HSP. This is the most important thing. Now, let me move ahead, kids. That. So see, kids, if I say that which compound will show GI, if I ask you that which compound will show GI, this is very, very important question. Which will show GI? Now the options are given like this. First, second, third, fourth. There are being 4 options, kids. The A option is double bond here. B option is double bond with 2 methyl groups. C option is 2 methyl groups over here. And D option is double bond at this place and 2 methyl at this place. So see, this question will make you intelligent. So let's see who is going to give the correct answer for this question. Let me check it out. Very good, kids. Let me check it out in the chat section who is going to give the correct answer for this question. Now, my dear friends, definitely some of you will say B. Some of you will go for D. Then the correct answer is D. Rest of the others, just say this is dead. This double bond is dead. This double bond is dead. This double bond is dead. All the double bonds are dead. So with respect to double bond, no one is going to show GI. But you see these substituted carbon atoms. So one time this compound will be like this. That 2 methyl groups on the same side. This is cis. And another time this compound will be like this. Hydrogen, methyl on that side. Hydrogen and methyl on this side. So opposite. So they are GI. So it has not shown GI with respect to double bond. It is showing GI. Very good. Everyone's answer. Baba is really happy that you kids, only the kids, those who are into studies, they are there. Rest of the people are not watching this lecture. So I need such type of people only like you kids. Now, my dear students, now let me tell you GI in allenes. What are being allenes? Just see what are being allenes. I'm not saying aliens, allenes. What is being allenes? Just see, kids. What is being allene? Allene is, remember that allene means, if I talk about allene, allene stands for cumulated system. Allene is a cumulated system. Cumulated system. What is cumulated system? This means that pi bonds are continuous. Pi bonds are present continuously, present in a continue method, in continue. For example, if I say that this is the smallest allene, this is the smallest allene, it will neither show GI nor it will show OI. Neither it will show GI nor it will show optical isomerism. Both the two types of isomerism it will not show. Now, to show GI what actually is required, let me tell you, to show GI, allene must follow two factors. Now, what are these two factors? Let me tell you, my dear students, two factor. Factor number one, that is very clear, you know from the starting, that factor number one is that each sp2 hybridized carbon must be attached with different atoms, different atoms or groups. And factor number two, my dear students, what's that? Factor number two is number of pi bonds must be odd. Number of pi bonds must be odd. Now, if by chance, if you forget about it, you are not able to understand even or odd, then just remember God. Just remember God. To show GI, number of pi bond must be odd. So these are the 2 points. You have to keep it in your brain. Then only you can solve the question. Now see, if they are even, why they will not show GI, that also I will tell you. I will explain now. See to it. If I say it's that, if the compound is given like this, then it will show GI. GI, geometrical isomerism is going to show, and it will not show optical isomerism. But if the compound is given like this, now it will not show GI, whereas it will show optical isomerism. Now question arises, why? See kids, if I say this is horizontally present in one plane, this is also horizontal, then it's pi bond. You know sigma, if sigma is like this, then sigma and pi bonds are vertical to each other, this perpendicular to each other. If this is lying in one plane, then the pi bond will go above the plane, that is vertical. Pi bond will be vertical, kids. This pi bond will be vertical, and if it is attached here vertical, it will be vertical. Now it is having 2 pi bonds. One is being vertical. Now see, this is sigma bond and this is 1 pi bond going vertical. Then the another pi bond will be like this. Another pi bond will go like this. See, it's perpendicular to this and perpendicular to this also. It will go perpendicular to both, right? It will go perpendicular to both. Now see, its another pi bond will be horizontal. This is going vertical. If this is going vertical like this, then another pi bond will be horizontal. This will go like this. This will go like this. So this will be horizontal, right? And now if this pi bond is horizontal, then that will go vertical. Once again, this will go vertical. This will go vertical. So they are being vertical. If they are being vertical, then this will come out to be horizontal. So in the starting only I said, if they are in the same plane, they will show GI. But here see, if I say this is horizontal, then this will be vertical. If this pi bond is going to be vertical, then another pi bond will be horizontal. This will be horizontal. If they are going horizontal, then their sigma bond will go vertical, and they are vertical. That means one is going above the plane, one is going below the plane. This is horizontal and that is vertical. They are not in same plane. Not in same plane. So will not show GI, will not show GI. So remember that this will show GI, that will not show GI. Are you getting my point, kids? Got it? Do let me know in the chat section if it is clear, the diagram is clear, each and everything is clear, kids. Do let me know. Okay, billionaire thinking, that's fantastic. Sir, naha ke aata hu. Oh my God. Thank you, room roster. You are thanking for Baba's efforts. That's really so nice. Kids, do let me know. And kids, make the likes to reach up to, I didn't get it, Baba, please explain again. Okay, I will make it clear. Don't worry, but make likes to reach up to 600 kids. Make it 600. Why it is 574 only, kids? Hit the like button. Everyone hit the like button. Smash the like button, kids. Oh, your dear aims. Oh, optical structure. I will tell you, optical structure, it is not having plane of symmetry. Optical structure, if I talk about, I will teach later on, no plane of symmetry. It is without plane of symmetry. No plane of symmetry, no chiral carbon. So it is optically active. So it is optically active. I will explain. Just wait. Optically active. It is being optically active. Now I have told you each and everything related to GI, geometrical isomerism. I have told you one point I would like to say, that all GI are diisomers. Remember that, what I am saying? All GI are diisomers. Remember this point, $1 million points. All geometrical isomers are what? Diisomers. All geometrical isomers are diisomers. But reverse is not true. But reverse is not true. Remember that. But reverse is not true. Reverse is not true. Not true. Reverse is not true. Because diisomers are those isomers which are not mirror images of each other. How will you define diisomers? Distereomers are those stereoisomers which are not mirror images of each other, which are not mirror images of each other. Which are not mirror images of each other. So remember, this point is really very important point, kids. Once do let me know that everyone is able to understand it or not. I would like to see that, kids. Everyone is able to understand it or not. Not mirror images means they are diisomers. They are not the mirror images of each other. Wow. Now kids, just see. Now this was all about geometrical isomers, diisomers. Now let me tell you, kids, the physical properties of diisomers, geometrical isomers, right, kids? Now let me tell you the physical properties so that you can understand each and everything. Now, physical properties of GI, or I can say diisomers, because all GI are always diisomers. So I can say the physical properties. So kids, they have different melting point, boiling point, and so can be separated by what? Can be separated by fractional distillation, FD. FD means fractional distillation. Now my dear friends, if I talk about their chemical properties, then what you will say? Their chemical properties are same or different. Any idea about it? Chemical properties are same or different. So answer will come out. Their chemical properties are not identical. Chemical properties are same. Chemical properties are same but not identical. But not identical. What is the meaning of this? But not identical. Now what is the meaning of this, kids? That is the rate of, the rate of reaction is different. Rate of reaction is different. Now how will you account for this, that the rate of reaction is different? Then I will let you know that malic acid and fumaric acid. Malic acid is more acidic. Malic acid is more acidic than fumaric acid, kids. Than fumaric acid. Now let's see how will you prove that this is being more acidic than fumaric acid. See, kids, let me explain on the next page. Baba is going to explain on the next page. Just see to it. The formula of malic acid is like this. The formula of the malic acid is, remember that the formula of malic acid is C double bond C, C double bond O, OH, C double bond O, OH. Now H and H, the cis form. You can call it the cis form. Malic acid is cis form. And the fumaric acid, definitely that is going to be the trans form, my dear friends. Fumaric acid is the trans form. C double bond C, C double bond O, OH, hydrogen, hydrogen, C double bond O, OH. This is the trans form. So fumaric acid. Now see, kids, if anyone wants to go away from life of anyone, and if that person, place or thing is going and the one who is leaving it enjoying a lot, then that will say, oh, poda. So hydrogen wants to go away from the life of this oxygen. Once it is going, then he will say, wow, I'm to enjoying, yay, my life has become very good. Now see what has happened over here. Just see, once it's going, they will do hydrogen bonding. The strong hydrogen bonding, or earlier also the hydrogen bonding was there, but not that strong. This is going to be very, very strong hydrogen bonding, kids. Very, very strong hydrogen bonding. But if this is going to lose its proton, this hydrogen and that oxygen is far away, the opposite side. Oxygen and hydrogen are on opposite side, So no benefit of hydrogen bonding. So it will lose its proton easily. So we will say Ka1 of malic acid is greater than Ka1 of malic acid is greater than whom? Greater than Ka1 of fumaric acid. Are you getting my point, kids? Everyone. Now, once the turn of second hydrogen, somebody has come, that the base of the water, hey, I want to take your H plus. Then see, this will not go. This will say, no, I don't want to go. But this will say, oh, there is nobody of mine. Let me take away. I want to go with you. Then Ka2, because see, this is involved in hydrogen bonding chelation. It's enjoying this life, so don't want to go. So remember that Ka2 of malic acid is less than K2 of fumaric acid. Now second H, who will lose second H first? Fumaric acid will lose, but due to common ion effect, the one who is losing its H plus easily, first H plus, that is going to be more acidic. Clear, kids? Is this point clear to all of you, kids? Now this point, if this is clear, show me some green hearts. What happened, kids? Where are you? Where are you, kids? Is it clear or not? Do let me know. Is it clear or not? Everyone do let me know, kids. Very good, very good. Wow, clear. Okay, fantastic. Now let's move towards optical isomerism. Now geometrical isomerism is crystal clear, done and dusted. Now we are reaching towards optical isomerism, kids. But let's see whether we are having questions of geometrical isomerism. Yes, number of questions we are having. Just see this question. What's your answer? What's your answer? What's your answer for this question? The alkene that exhibits geometrical isomerism, 2-methylpropene. Let me make first one. 2-methylpropene. How to make 2-methylpropene? It's looking very tough. 2-methylpropene. 1, 2, 3. 2-methylpropene. This is CH3. So see, they are same. That will not show. Now butene. CH3, CH, double bond, CH, CH3. It is active, will show. This is the answer, right? You got it? Second is the answer. Same. Show me the answer. Yeah. Another question. Which one of the, oh my god, this is already declared. Another question. Geometrical isomerism is not shown by. So definitely this is different, that is different, will show. These are different, will show. Now this is 2H2 same. This is the answer will not show because hydrogens are same. Right. Now, how many stereogenic centers are present in this compound? Stereogenic means which will show geometrical isomerism. How many stereogenic? So see, if I say this is different, these two are different. These two are different, right? These two are different. And if I say this is carbon, this is attached with 2 chlorines and this is attached with 2 hydrogens. So this is stereogenic center, but this is not stereogenic because 2 chlorines are same. They will not show. So answer will be definitely going to be 1. Right? Now another question. How many stereogenic centers are present in this compound? Now see, this is methyl and this is also methyl, same. So this is dead, so it will come 0. 0 should be the answer. 0 is the answer. Now another one. The alkene that exhibits geometrical isomerism, propene will not show, propene will not show, propene will not show. 2-methyl propene already we have seen will not show. Cis or trans 2-butene will show, and this is going to be the answer. Now another question. The geometrical isomerism shown by, this is good question. I would like to see answer from your side because this question is really good. Awesome question. Very good, Dr. Siddharth. Do let me know. Do let me know, kids, what's the answer? Because this is a really good question. Really good question. Stereogenic center means the one which will show geometrical isomerism. Stereogenic center means the one which will show, let me show you. It is going to show geometrical isomerism. Just see, if I say this double bond, these 2 hydrogens are same. So it's not stereogenic, will not show geometrical isomerism. Now see, 2 hydrogens are same. So dead will not show geometrical isomerism. Now these 2 are same. So dead will not show geometrical isomerism. Now see, this hydrogen, this chlorine, they are being different. Now this is carbon, this is CH2, this is also CH2, this is attached with methyl, that is not attached. So this is active and this is going to be the answer. I hope that everyone is able to understand, kids. Now geometrical isomerism is not shown by, so definitely we have to draw it, and you will see 2 chlorines are attached with same. It will not show. That's all. Now, how many geometrical isomers are possible for given compound? Just see, this double bond is active. Now this double bond is dead. It is being dead. Why? Because 6 carbon ring. But see, will you be able to get the answer? You got it, kids? You got it or not? Everyone just do let me know. So this will cis and trans, so 2 geometrical isomer, 2 raised to power 1 is 2. I hope that everyone is able to understand. Now, how many geometrical isomers are possible for given compound? This is good question. I would like to see answer from your side for this question. Very good, kids. Fantastic. I can see you are doing really good, and South Sea, very good. South Sea is full on energy, and this is required, kids. If you want to get selected, you have to be like South Sea. Very good, South Sea. Surya Prakash, Pravin, Nisthanani. Kids, B. Maximum people are going for B. Okay, let's see how to get the answer. One time all the chlorines up, and second time 1 chlorine down, 2 up, 1 chlorine down, 2 up, so 2. Definitely 2 will be the answer. 2. So see, all chlorine up, 1 chlorine down, 2 chlorines up. Fantastic. 2 is the correct answer. Fantastic. How are the questions? Now, how many geometrical isomers are possible? So see, this is active and this is also active. So total number of GI will be 2 raised to power 2. The answer will come out to be 4. 4. So we will go for the 4. 4 is the correct answer. Now kids, see, how many geometrical isomers are possible for given compound? In this is active, this is active, but R1 is equal to R2. They are same. So 3 for this. The answer will be 3 for this. And for this and this, but these terminal are different. R1 is not equal to R2. So for this, 4. So 3 and 4 will be the answer. 3 and 4. I will go with D. Kids, what you are going for? D. D, we will go for D. So, very good. D is the correct answer. Now, I hope that everyone got it. What I am telling you, in this R1 is equal to R2. And here R1 is not equal to R2, case 1 and case 2. Already I have explained, kids, right? Now, which of the following has Z configuration? Tell me, let me see in the chats. Which one will have Z configuration? Let me check it out. Kids, hit the like button. Make it 600. Why it is not 600? 18 away. Lafia is there. Lafia, come on. D. People are going for D. Let me check it out. All of these. Let me check it out. And out of these two, this is senior. Out of these two, this is senior. Z. Out of these two, this is Z. Now 2 are Z. So definitely all of these is going to be the correct answer. Yeah. Very good slides. We are having, which of the following is having E configuration? Out of this is senior. 2 Z. This is Z. This can't be the answer. And out of this to this two, this nitrogen is senior and this oxygen is senior. Once again, this is being Z. And out of these two, CH2, NH2, this is senior and there CH. This is senior. This is also Z. So definitely this is going to be the answer, senior and the senior. E. This is the answer. Let me check it out. Before me, you are going to do this question. I know very well that you kids are solving in less time. Baba is taking more time, kids, right? Very good questions. Now, let's see the optical isomerism. Let's come to the optical isomerism, kids. Optical isomerism, the last topic. Now, Baba is following the rules and regulations, the sequence, kids. Tell me, Baba is following the sequence or not, kids? Do let me know. Baba is following the sequence. Saucy. Now, we are here to start with optical isomerism, the most important thing, optical isomerism, kids. Are you ready for this? Optical isomerism. Very, very important chapter. Very, very important chapter, kids. Very, very important. Now, if I ask the necessary condition to show optical isomerism, one and only one necessary condition, one and only one necessary condition to show optical isomerism, necessary condition, kids. What is the necessary condition, kids, to show optical isomerism? Who is going to tell me, kids? The only one necessary condition. then you will say chiral carbon, but I will say asymmetric compound. Now how the compound will become asymmetric? That asymmetric compound, what do you think? Chiral carbon should be there or not there? Not necessary. Plane of symmetry should not be there, and center of symmetry should not be there. Neither plane of symmetry nor center of symmetry. Chiral carbon can be present or can be absent, doesn't matter. With or without chiral carbon doesn't matter, kids. Remember that. With or without chiral carbon doesn't matter. Chiral carbon is not having any condition, so chiral carbon's necessary condition is not there. With or without chiral carbon. What I'm saying, with or without chiral carbon. Now kids, I know that time, you know that you must be feeling sleepy, but Baba will not decrease the quality content. Baba will not decrease the quality content, kids. Baba will provide you the full quality, quantity, each and everything. I know that it's 2 o'clock, 2 of morning, and Baba has to go for offline classes also in the morning, in the evening, but then also kids, I will complete it. Now I want to see from your side. Kids, I want to see your energy level, because this optical isomerism is very, very important chapter, and we have to give full on energy, kids, full on energy. So kids, just think of that without energy, this isomerism means very, very poor isomerism. Very good kids. Let's give our best. Be with full on josh, full on energy. We have to have that much energy. Now see kids, plane of symmetry. Let me explain plane of symmetry. What is plane of symmetry? Now kids, see, plane of symmetry. Just try to visualize plane of symmetry. What is the meaning of plane of symmetry? Let's see to it, kids. Pause. Pause means plane of symmetry. Pause. What is the meaning of pause, kids? That is the plane of symmetry. Kids, plane of symmetry means an imaginary plane which divides the whole compound in 2 equal parts, so that one part is exact, the mirror image of second part. For example, if I say that I make A Do you think it is having plane of symmetry? Do you think it is having plane of symmetry? Yes. If you divide it from here, this is plane of symmetry and it is known as vertical plane of symmetry. Vertical plane of symmetry is there. That means if its present compound is optically inactive. Optically inactive. It can't be optically active. If I say that I'm having compound like this, now is the plane of symmetry is there? Yes. If I divide it through here, then the plane of symmetry, and this is known as horizontal plane of symmetry is present. That is the vertical, this is horizontal. Can you see, kids? Everyone, are you able to understand? Now let me give you a little bit tougher part. If I make a compound like this, just see to it. If I make a compound like this, and if I ask that the compound is like this, what do you think? Chlorine and chlorine, hydrogen and hydrogen. Do you think the plane of symmetry is there? Answer is yes. If I divide it from here, it will divide in two equal parts. So the plane of symmetry is present. Yes. Compound is optically inactive. If I say, if I make compound like this, kids, and if I add here the chlorine, here the bromine, here the hydrogen, here the methyl. Now if I ask the plane of symmetry is there? Now you will say, sir, no, there is no plane of symmetry. But I will say, yes, there is plane of symmetry. Just see. If I divide this compound like diagonally, if I divide it diagonally, then there is diagonal plane of symmetry. If you see, diagonally if I cut it, if you're not able to understand it, then do let me know. I will make it in 3D diagram, then you can understand it. Then if I make it like this, then there is diagonal plane of symmetry. Just see, there is diagonal plane of symmetry. Diagonal plane of symmetry is present. If you are not able to understand, then I will make 3D diagram. I will show you. Kids, do let me know in the chat section that diagonal plane of symmetry you are able to understand or not. Wow, Lafia. Not understand. Okay, no worries. Now see, let me make it. Let me bring it. Suppose this is cycle. And if I say upper side is going chlorine, this is chlorine going chlorine like this, chlorine is over here. Just see, chlorine is over here. And if I say bromine is down, bromine is going down. Now cut it like this. This is the copy, can you see? And try to cut it diagonally. This was like this, but I am making it diagonally. Now cut it. The half of the chlorine will go towards right hand side, the half chlorine will go left hand side, and you cut it like this. Half of the bromine will go right hand side, half bromine will go that side, and make it cut like this. Whatever is coming, half will go right hand side, half will go left hand side. So this will see, hey, my right hand side and left hand side, both you are equal. So there is plane of symmetry. Now you got it? If not, then do let me know. Once again I will explain. Have you got it or not? Let me know in the chat section. You got it or not? Saucy is really enjoying, but rest of the others, do let me know you got it. You got it or not? Clear? Wow. Clear to each and every one. Wow, that's really awesome. That's really awesome. Vera level. Okay. Diagonal plane of symmetry is there. Now, my dear students, just see. If I say that CH4, CH3Cl, CH2, Cl2, CHCl bromine iodine. Out of these four, which is not having plane of symmetry? Out of these four, what do you think which is not having plane of symmetry? So let me make 3D diagram so that you can understand. If I say that I am having all four carbons same, CH4, let me draw CH4. This is 1B. My hand is carbon, this is hydrogen, okay? And this is also hydrogen, and this is also hydrogen. Can you see tetrahedral? Is it visible to all of you kids? The tetrahedral, can you visualize? Everyone just to let me know, can you visualize tetrahedral? Now if I start cutting from here, just see, if I start cutting from here, the half of the marker means atom, like these are spheres, half will go this side, half will go that side, and this and this are same, both are same hydrogens, this hydrogen and that hydrogen, and when you come to this place, half will go toward that side, half towards this side. So definitely this is having plane of symmetry or not? First one is having. This is having plane of symmetry. Now if I replace one, suppose in place of this, if I put this white one, in the place of one I have replaced, and I put white one, and if you now cut it, tell me that you will get plane of symmetry or not. These are like this, and I put here white one. Now one I have changed, rest of the three are same, one I have changed. Now if you cut it, half of portion will go right hand side, half will go left hand side, and these two are same and this is same, then also I will get plane of symmetry. Now if I change two, this one and this one, then also if you cut it, half will go toward this side, half will go toward this side, these are remaining same, and this will cut down. Now if I change all four, if Baba is going to change all four, now if all four are different, now if you cut, now if you come over here, this side red, this side black, there will not be plane of symmetry. So this is known as chiral carbon. Chiral carbon means a carbon attached with four different groups. So it is having plane of symmetry. It is also having plane of symmetry, but this carbon is attached with four different groups or atoms. All four are different. So this carbon is known as chiral carbon. And there is no plane of symmetry, so it is optically active. It is being optically active. I hope that you got it, kids. You got it. The carbon which is attached with four different atoms or groups are known as chiral carbon, and there will be no plane of symmetry, so it will be optically active. Now let me tell you, kids, how to find out total number of optically active isomers. So remember that case number 1, if there is no pause, no cause in any representation, of compound, then total number of optically active isomers will be equal to total number of optical isomers now they will be equal. Why they are equal? Because we should know one thing, that total number of optical isomers is equal to total number of optically active isomers plus meso isomers. But for this case, meso number is 0. In this case, there is no meso. Meso are 0. So meso is 0. That means total number of optically active isomers will be equal to total number of optically active isomers. Okay, kids? Is it clear? Now, that formula is 2 raised to power n will be equal to 2 raised to power n, where n is equal to number of chiral carbons. Number of chiral carbons. These chiral carbons can be odd or even, doesn't matter. Odd or even, doesn't matter. Now, kids, let me tell you, suppose if I am having a compound like lactic acid. Lactic acid. What is the formula for lactic acid? You have to remember the formula for lactic acid. CH3 CHOH COOH. How many chiral carbons are there in lactic acid? Do let me know how many chiral carbons. There is just one chiral carbon. So total number of optically active isomers will be equal to 2 raised to power 1. That is 2. Out of 2, one is being dextrolactic acid. Another one will be levolactic acid. Now, my dear students, if I say that CH3 CHOH COOH, then its mirror image will be like this: CH3 CCOOH OH H. These two are mirror images of each other, but they are non-superimposable. Why non-superimposable and how non-superimposable? Suppose everyone, gets, just a second, I don't know what happened, just a second, kids. Yeah, it's okay now. Am I audible and visible, kids? Am I audible? Let me check. Am I audible and visible, kids? I will tell you center of symmetry, but don't worry about center of symmetry. I will let you know. But am I properly audible and visible, kids? Okay, thank you. Now see, kids, if you, once again it's gone, what's happening? Something is wrong, kids. I can't understand. Can you hear me? Can you see me, kids? Everyone? Okay. Now you see your right hand. You just take your right hand. You just take your right hand. Now if you try to divide it two parts, don't try, I'm saying just imagine it, that you are trying to divide it two parts. You won't be able to divide it into two equal parts. So if you see the right hand in the mirror, you will see the left hand. You will get left hand. And if I ask you the right hand and left hand, are they superimposable? They are same? Then the answer is no, they are not identical, because if you are having gloves, the finger gloves, if you try to put your right hand gloves in the left hand, not possible. If you are having shoes, if you try to wear out shoes of right hand side in the left hand leg, they are not going to exactly fit. So if you try to put this right hand on the left hand, it is not superimposable. See, the thumbs are on that side. If you keep on rotating, then also it's not possible. Don't do like this. This is not allowed. This, rotate it. See, if I keep it over here, if I try to rotate it, it will never be able to, you will never be able to superimpose. You just try at your home. You can try it out. It's not superimposable. Are you getting my point? Are you getting my point? So, if I say this is dextro, if I consider this one to be dextro, then that will definitely is going to be levo. Now, what are dextro and levo? I will tell you. So, these are non-superimposable mirror images of each other. Non-super impossible, I am not saying impossible, impossible mirror images, non-superimposable mirror images of each other. And non-superimposable mirror images are known as enantiomeric pair. So we will say these are enantiomeric pairs, enantiomeric pairs. Now, what do you mean by dextro and levo? Let me tell you first of all, what do you mean by dextro and levo? Let's see. If I say that I am having plain polarized light, but before that, let's take simple light. Let's take simple light, which is multidirectional. Simple light is always multidirectional, kids. Okay. Simple light is always multidirectional. Multidirectional light. So it is already rotating. It's of no use. So we have to make it unidirectional. So we have to pass it through nickel prism. Let's pass it through nickel prism, which is made up of calcium carbonate. Nickel prism. Made up of calcium carbonate. What it will do? It will convert this multidirectional light into unidirectional light. Once it is going to pass through nickel prism, the light will become unidirectional. That is known as plain polarized light. Then the light will become unidirectional, kids. Light will become unidirectional. It will move like this. Now the multidirectional, which was rotating in all the directions, now the light will become plain polarized light. What we call it? Plain polarized light. We will call it plain polarized light. Plain polarized light. This is unidirectional light. Now, the compound for which we are doing the analysis, we will take that organic compound in the tube. We will take that organic compound in one tube. This tube, which is for detecting the organic compound, whether that compound is optically active or not. This tube will find out whether the compound is optically active or not. We will make organic solution, but remember that its concentration, organic solutions concentration, organic solutions concentration will be measured in gram per ml. Otherwise, you will take over there molarity, normality. Don't take molarity, normality, molarity, nothing. Gram per liter. Gram per liter. Right? And the length of the tube, will be in decimeter, and the plane polarized light will pass through this compound. Now, if you think that the compound is optically active, then it will rotate the line either in clockwise direction. If the compound is found to be optically active, this will rotate the light either in the clockwise direction or in the anti-clockwise direction. It will rotate the light either in the clockwise direction or in the anti-clockwise direction. Who is rotating the light? This compound. This compound will rotate this light. Once this light is passing through this solution, light will come out. If this compound is found to be optically active, it will rotate the light, and if the light is found to be getting rotated in the clockwise direction, then we will say that compound is dextrorotatory. We will say compound is dextrorotatory. We can write a small d, or we can write down plus sign, anything. Dextrorotatory, small d, plus sign, all three means same. But if light is found to be moving in anti-clockwise direction, then everyone will say that the compound is levorotatory. Levorotatory, small l, or negative sign. This whole setup is found in NBRI, IIT, CMAP, ITRC, Indian Toxicological Research Institute, National Botanical Research Institute, National Sugar Institute, and number of IITs. And the whole setup is known as spectrophotometer. Everyone say this instrument's name is spectrophotometer. Everyone say spectrophotometer. This question will be asked. What is the name? Spectrophotometer. Everyone says spectrophotometer. Another name is polarimeter, or we can call it polarimeter. 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 Either spectrophotometer or polarimeter. This thing is clear. If till now this much is clear, kids, do let me know in the chat section that this much is clear to each and everyone. Thank you, Saucy, for appreciating and for being energetic. One is appreciation, one is energetic. Ambika ma'am is there. Hey, really Ambika ma'am is there? Kids? Really? Ma'am, how are you? Thank you, ma'am. Thank you. Thank you. Thank you. Really feeling good. Now I am feeling energetic. Pranam, pranam, welcome, vanakkam, suswagatam, suswagatam, suswagatam. Let me see, Ambika ma'am is there. Okay, she was there. Okay, kids, okay. So see, it's your energy level, that's why ma'am was there. Now kids, let's move, yeah, okay? Let's move, yeah, huh? Should be moved now. Okay. Okay, no problem. Now see kids. So, what you are supposed to do, you have to find out number of chiral atoms, chiral carbons, and then you can find out the answer. Now, if I say that the compound is like this, if I say that the compound is like this, CH3, CH, Cl, CH, Br, and COOH. What do you think? How many chiral carbons are there? Remember one point, kids. Always remember one point, that carbon attached to double bond or triple bond carbon attached to double bond or triple bond can't be chiral, can't be chiral. Can't be chiral. Now, this is one chiral, this is one chiral, two chiral carbons are there. Can you see kids? How many chiral carbons are there? Can you see? 2. So, total number of optically active isomers will be equal to 2 raised to power n. So, 2 raised to power 2. So, it will be 4. 4 is the answer. You got it? Now, if I try to visualize it, this though I have told you with the formula. So, formula never visualize it. Formula never gives the accuracy. Formula only can increase the speed. So, what are 4? DD, LL, DL, LD. These are the 4 isomers. So, this is visualization wise. Now, let me give you another one. Just see kids. If I give you this compound, and try to find out which compound is this, and do let me know. Which compound is this? This is your well-known glucose. You know very well this is being glucose. Now just see how many chiral carbons are there. 1, randa, mono, nale, 4. So total number of optically active isomers is equal to 2 raised to power 4. That 2 to 4 to the 8, 16. Optically, total number of optically active isomers. Can you see kids? Are you able to understand? Everyone, just to let me know in the chat section if you are getting it. I want to see kids. Everyone got it? Have you got this one, kids? Do let me know. Kids, do let me know you got it. Now if I ask you for if I make its chain form, glucose chain form like this, pyranose ring structure. CHOH, CH double bond OH. So it's CHOOH gone. Okay. 1, 2, 3, 4, right? OH, CH2OH. Now this is known as hemiacetyl pyranose ring structure of glucose. Hemiacetyl pyranose ring structure of glucose. Now see, it is having how many chiral carbons? Do let me know how many chiral carbons it is having, kids. This is also chiral carbon. One chiral carbon has got increased. Earlier they were 4, but now they are 5. 1, 2, 3, 4, 5, 6, 7. I have increased number of carbons, kids. So let me delete this one. Now see, is it okay? 1, 2, 3, 4, 5, 6. Now one chiral carbon, earlier 4 we were having. Now one chiral carbon has been increased, the fifth one. The fifth one is increased. Just see the fifth one. Now n is equal to 5. Now we are having n is equal to 5. So total number of optically active isomers is equal to 2 raised to power 5. Now its answer is 32. So if anyone is asking in the pyranose ring structure, pyranose hemiacetyl ring structure of glucose, will have 32 optically active isomers and the chiral carbon are 5. Otherwise, open chain structure of glucose is having 4 chiral carbons. This point is clear, kids? Is this point clear, kids? Now same thing, and they are asking for fructose. This carbon is known as, this one is known as anomeric carbon. You know very well, anomeric carbon, right? Now this point is clear. Now if same thing, if I ask for fructose, then we can directly know that fructose is CH2OH, C double bond O, CHOH, CHOH, CHOH and CH2OH. So open check chain structure of glucose is having how many chiral carbons? Just see. This is not, this is not, this is chiral, this is chiral, this is chiral. So fructose is having 3 chiral carbons. So total number of optically active isomers will be equal to 2 raised to power 3. The answer is 8. But if we make hemiketal furanose structure, then the ring structure 1 carbon will increase. Ring structure, the value of N will come 4. So 2 raised to power 4, that will come out 16, right? Ring structure of what? Furanose, hemiketal, ring structure of fructose. Now I think this point till now it's clear to each and everyone. Just I want to see in the chat section any doubt, kids. And oh my god, kids, you are really all studious students are present. Those who are weak, they have gone. All studious students are here, kids. Really, I'm amazed that I can see only those students, those who are studious. My god, so fast calculation, so fast answer, kids. All dedicated students are present over here. That is really awesome. That is really awesome. Baba is glad. My god, wow. Now, kids, now come to one point. Now, this was the case number 1. Now, let me explain the case number 2. Let me explain the case number 2. Are you ready for the case number 2, kids? Is everyone ready for the case number 2, kids? Now, case number 2 says, but before I move towards the case number 2, let me tell you something. Okay, after the case number 2, I will explain. Otherwise, there will be confusion. So, first of all, case number 2, if any representation is having plane of symmetry, by chance any representation, if some representation of compound is having plane of symmetry and others not having, now kids, you must be thinking, sir, center of symmetry you haven't taught. I will tell you at the last, because center of symmetry is very, very less important. Mainly the plane of symmetry is important, right? Now, then this is the case. Now, in this 2 subcases arises. Subcase A, subcase A. When n is equal to even, when n is equal to even, then total number of optical isomers will be equal to total number of optically active isomers plus meso. Here meso will be present. So the formula is 2 raised to power n minus 1 plus 2 raised to power p minus 1, where p is equal to n by 2. Do you remember this formula I have told you in GI? It was like this only, 2 raised to power n minus 1 plus 2 raised to power p minus 1. This formula is same exactly, kids. Do you remember? I have told you this formula. If you remember, kids, do let me know. In GI, I have told you this formula in GI. So it is looking like that only, kids. So no need to cram it once again because already you know it. Right? Now let me explain this one on the next page. Let me explain. Let me take an example of tartaric acid. Do you know tartaric acid, kids? Have you heard about tartaric acid? Tartaric acid is COOH, CHOH, CHOH, COOH. Now how many chiral carbons are there? 2 chiral carbons are there. First I will tell you the answer with the help of formula and then I will explain it. Okay, kids. First I will tell you, I will teach you RS, all these, yes, Saucy. Yes, now I will not take too much time. After this case, one more case, then RNS, then DNL will not take too much time, 3 or I3 will not, only RNS will take little bit time, okay, only RNS will take a little bit time, kids, then the class will get over, the chapter will get completed, kids, okay. Baba is trying his level best, kids, but why it's not 600, kids? Smash the like button, at least make it 600. Why it has not gone to 600? What happened, kids? Why it's not reaching 600, kids? Tell me. Break I will give you, but little bit. Just wait for few seconds, kids. Let me teach this. Now, if I apply formula, let me apply here formula. Everyone. Total number of optical isomers is equal to total number of optically active isomers plus meso 2 raised to power n minus 1 plus 2 raised to power p minus 1. So 2 raised to power 2 minus 1 plus 2 raised to power 2 by 2 minus 1. So 2 raised to power 1, 2 raised to power 0. So 2 plus 1, 3. 1 meso, 2 optically active. This is formula wise, right? Now let's see the visualization. Visualization means most important thing. Visualization is being important, kids. See. If I draw the compound, I will get compound like this. So I will say COOH, OH, OH, H, H, COOH. So this compound is having 2 chiral carbons, 1 and 2. There is no plane of symmetry. Plane of symmetry is not present. So it is optically active. If I draw its mirror image, definitely that is going to be optically active. That will also be optically active. Its mirror image. If I say this is dextro, that is going to be levo. COOH, OH, H, H, OH, COOH, 2 chiral carbons. This is also optically active. So any relation, they are enantiomers, enantiomeric pairs, non-superimposable mirror images, enantiomeric pairs, kids. Now if I draw the third one, just see. this one. Oh ho ho, I think, okay, I have to make space for it. So if I draw like this, now just try to visualize it. COOH, OH, OH, H, H, COOH. Now see, this compound is having chiral carbons, but along with chiral carbons, plane of symmetry is there. Just see, it is having plane of symmetry. If I divide this compound from this place, then this will be divisible in two equal parts. Just see, it will get divided in two equal parts. Just see, kids. So this is plane of symmetry. Can you see, kids? This is being plane of symmetry. Plane of symmetry is present here or not, kids? To let me know. Plane of symmetry, if I cut it, divide it in two parts, the plane of symmetry is present. So this is meso. Now let's visualize it, this compound. Just see, kids, just see. If I say move from OH to COH, it's moving anti-clockwise, moving OH to COH anti-clockwise. Only one direction is there. OH to COH clockwise, only one direction. OH to COH clockwise, only one direction. But here you will get two different directions. From OH to COH it's moving anti-clockwise, and from OH to COH it is moving clockwise. So half portion of the compound rotating the light in the clockwise direction and other half rotating in the anti-clockwise. So the light will move without any deflection. So it has become optically inactive. It has become optically inactive because of internal compensation. Because of internal compensation. So it is optically inactive, but still it is optical isomer because it is rotating the light. It is optically inactive, but still it is counted as optical isomer. And these two are optically active as well as optical isomers. So two optically active, one meso. So 2 plus 1, it's coming out 3. Kids, just to let me know in the chat section, everyone, strength is getting decreased. Baba is continuously teaching, but kids, no problem. I will tell you each and everything, then only I will go back to home. I will let you know each and everything, kids. Got it, kids? Do let me know. Got it? Everyone got it? Is it clear to each and everyone, kids? Meso, yes, meso. Wow, thank you, Sahausi. 600 likes. It crossed 600. That's really awesome. Now, kids, let's take 10 minutes break, kids. After 10 minutes break, I will continue. Then I will tell you the center of symmetry also. Just 10 minutes break, okay? Short break for 10 minutes. Okay, kids? Hey everyone, are you there? Let me see. Yes, Saucy, I have taken one apple. Yes, I took one apple. I have. Everyone, are you there? Break is over now. Drink water. Yes, I have taken water and ate apple, right? An apple a day keeps doctor away. Right, kids? Now, let's come with the full-on Josh. Let's complete, kids. Kids were asking, please repeat it once again. Let me tell you once again. Don't worry. When Baba is there, no need to worry, kids. You know that plane polarized light, when that plane polarized light is going to move through this compound will rotate the light only in one direction, anti-clockwise. This you will know when I am going to teach you RNS system. So first compound is rotating the light, the plane polarized light was moving and this compound has rotated it anti-clockwise. Anti-clockwise means the light will be seen by the instrument moving towards anti-clockwise. But here the mirror image, it's a mirror image. Just see how it will rotate the light. It will rotate the light. Just see, the light will go in the clockwise direction. Clockwise direction, kids. Clockwise direction. Now this will also rotate the light in only in one direction. The plane polarized light is coming and this compound will rotate it. Ting, 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 ting. Then the instrument will see that light has been found to be rotated in the clockwise direction, kids. Now, if you see the third compound, then you will come to know that half of the portion rotating the light through clockwise, half is rotating through anti-clockwise. Just see why and how. Just see. Move from same atom to same atom. Here OH to COH we have moved. OH to COH, OH to COH, OH. Now here also move OH to COH. You can see this is moving anti-clockwise. But here OH to COH, this is moving clockwise. So half the plane polarized light has gone into the solution. Half portion has rotated in clockwise, half portion has rotated it anti-clockwise. Now the light will, once it is going outside the tube, the instrument will say, oh, nothing has happened to the light. It's moving straight. But what has happened inside the test tube? That it has been rotated, but the rotation has cancelled out. Rotation got compensated internal, because that half portion has rotated clockwise, half portion has rotated anti-clockwise. So internal compensation is there, and internal compensation has cancelled out the rotation. And you can see why this has happened. This has happened because this compound is having plane of symmetry. So whenever compound is having plane of symmetry along with chiral carbons, whenever any compound is having plane of symmetry and along with chiral carbons, we will say that compound is meso. And meso are always optically inactive. These two are optically active. As well as optical isomer. Now kids, anyone who's rotating the light will be counted as optical isomer. But optically active, for optically active, light has to get rotated. These are optical isomers, but not optically active. Not optically active. It's not optically active. It is just optical isomer, but not optically active. Half is and all. Everyone do let me know you got it. Now you understood, kids. Half is. Now you got it. I have explained once again. You got it. I think you got it, kids. Once again I explained it, kids. Do let me know, kids. I have explained twice. I have explained twice, kids. Do let me know. Is it clear? Now let me tell you the sub case number B. Sub case number B. Subcase B. Now my dear students, in this the value of n will come out to be odd, and generally you will see 3. So this example will come, and so many times it has been asked in ends. Just see number of times they have asked it. The same example will come again and again. But I am not saying that you should cram it out. You just see how will you find out this is the case. You just stand in the middle, center of the compound. Whatever you see on the right hand side, you will see on the left hand side. So kids, for such type of compound, this carbon is said to be chiral and this carbon is said to be chiral. These two carbons are said to be chiral, but you see from the center, the symmetry is appearing. This is known as pseudochiral. This will be known as pseudochiral. Why it is known as pseudochiral, I will let you know, my dear friends. I will let you know. You can also call it to be prochiral. Prochiral. Now, why we call it like this? Let me tell you, kids. First of all, let me tell you, this compound will have 2 optically active isomers and 2 meso isomers, 2 meso. So definitely total number of optical isomer 4. If anyone is asking total number of optical isomer, 4. Now how 4? Just see, kids. Let me draw it. If I draw the compound COOH, CHOH, 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 and COOH. Now you see, there all 3 carbons are chiral. This is chiral, this is chiral, this is chiral. Now you will say, sir, there you said pseudochiral. Yes, that was the condensed formula. So we will say pseudochiral. But right now, all the 3 are chiral. Now if I draw its mirror image, water mirror image, let's say, water mirror image, just see COOH, COOH, CHOH, COHH, COHH. So it will also be having 3 chiral carbons. So we will say they are optically active and they are enantiomeric pairs. A and B are enantiomeric pair and they are optically active. This is also optically active. Now let's see two more. Just see. If I draw this compound, just see. COOH, COOH, COH, OH, OH, H, H, H. Now you see, I will say that this is chiral, this is chiral. These two are chiral, but this is not chiral. Now you will say, sir, what is this? There you said pseudo-chiral. Now you are saying not chiral. Here you are saying chiral. Yes. From this carbon, you see the plane of symmetry is passing. That's why, kids. If you would see from this carbon, the plane of symmetry, I can cut it in two equal parts from here. So this is indicating that plane of symmetry is there. And once the plane of symmetry is there, that means it is meso. Along with chiral carbons, the plane of symmetry is there. This is known as meso. And the mirror image of meso is also meso, identical. Remember that its mirror image. What should be its mirror image? They will hold relation of identical. They will be identical to each other. But here, the mirror image, because it is not having plane of symmetry, no plane of symmetry, then the mirror image will have the relation that is enantiomers. So these two are enantiomers. But kids, if the mirror image is having plane of symmetry, because compound is having plane of symmetry, so the mirror image, meso's mirror image will be meso, and that will be identical, will be counted as one. Now second meso, let's see. What is the second meso? This is the point to be noted, my lord. The second meso, see. Now see how this meso is different from this meso. This mesos, all three OH were on the same direction, same side, but it's two OH on this side and one H, but it is also having plane of symmetry. Just see, still it is having plane of symmetry. So this is different meso, you can see. This is being different meso. Very easily you can see this is being different meso. So two meso, two optically active, so 4. Always remember 4. I hope this is clear to each and everyone. Let me check it out in the chat section. Clear, kids? Do let me know, is it clear or not? Do let me know, kids. Is it clear or not? Now, after this center of symmetry, then I will tell you RNS system. But first of all, do let me know, is it clear to each and everyone or not, kids? Very good, kids. Very good. Very good, kids. Very good. Wow. Fantastic. Fantastic. Now, see, kids. Let me teach center of symmetry. Let me tell you center of symmetry. So kids, for your syllabus, center of symmetry is not that important, I am telling you, but it is only very, very less important, center of symmetry. From the center, if we see in opposite direction, then same appearance in all the directions. Now let me show you. Suppose if I say you sit in the middle, if you just sit in the middle, and if you move in opposite direction, just see, if you move in opposite direction, from here you go toward this side, you will get CO, this side also CO, from the middle, this side NH, this side NH, this side CS2, this side CS2, this side bond, 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 this side. So center of symmetry is there, center of symmetry is present, so compound can't be optically active. Let me give you one more example. Let me give you one more example. Now if you sit at the center, and from here if you go in the opposite direction, just see, if you go in the opposite direction, you got chlorine, you got chlorine, just see, you got chlorine, you got chlorine. If you go that side, you got bromine, you met with bromine. Any direction, if you go here, hydrogen, this side hydrogen, every side the same symmetry is getting or not getting. So this compound is having center of symmetry, so optically inactive, optically inactive. I hope that everyone got center of symmetry also. Do let me know in the chat section that you are able to understand center of symmetry or not, kids. Everyone do let me know. Just to let me know you got it or not. Everyone gets perfect. Okay, okay, so everyone is able to understand, right? Now let me tell you RS system. Very good, very good. Now types of configurations. Let me tell you types of configurations. Only I think 20 minutes more, 20 minutes more, kids, don't worry, okay? Not more than that, 20 minutes more, kids, okay? Don't worry, kids. And thank you for being so much energetic. R and S. This is known as absolute configuration. D and L, relative configuration, trio and Ri trio, small d and small n, experimental. These are the 4 types of configurations that we have to understand, kids. So don't worry, with this I will tell you little bit more, then we will complete it, wind up, right? Now let's see, kids. RS configuration in Fisher projection, right? R and S in Fisher projection. Now remember that Fisher projection, first let me tell you, R means rectus, S means sinister. In their language, this means right hand direction. Clockwise, this means left hand direction. Now there are rules, okay? How to find out R and S? Rule number 1. Give number 1, 2, 3, 4. 4 to the least priority group and 1 to the highest priority group according to CIP. According to CIP. CIP rule I have told you, kids. Then this is the rule number 1, kids. Rule number 2. Make an arrow moving from 1 to 2 but remember that while moving from 1 to 2 we cannot cross third priority group, but we can cross LPG. Remembering that we can't cross third highest priority group. But LPG can be crossed, least priority group. I will explain with the example, don't worry. These points I will explain with the example. Rule number 3. If least priority group is on vertical line, then clockwise arrow, then for clockwise arrow this is R configuration, and anti-clockwise arrow it is S configuration. But if LPG is on horizontal line, then clockwise arrow means S and anti-clockwise arrow means R. Why it is difference is there, get see. Whatever I see from my side, whatever I am doing from my side, for you people that will look different. Suppose I am a driver and I am moving the steering in the clockwise direction. Now you see, it must be looking to you anti-clockwise, because I am moving it clockwise. From your side it must be looking anti-clockwise. I am to moving clockwise, but you see, you will say that yes, it is anti-clockwise, right? Now, if you can't remember all these things, Baba is going to give you a trick. Just see Baba's trick. If LPG is on vertical line, then anti-clockwise arrow, then it is S. If it is on horizontal line, anti-clockwise arrow, then it is R. Harendra, very awesome teacher. Harendra, very awesome teacher. My name is Harendra. Harendra, very awesome teacher. Very awesome teacher, Harendra. Can you remember? Then it will become simple, very simple. Then you will enjoy. Now, I am going to start. Okay? Are you ready? Baba is going to start. Kids, do let me know in the chat section. You are ready? Baba is going to start with what, Dr. Gayatri? What you are unable to understand, do let me know. I will make it clear. Don't worry. Just do let me know what you are unable to understand. Ready. Very good. Fantastic. Fantastic. Okay. So, I am going to start it. Okay. Now, see kids. Number one should be given to iodine, number 2 to bromine, 3, 4. This is being LPG. Okay. This is vertical line, this is horizontal line. Sleeping line is horizontal line, standing line is vertical line. Now see, the arrow is moving 1 to 2 clockwise, and LPG is over here. So it is R configuration. R configuration. Got it? If I say, if it is like this, iodine, bromine, chlorine, hydrogen. Now number 1 is iodine, number 2 is bromine, number 3 is chlorine, number 4 is this. Now I cannot move from 1 to 2 like this. I am crossing over this higher priority group. That is wrong. I am allowed to go like this. I am allowed to go like this. This is the right way. So it is going clockwise, and it is over here, R configuration. Now if I write like this, the compound is given like this, CH3 hydrogen iodine OH. Now C, number 1 should be given to iodine, number 2 to oxygen, number 3 to carbon, number 4 to this. This is LPG, least priority group. So 1 to 2 I am moving clockwise, and the least priority group is here, over here. So it is S configuration. Got it, kids, or not? Just to let me know. Everyone got it or not? Do let me know. Everyone got it or not? Till now, is it okay? Kids, do let me know till now you are able to understand or not. Do let me know, kids. Only 10 minutes more. Don't worry, kids. Just 10 minutes more. Just 10 minutes more, kids. It's a game of just 10 minutes more, kids. Till now, is it clear to each and everyone or not, kids? Do let me know. Is it clear? Thank you, kids. Thank you. Saucy is very energetic. Thank you, really, Saucy, Angeline, Pranav, Yararai, Monica, Priyadarshini. Thank you, kids. Really, thank you. Now see, kids. So if this point is clear, that means, let's see, R is clear. Now see R and S in flying wedge dash. But before telling you in flying wedge dash, let's see one thing that will make your work easy. That by making following changes, configuration will not change. With following conversions, configuration will not change. First process, with rotation of compound by 180 degree in the plane of paper. For example, I am having this compound. Now if I rotate it by 180 degree in the plane of paper, then you know south will go to north, north will come to south, east will go to west, west will come to east. Then it will look like this. I have written this by chance. I have written, kids, hydrogen. Hydrogen is already there. Chlorine. So chlorine will come over here and iodine will come over here. Let's see. Let me check it out whether I have written right or wrong. Just see. 1, 2, 3. Arrow is moving clockwise and LPG is on vertical line, so it is R. So according to me, that should also be R. The arrow is moving clockwise. LPG is over here, so it is R. So the configuration has not changed through 180 degree rotating. Everyone got it? Everyone able to understand? Now, the second process. Even number of exchanges. By even number of exchanges. If you make even number of exchanges, then the configuration will not get changed. Just see, This was the compound. If I make exchange of this and this, exchange of this and this, one exchange, exchange of this and this, one more exchange, so two exchanges we have done. So the configuration will not change. Iodine will come over here, hydrogen will come over here, bromine will go over there, and chlorine will come over here. Just check it out whether am I right or wrong. So the arrow was moving clockwise in the least priority group. Here R configuration, and arrow is moving anti-clockwise direction, and least priority group is over here. So R configuration, both are being R configuration. Clear, kids? Let me check it out whether you are getting or not. Everyone do let me know. Everyone, you are able to. Thank you, Sausi. Thank you. Everyone is able. Baba will complete. Baba knows very well that whatever the situation, whether Baba is able to stand or not, but Baba will complete. Baba will complete. Baba will definitely complete. Kids, do let me know. Everyone, till now it's clear or not? Thank you, Lakshita. Thank you. Your time, your rank matters a lot to Baba, kids. You people holds a hell lot of weightage in Baba's mind. Praveen, thank you. Now third one. Third conversion. Hold any one and rotate other three. Hold any one and rotate other three. Configuration will not change. For example, iodine, bromine, chlorine, hydrogen. So whom you want to hold? Let us suppose chlorine is on hold. So chlorine on hold. So chlorine will remain over here. Now rest of the things you can rotate either clockwise or anti-clockwise, and rotate either clockwise or anti-clockwise, doesn't matter. Configuration will not change. Let's suppose, let's rotate them clockwise. So iodine coming over here, bromine coming over here, hydrogen will come over here. Let's check it out. Am I right or wrong? This is moving clockwise, this is over here, so R configuration, and see over here, this is moving anti-clockwise, but hydrogen is at this place. This is also R configuration. So this much is clear. Now let me tell you, in flying wedge and dash, it will take 2 minutes. Once you are able to understand this, it will just take 2 minutes. Kids, for Sausi, Baba, they are the best students. Yes, these students are really, these 49, 50 students, 54 students are the best. I will say thanks from the internal core of my heart that you kids are really awesome, really awesome. Really awesome, kids. Now, see. See, kids. Flying wedge dash. R and S in flying wedge dash. Suppose if anything is attached like this, this means coming towards your side. Going away from you. in the plane of paper. If I say iodine, bromine, chlorine, hydrogen. So remember that, write down 1, 2, 3. And remember that if least priority group, that is fourth number, is on dash line, then for clockwise arrow R, anti-clockwise arrow S. And remember that if it is not on dash line, if, see, board is not working, board is writing in delayed time, not, if LPG is not on dash line, then hold anyone, and rotate other three, so that it will come over there. Now see, arrow is moving anti-clockwise direction, and this is over there LPG. So this is S configuration. Done and dusted. Now only capital D, capital L, 2 minutes for capital, 5 minutes for capital D, capital L, and 2 minutes for 3O, I3O. So within 10 minutes I will complete, okay? Within 10 minutes. So don't worry, kids. Hardly 10 more minutes, kids. Wow, thank you. Hardly, kids. Hardly 10 minutes, kids. Not more than that, kids. And really thanks to you, kids. Thank you, kids. Now, see, kids. Now, capital D and capital L configuration. Capital D and capital L is being used in carbohydrates and amino acids. Let's see in carbohydrates. And remember that you have to see the last and second last carbon. Focus on last and second last carbon. So if you see the compounds, IUPAC will start from here 1, 2, 3. And if we see the last and second last carbon, where are they? These second and third carbons, last and second last carbon. If they are found to be on same side means it is capital D, D-glyceraldehyde, D-glyceraldehyde. And they are found to be on opposite side, then we will say L. They are found to be on opposite direction, this OH over here, this OH over here. So L-glyceraldehyde, right? Same like if I write for glucose, then also D-glucose, L-glucose. So it's simple. Now if I talk about glucose, just see In glucose also, what you are supposed to see? Now see, last and second last carbon, you see last and second last carbon, the OH, they are on same side, so we will say it's capital D. And glucose, so capital D, in nature it is found to be dextrorotatory. Capital D has nothing to do with dextro, but nature dextro. Glucose. These are also on same side, just see. So capital D, mannose. Now if I talk about these two compounds, there is difference in the second carbon's position. So these are apimers, only differing at one carbon, they are known as apimers. Now if I write down this one, these are also on same side. So capital D, this is known as galactose. Galactose. Now my dear friends, it is differing at this carbon, fourth carbon. It is differing at second carbon. Now many of you are must be having that confusing that how to find out which one is galactose and which one is mannose. Remember that nose is at the top, nose is at the top, so mannose, and toes are down, the down carbon different than toes, up is different than nose and toes. Just remember nose and toes. Kids, are you getting my point? What do you have to remember? Nose is at the top different than nose, lower side different than toes. Show me in the chat section that you are getting it, kids, how to remember toes and nose. Kids, do let me know. Do let me know. That how to remember that. If it is clear, then do let me know, kids. Yes. Everyone just do let me know. Now this is okay. Now let me tell you R and S in amino acids. Okay. Now who is apimer, kids? Remember that glucose and mannose. Don't get confused. See, this is A, this is B, and this is C. A and B are apimers. A and C are also apimers. But B and C are not apimers. Why? Because they are having difference at 2 carbon. The difference in the orientation of OH at 2 carbons. So they are not apimers. They are just diisomers. So B and C are diisomers only. They are not apimers. Now, in amino acids, remember that all amino acids are optically active. Except glycine. The amino acids molecular formula, structural formula, you can say NH2 CHR COH. So everywhere you can see this is being chiral carbon, but in glycine this R is hydrogen. Once the R is hydrogen, it can't be the chiral. That's why, my dear friends. Now, how to find out the amino acids are R or S, then D or capital L? How to find out? Just see. If the configuration of amino acid is coming R, then we will say it is D, capital D, and if it is coming S, we will say it is capital L. But remember that for this, the COH group, this COH group must be present at second number according to CIP rule. According to CIP rule. If it is not present, then generally it will not be asked, but let me tell you, if it is not present, they are not going to ask this, but it is there. If COH is at third position, then R will become L and S will become D. But it's not important, this is important. This is very, very important. Now see, kids. Now let's see what is the meaning of COH at second position. Just see CIP rule. Nitrogen is on the first number and C is on the second number, and this is at the third number, this is at the fourth number. Arrow will move like 1 to 2 will go like this, anti-clockwise direction. And this is over here, so it will become S, so it is L amino acids. Now only trio and erythrio is left. Trio and erythrio, kids. Till now everything is clear. Do let me know, kids. Only trio and erythrio. It is going to take 2 to 3 minutes. 2 kids informations. Baba cooked. Wow. What is this? 2K kids. Good. What is this? Now kids, now the time is to tell you trio and erythrio. That's it for then today. Baba is going to tell you. Yeah, even I am tired. Just let me complete trio erythrio 2 minutes. Then we will go back to home. Oh, I have to go back to home. Right now I am at the office. I have to drive for 1.5 hours. My home is far away from the office, kids. Baba has to drive the car. Then Baba will go to home. So kids, 2 minutes only. Oh my God. 2 minutes only. Now see, trio and I write through. Last topic, trio and I write trio. Yeah, yes, I have to do that because Baba is also, yeah. Champa, where are you, Champa, my assistant? Give me energy. Yay! Yes, now I can teach for more next 12 hours. Don't worry, kids. Don't worry. Baba has gained energy. Baba has gained energy. Baba has gained energy. Now see, kids. Baba has gained energy. Now see, kids. Trio and I write trio. Now see, the name itself is saying the answer. Name itself is saying the answer. See, if the same type of groups, they are going opposite, same thing going opposite, trio, and the same things are on the same side, a right trio. Got it? Are you getting my point, kids? Name is already giving the answer. The answer is hidden in the name, right trio. Same things on same side. Now see, in the E, these are on same side, right? It's got it, and they are being on different sides. Are you getting my point, kids? Do let me know you are able to understand trio and I trio. Kids, do let me know you got it or not. Everyone, do let me know you got it or not. Kids, you got it or not? Now, kids, one thing is left, racemic mixture. Let me tell you racemization, and then I need your 3 minutes more, kids. Can you give? Then I can tell you racemization. Just 3 minutes more. Can you give me your 3 minutes? Just 3 minutes. Let me tell you racemization. Suppose if we allow the light, plane polarized light, to move through solution of lactic acid, solution of lactic acid. Now if I say that in this 60% is dextrolactic acid, 40% is being levolactic acid, then 60% will rotate towards clockwise and 40% will rotate anti-clockwise. Then light will be seen rotating towards anti-clockwise direction. Can anyone tell me why? Light will be found to be moving in anti-clockwise direction. Why, kids? Because the 60% will kill this 40% and 20% we will say this light is rotating because enantiomeric axis. Now I think you are not able to understand enantiomeric axis. What is enantiomeric axis? Let me teach you. If I say 60 milliequivalent of acid is there, 40 milliequivalent of base is there, then neutralization will take place, but acid will left behind because that is in axis and this is the limiting reagent. So that will left behind. So enantiomeric axis will rotate the light in the clockwise direction. So neutralization has taken place. Just like in acid base we say neutralization, here we will say racemization. What will we say? Racemization. But here is partial racemization. Partial racemization is there. Are you getting my point? Partial racemization. And this is happening in between two different molecules. So we will say external compensation. External compensation. But if I say kids, because this is going to help you in SN1 and SN2 reaction. If I say the same plane polarized light was allowed to move through another solution, but this time here the mixture was of 50 and 50. 50% dextro lactic acid, 50% levolactic acid. Now the light will not move any direction because there is complete racemization. Complete racemization is there. Are you getting my point, kids? Now what is the difference between complete racemization? This mixture is still optically active because of enantiomeric axis. This mixture is still optically active. Still optically active. That's why it has rotated the light some direction. In some direction. But this is optically inactive. Now one more case arises. If this is 40%, this is 60%, then the light will move in the anti-clockwise direction. I hope that kids, everyone got it. Let me see the chat. Any doubt? Do let me know. Then I will say good night, good morning to everyone. Tell me, kids, any doubt to anyone? Any doubt? Anyone's any doubt, kids? Do let me know, kids. Okay. So, kids, take care. Everyone, take care. Thank you so much for the wonderful lecture. Each and every concept are clear. Also good revision, no words. Thank you, kids. But if possible, after the lecture, whenever you get time in the morning, kids, You have to write down all these things in the comment section, right? Yeah, in 50-50, Praveen, the clockwise direction will cancel out anti-clockwise and mission accomplished. Yes, Baba is really feeling accomplished. Yeah, yes, Sausi, sure, Sausi. Kids, I've completed, I haven't left even a single thing, kids. Thank you, Sausi. I haven't left even a single thing, kids. Sri Lekha, thank you, Sri Lekha. Really thank you, Sri Lekha. How I have completed only I know, because in the morning I have class from 9 to 11, then 12:30 onwards offline. But anyhow, I haven't left anything. It's Baba has explained each and everything in detail. Baba has not left even a single thing. Monica Priyadarshini, thank you. Pramod Movies, you are really gem, kids. You are at the last, kids, up to the last, kids. Pranav, Yara, Angeline, Raki, Veera Level, Baba, thank you. Dr. Siddharth, thank you, really thank you. Rana, thank you, really thank you, kids. I have no words to say. I will pray to Almighty God that Almighty God bless you with all happiness and prosperity along with the best rank in the coming exam. Ahmad, Hanzala, thank you. Praveen, thank you. Sure, Praveen. Sure. What to say? Sri Priya, oh Sri Priya, you are there still. Gayatri is there. Saran, thank you. 2K Kids information, thank you. Dityakana, Balaji, Daniel, Shanu is there. Okay, bye to all of you. 52 True HSPN. How to say thanks, kids? I have no words. Baba is not having anything to say, kids. What to say? Love you, kids. Love you. Yes, Gayatri. My class is in your class only now, Gayatri. Dr. Gayatri, my class is in your class only now. Next chapter, I don't know. I will tell you. Sausi, today Lafia rocked. Yes. Queen of this lecture, yes. Monica Priyadarshini, same here. Love you all, kids. Love you all. Everyone. Next chapter I will tell you tomorrow or day after tomorrow, Dr. Siddharth. Yes, Phoenix Pro batch, okay. Bye, kids. Bye. Good night, everyone. Good night, kids. Bye to all of you. Manasa, good night. Parkavi, bye. Tamiz, Sarasu, bye. Soumya, thank you. Hiron Lafia, thank you. Sri Priya, thank you. Good night, kids.
Good night, kids. Good night and bye bye. Take care, kids. Have sound sleep, everyone. Okay. Baba will pray to God to make you healthy, wealthy, and wise, to give you more energy. Yeah, I will drive slowly. Yes, I will take care. You kids are so good. What to say, kids? Lovely kids, really. Bye, kids. Bye to all of you. Bye bye. Good night, kids. Good night. South CHSP, and thank you, thank you, thank you. Bye, Harun Lafia, Monica, HSP and Army Doctor Gayatri, Raki, Harun Lafia. Bye, kids. Bye. Bye to all of you.